Welcome, welcome everybody. We're about to get started soon. So if you're able to, please take a seat and we're going to get the summit underway. All right, so first of all, welcome to the second edition of the Open AGI Summit. We're absolutely thrilled to be able to bring you a day full of panels, keynotes, lectures on decentralized AI, with conversations from the foremost thinkers in this space. It's going to be a great day. Today's conversations are going to revolve around how blockchains and artificial intelligence can interact with each other to make more just and fair technologies. We're going to discuss things like what it actually means to bring AI on-chain and debate the pros and cons of making AI more decentralized. Before we start, however, I want to go through a little bit of housekeeping. So for the next 7 hours, we're going to have 2 rooms running in parallel. This room that everybody's in, this is the main auditorium, and in it we're going to have our main panels as well as keynotes running roughly every 30 minutes. And then just outside and down the hall is the cinema room, in which we'll have our research talks. And those are more technical lectures from leading founders in this space, who will be presenting their research at the intersection of crypto and AI. And right before we start, I'd be remiss not to say that none of this summit would be possible without our amazing sponsors. A huge thank you to AWS, to Sentient, to Polygon, and EigenLayer for your support of this event. We thank you very much for being able to have our second summit here in Brussels. And now, without further ado, I'd like to welcome our first keynote speaker. We have Ilya Polosykhin. He is the co-founder of Near, and he will be presenting his talk, Securing the Future Internet with AI. Welcome, Ilya.
Okay, thanks everyone for coming. It's great to have an event starting at 12, not at 9. Especially on Sunday. So I hope everyone is well rested, especially given it's Brussels, everything closes at 5 p.m. anyway. So let's kick it off. If we have slides loading, I think we have AGI faster than we have AV working. Cool, so for those who are not familiar with me, I originally was AI researcher. I worked in machine learning space for about 10 years. Before diving into crypto rabbit hole. And I worked at Google Research on natural language understanding. From my perspective, natural language is where most of the knowledge, of the world knowledge is lying, as well as where we're able to really test the intelligence of the machines we're building. And so I joined Google Research to really make progress there. And it was interesting because we had built really interesting models in 2014 and 15, and we were not able to put them in production because Google has very high latency requirements, and the models we had were too slow. They were trying to read all the search results to do that. And so the Transformers technology, right? The technology that's powering right now ChatGPT, it's powering Midjourney and Gemini, Llama, etc., was invented really from this challenge where we could not get something in production. We needed something that was able to process lots and lots of documents, lots and lots of language extremely quickly in parallel without blocking on reading every word. And so that's what the work of Attention Zone You Need introduced in 2017. Now, I left Google because I wanted to make progress on not just research, but also putting that into production. And we started Near AI, the AI company, in 2017 that was teaching machines to code. And this is relevant because I think this is one of the most important technologies that humanity can build right now. And I'll explain why. Now, back in 2017 and beginning of 18, there was no scale that we're looking at right now on compute, and obviously we're a small startup, and so we were trying to be smarter. We engaged a lot of students around the world to help us with crowdsourcing data. They were pretty much in China, in Eastern Europe, in Southeast Asia, Some of them didn't have bank accounts. Sending money from US to China or Eastern Europe is also complicated. And so we actually started looking at blockchain as a solution to our own problem. How do we programmatically pay people around the world without needing to kind of overcomplicate things? And that's how Near Protocol started. And obviously, fast forwarding now, the most used protocol by number of users. And the way we framed the vision is that we want all people to control their own assets, data, and power of governance, right? And this is not just kind of the Near vision. It's really a broader Web3 space vision that we're trying to kind of put together and align resources across all of the projects that are working in this space. And importantly, it's not just about assets, right? A lot of the blockchain kind of original talk, right, DeFi, et cetera, NFTs as well, were all about assets. But even in 2019, we kind of clearly saw importance of ownership of data, as well as power of governance, power of choice, power of being able to choose kind of your journey, not being able to not be dictated by the kind of centralized providers. Now, the new reality with generative AI is that the big technology companies are kind of accelerating this state where they're amassing more and more power. They have a very kind of direct economy of scale where the more attention you spend on them, the more money they make. The more money they make, the more they can invest into pretty much advancing machine learning models to get you to spend more time, right? It's a very kind of negative flywheel for the users and positive on making revenue for them. It also breaks kind of other business models, right? Now, you don't need to go to search results at Google. You can just get an answer that summarizes all of the articles, right? They're just buying data now from other kind of social networks, pretty much turning them into just a data provider, not a platform itself. Same with publications. We're going to see that all transforming. And obviously, all of that breaks trust that we kind of create because the algorithm, like the most engagement and attention you can get out of users if you show kind of different kind of things that enrage you and in turn kind of erode this trust that people have in systems. Now, we're on track for these few major companies to pretty much control all of the humanities intelligence tools, right, if this flywheel continues. And the regulations are not going to be helpful here, right? The regulators will be one way or another engaging directly with these big companies, and these big companies will find a way to really dictate what they want. And especially it will limit what open source and kind of startups are able to do because they don't have resources to comply with this. And we see this already happening, right? There's a kind of a war, like a legal war is unrolling, right, where everybody's suing Google and OpenAI in different ways for data, for monopoly, for everything. And this is going to continue because the current legal framework is not able to really keep up with the generative AI. Like, it is fundamentally different technology. It went from the attention economy to kind of this recombination generative economy, and you need to change the regular framework as well. Now, the problem I wanted to talk about today is actually a little bit different problem. And this lies in the fact that all of our systems, all of our software that's currently now running the world is written by people. And people are not perfect, right? On average, we have 15 to 70 bugs per actually, this is a typo, per 10,000 lines of code. And there's 86 million lines of code in macOS, right? So this is like over 1 million bugs in macOS itself, right? Then you go to the underlying networking stack. You have things that running on switches, et cetera. Point is, we have a fundamentally broken whole stack of our kind of internet operating systems and browsers and applications we're using. And the bigger problem is that AIs are really good at finding them, right? The LLMs are trained on kind of finding, on the statistical, like looking at all the code, and they're actually pretty good at finding things that are like outliers from the normal statistical distribution. And so they're able to analyze and give you potential vulnerabilities now if you point them at specific code base. And so they will be able to find zero-day vulnerabilities. These vulnerabilities will be exploitable by malicious actors. And this is not the doomsday of AI becoming sentient and attacking us. It's really about the same thing that's been happening where hackers are using advanced tools, but now they can do it at scale. So there's research now on using teams of LLMs pretty much to exploit zero-day vulnerabilities. There's been some research from University of Illinois, but this is kind of generally advancing pretty quickly, right? So this is just to give you an example. You get a bunch of agents that are able to probe for different types of vulnerabilities, and if you kind of pipe them in the right way, you can find like 30 to 60% of the vulnerabilities that exist in a code base that people have found. Now, what I did actually, because I was thinking about this even before I saw this paper, I was like, can I find a vulnerability? And so I went to the security vulnerabilities registry, right? There is a place where all of the issues are reported, and I found something that was like a week ago, right? So it's clearly not in the training data. And so this was a vulnerability in Go compiler that would allow to escalate pretty much permissions on a networking stack. So to give you an potential impact is if you're running a Geth node, right, for Ethereum, and you have an RPC that is only accessible locally, right? Through this vulnerability, you can actually, from remotely, to get access to the RPCs that are only available locally. And some people actually have a private key embedded in that RPC because they use it for maintenance. So you can actually get, quote unquote, root access to your private key in the Geth node through this vulnerability, right? So, small problem. And so obviously, the fact that it's published, it's already patched. So there's a patch. And so I took a code that was before. I took the networking module of Go compiler, and I put it into ChatGPT in this case, and I prompted a little bit, you're a best security engineer, and you know how to find vulnerabilities, and list every function and look at what is the potential issues there. And it literally found exact same vulnerability and explained it and gave me a specific IP address that if you put in would actually break into the, through the permission check. So this is just an example of the current state, right? I'm not talking about the future. I'm not talking about, that, like this model is going to evolve. This is a current state where you can use them now. And if you have a proper setup where you can test them at scale, you're able to start breaking software right now. So the core idea here is that we need to rebuild the internet from ground up, right? It sounds a little bit ridiculous, but the reality is we don't actually have an alternative. Like every single line of code that's written so far has bugs, and there's no way for us to actually inspect that and make sure that we know all the bugs. Like even if you had audit, even if you had a bunch of people reviewing it, there's still maybe vulnerabilities that are not covered. And so we need to rebuild the internet from ground up in such a way that we can ensure that it is correct, right? And so this is where kind of the bigger vision we outlined for NEAR of user-owned internet really comes from. It's really combining the Web3 tools that we've been developing for years and years now of user ownership, of cryptographic systems, of incentives, of really connecting people in a different way, as well as user-owned AI to optimize for user ownership, for privacy, and kind of enable customization, right? That's a new internet we're building. But the fundamental part, right, of this vision is not just that, hey, we have new capabilities and new values, but we also need to rebuild the old internet, otherwise it's completely broken. And so how do we do this? Well, we need a cryptographically security. We need formal proving, right? So for those in crypto, you've probably heard of formal proving. This is really, when you're writing code, you're also writing a proof that this code is actually following specific requirements, right? For example, it doesn't lose your tokens, right, when you transfer them. It doesn't, change ownership of any assets without explicit signature of the asset owner, right? So we need a way to actually verify that every single line of code is actually following specific requirements. Now, the cool thing about this is actually it's kind of similar to ZK proofs in the sense that if you have a piece of code that has a formal proof, if you put it in your code base and you have your set of specifications, it will actually not work if there's anything breaking, right? So you don't need to validate yourself the proof for every single submodule. You can actually grab submodules that have proofs and plug them into your system. So this has like a very nice properties of composability of code that right now, if you're grabbing an NPM package from internet, you have no idea what kind of vulnerabilities and attack vectors you're actually exposing yourself to. And this is literally all of internet runs on that right now, on just a bunch of NPM packages. And so Web3 is a perfect testing ground for all of this, right? Because we have smart contracts that need to be correct. We have a lot of actually kind of security tooling that's been built already around formal verifications. And we obviously have kind of, in a way, an insurance pool, right? When people are using this smart contract, there's money. So there's enough like interest to make sure that these things are correct and not breakable. So this is really where this thing's coming together. And now at Near AI, we're specifically working on what we call AI Developer. AI Developer starts with, I want to build a specific application in Web3, and it generates you a specification, right? This is kind of, for those who are not developers, this is kind of the intermediate document that usually your product managers or tech lead would write to explain what product you're trying to build. Now, this is AI generated. You can talk to it, you can refine it, you can tell which features you want to add or remove, and what specific flows it should take. Right? And then it goes and writes a code for you based on the specification directly from AI. This is smart contract, front end, and middleware to connect them. And smart contract then needs to have this formal verification kind of coming with this. Ideally front end as well, but this is a little bit further down the road. So I just want to finish with this idea that we're kind of at an interesting point in the world, right? We have kind of centralized parties that are developing kind of closed source, closed AI models, which are used to put in front of us to really kind of attract, use our attention to convert to money, right? That's really what these companies are doing. That's their business model. And it's all built on kind of house of cards, right? The number of vulnerabilities that are being found, like there's a new SSH vulnerability that was just found, for example, which gives you root access to every machine, right? There was somebody trying to sneak in a vulnerability in SSH, in a tar library or in archival library that if that went to mainstream, every SSH would be vulnerable when an attacker attacks with a specific key, right? This is like the world we're living in. Is there's a constant kind of malicious systems attacking everything. And closed source, by the way, doesn't help. The fact that you're like, oh, my software is closed source, so nobody can attack it. The reality is like the fact we know these things about SSH is because it's open source and there's 10 million people looking at it one way or another, inspecting it. Like the reason why that archival bug was found is because somebody noticed a 20 millisecond delay when they were testing their deployment. 20 millisecond delay, and they're like, oh, something is wrong here, let me debug it. And they found there's a piece of vulnerability code was injected during the archival. So we are in a very weird state where we really need to work hard to not end up in a state where everything is exploited, including us as individuals through these big companies, but as well as our systems in the world, our kind of tech systems through this kind of finding vulnerabilities and exploiting them. And instead, we need to build kind of a new internet, right, that is based on cryptography, that's based on formal proofs, on math, and on focusing on the user, right, user-owned internet. So I'll just leave you with that. Hope this is, good opening, and I didn't scare you too much. But thank you, and keep track of progress on Near AI, on what we're doing, as well as we're going to be, we have this office hours actually on YouTube where we invite both Web3 and Web2 kind of developers and founders to talk about kind of recent advancements in this space. Thank you.
Okay, next up, we are going to have our first panel of the day. This panel is titled Open versus Closed AI, and it brings with it Mark Rydon, co-founder of Aether. Sewang Oh is a core contributor at Sentient and a professor of computer science at the University of Washington. We have Sunil Srini, who is a founding member of Ritual, Matthew Wang, co-founder of Valence, and moderating this panel, is Anand Iyer. He's founder of Canonical Crypto and a venture partner at Lightspeed. Let's welcome them to the stage.
We've got a nice crowd here. I like this. Oh, are we missing a mic? You guys want to? I can also pass this down if needed. All right, sick. Excited to kick this off. Thanks for, first of all, thanks to the team for having us here. Let's just blaze through, we'll do some quick backgrounds just to level set your experience. The theme is to talk about open versus closed. But let's just kick it off with a quick round of intros, backgrounds, and my ask is like, I was telling backstage, and maybe something punchy, something that's like, I know you just got off the plane, by the way, but something that's like top of mind for you as it pertains to this panel. But how about this? We'll start with you, and then we'll work it on, because this guy just literally got off the plane. But Siwang, you want to kick it off with some intros? And
Sure. Hi. I wear two hats here. One is I'm a professor of computer science at Allen School at University of Washington, and the other hat is I'm directing research of AI at Sentient. So I am interested in open source in many ways. One thing I want to kind of point out is we are running a huge open source data set competition at UW. We run several rounds of it now, and it's been very exciting research direction to provide data sets that can achieve the closed and black box models that big techs have with the data set that can achieve these performances. And that's been, I think, most exciting part recently in open source for us.
cool. Thank you.
Awesome. I'm Matthew. I'm the co-founder of Valence. And my personal background is a little bit of in HCI research, ML research. Spent some time doing small stints at big tech companies like Google and Facebook. Most of my professional career was doing research engineering at a quantitative hedge fund called 2 Sigma, where I worked on the quantitative modeling side, research engineering side for an equity options desk. And at Valence today, we spent a lot of time thinking about how to bring more of the world's compute on chain in the form of model-driven workloads and compute. How to bring kind of functions that help people run model-driven compute workloads, like simple regression, analysis, interpolation, all this stuff on chain to help empower the existing state of Web3 compute.
I've got my own now.
Okay, awesome.
So Mark here, co-founder of Aether. At Aether, we build decentralized GPU infrastructure for AI and gaming companies. The big focus for us is enterprise-grade GPU infrastructure. So everything that's committed to Aether's infrastructure, all kind of 43,000 GPUs, are enterprise-grade. They're sitting in data centers or connected to enterprise-grade network infrastructure, all kind of perfectly suited and built for enterprise-grade kind of workloads from an AI perspective, or we also do a lot in the kind of cloud gaming and cloud publishing side. My background's in infrastructure building. I've kind of started in the oil and gas and power space, building large infrastructure projects before transitioning into cloud infrastructure, which kind of led me to where I am today.
Hi everyone, I'm Sunil. I am not Niraj, the founder of Ritual, but I am a founding member at Ritual. Ritual is aiming to bring models on-chain in a way that's accessible to developers across the world. So we have two phases, one of which is live and complete, which is sort of the first network AI Oracle network of its kind that allows developers to access use smart contracts to access models on-chain. And we're now heading into our phase 2, which is the Ritual chain, which will be its own sort of sovereign layer that adds a bunch of functionality to an EVM-compatible VM that will allow you to essentially use models atomically, right? So, Matthew mentioned a lot about, regression models. So anything from like classical supervised learning models to, LLMs and things that are more savoir-faire today to build applications around them. And the goal is to allow anyone to write smart contracts over models in the same way that Ethereum allowed people to write smart contracts over this, sort of shared state machine. My background is a mix of crypto and AI. I previously was on the founding team of a DeFi protocol, and I've been on the investment teams over at Dragonfly and Polychain, along with the investment team at Accomplice as well. But before that, I was actually doing a bit of ML research over at Berkeley, as well as doing ML at Lineage Logistics, which I don't expect anyone to heard of. But if you ever had anything refrigerated in North America, it went through their warehouses. So I was in charge of writing algorithms to make sure they got places very quickly.
Cool, thank you. All right, I have some questions here, but if anyone else has questions for this panel, please get it ready. We can improv a little bit and go to the audience. But to start off with, I'd love to understand from you folks, what is it that we think is necessary for open source AI to really dominate and for this to become sort of first nature for us, right? What are the barriers that exist today? What is the current landscape as it stands right now? And maybe the second bullet point here is also, how do you think about open source? Because it's like this, the way we think about open source when it comes to code is one thing. When it comes to models, weights, it's a different story altogether. So yeah, just in terms of how do you look at the landscape and what do you think are the barriers for us to for adoption of open source AI across the board? Is it okay if I start with you, Sunil?
Sure, yeah. I think that the question of adoption of open source and how I think about open source goes sort of hand in hand, right? At the end of the day, I think models are fairly, in themselves as units, right, are not necessarily fungible, but we currently see that the state of the art is consistently dominated by a few players that generally are closed source or tending towards closed source. I mean, even Meta was like, okay, we're not going to make our models free forever, right? But it is the case that whenever an open source model comes out, some lab or some hacker out there is pretty good at either, or a closed source model comes out, is pretty good at distilling something that gets a pretty decent functionality. Which is all to say that ultimately the only really good way to disseminate all of this is the end utility to builders, right? So if there's a combination of a model being cheap enough to run, or customizable enough in certain cases, right? There's a lot of consumer cases that want to take open source models and fine-tune them for their own needs. But if there's a case of a model being cheap enough to run and good enough for the use cases, I think that any marginal addition or any marginal improvement in things like perplexity or whatnot, right, doesn't matter to the end consumer. So when asking how does open source win or how does it compete with closed source, I think it really just comes down to those three dimensions, right? If you can make them cheap, run good enough for the task that's willing to do, right? Most use cases are never going to touch, most consumer use cases especially are never going to touch the complete upper bound of what OpenAI's GPT-4o can do, even though it is very, very powerful, but people definitely default to it because it's cheap to run. But there's plenty of distilled or models that are good at running on more constrained devices for cheaper that can do most of what a AI companion chatbot would need to do, right, for example. And then the question of open source is really, really interesting because, within open source itself, within software, we've seen a trend towards BSC3 licensing, right? This code is open source, but if you want to use it, you better give me something, otherwise, I have grounds to. With AI, it's much harder because, you can go and maybe trademark or whatever patent weights, right? License model weights, but you can also just slightly tweak the model weights and say that they're different, right? So I think that there definitely needs to be a big push for, I think, fundamental research around watermarking. There's a few schemas already, but I don't think they really deal well with non-determinism in models, or how do you account for minute differences that still yield differences in outputs, but are basically the same model at the end of the day. That's a really big unsolved problem. I think that'll be really, really important for unlocking the ability to monetize open source using crypto rails.
Yeah, that's a great take. And I'm going to maybe zoom out a little bit, right? I think for open source AI to win, right, I think there needs to be a recognition that open source AI is a pretty fragile space, right, in general, right? You've got, OpenAI started as a not-for-profit, earned a little bit of money, and now they're not open anymore. You've got Mistral, for example, right? They open source their smaller models, but Mistral Large, they don't release. You have an entire ecosystem, right, within the OpenAI space that's largely built on the release of Meta's latest model, right? If they pull out of that open source kind of ideology, right, I'd imagine the whole space would be set back, quite considerably. So I think that to be honest, the open source AI sector is really heavily reliant on a very small and very fragile set of contingencies, and that, to be honest, needs to be heavily addressed for us to ever get to a point where I think that that open AI or open source AI can compete long term.
Can I, just to piggyback off that, and I wanted to ask you both this, which is closed source, OpenAI, and others. I mean, OpenAI has been in the works for a long time, but these models like that are closed source in nature have moved really fast, right? So if you just look at, if you just, again, to zoom out, look at the progression of like closed source versus open source, right? You look at Microsoft versus, Linux, you look at iOS versus Android. It feels like the polish comes with closed source. Open source lags a little bit. How do you think about that when it comes to utility and things of that nature, Matt?
Yeah, so I think right now, like times have really changed a ton, and things have rapidly advanced, especially in the AI sector, right? When like Stable Diffusion first initially was open sourced, it was very different because they essentially were operating under the idea of, hey, we're going to put out this like open source model, and people are going to try it out. They're going to deploy on-prem, and once enterprises realize, hey, I actually want this model to be productionalized in some way, shape, or form in some kind of service, then they would contact Stability AI and have them essentially in a consulting capacity to build this for them. But now today, there are so many kind of tools and services and open source software that people can leverage to kind of fine tune and deploy these like AI models. So I think that like becomes the kind of tool that like the open source AI models are closely integrating with, where you now, instead of having, with closed source, you can just directly make an API call, but with open source, you now have access to, the transparency around the weights, and you have all these tools that you can use to fine tune the model. Becomes this kind of ability to allow open source to compete and slowly catch up with a lot of these closed source solutions. And I wanted to build on a bit on what Sunil had said about kind of watermarking as a way for like security for models as an example, or for IP, right? I think like like the people at Meta put out a great paper on what they call like stable signatures, which is essentially this technology that you would embed in a decoder for a diffusion model that would essentially would embed some cryptographic signature into the image it generates that's completely naked to the human eye, but is algorithmically detectable. And the kind of nice thing about that is we are now able to run simple algos that can detect, hey, was this content generated by AI, or was it generated by a camera or some human? And that introduces some degree of safety and transparency to the world where people are generating tons of fake content. But now I think just to play devil's advocate a little bit, if you open source these types of models, people can suddenly hot swap the decoder and be able to kind of remove the component that embeds these signatures. So I definitely think it's like a careful balancing game when we think about open source versus closed source, where it's like a series of trade-offs today, where with closed source you have like these huge enterprises that are willing to kind of like support you and also can embed technologies such as the signatures. But with open source you have a high degree of composability, but kind of less guarantees around safety, albeit with more transparency.
What do you think? You straddle sort of both worlds in some ways. And
Yeah, I think I agree with Matt quite a bit. So I think he pointed out something nice, which is that the landscape or ecosystem of AI is quite different from other examples that you mentioned. It's moving so fast that there's room for everyone to contribute. For example, we ran open source projects on CLIP models, which is multimodal models between image and text. And OpenAI came up with their CLIP model, which is completely hidden everything. And we were able to just try to match their performance. That was our goal initially, collecting data, filtering data, and coming up with simple training schemes, but mostly innovating on the data filtration to aim to match their performance. In the end, the open source project we ran ended up performing better significantly than the original CLIP model. So it's an ongoing conversation between open world and the closed world, trying to beat each other, but in the process, innovation comes up, and I think there's room for both worlds to help each other be better.
I just wanted to, just one sort of follow-up question there. Because I think some of the chatter that exists today is that a lot of folks who put, I mean, let's take Anthropic, Mistral, OpenAI, with their models, I feel like sometimes they like to parade the performance of their models relative to some benchmarks they really care about, right? So it looks really good. So when you say they perform well, can you elaborate? Can you zoom in on that a little bit more?
Right. So this was these models are typically evaluated on ImageNet with zero-shot accuracy.
Sure.
So that's the kind of the performance you care about. And then if you want to add another axis, you do it on distribution shifted versions
Yep.
of ImageNet and look at the robustness. So those are the two axes that we care about. Performance-wise, ImageNet mainly, just because it's what everyone uses, but zero-shot. And then there's a robustness metric. So in both, we are interested in, and in the ImageNet performance, I don't know the numbers top of my head, it's been a year, but we beat, with the open source model, the original model that they came up with from OpenAI.
Thank you. Yeah, it's helpful. I wanted to switch a little bit because you folks have incredible backgrounds. You've been thinking about the problem space probably a lot longer than some of us have. And maybe Mark, I'll start with you. Having spent time building Aether, like what are some earned secrets? What are things that you have learned along the way as it pertains to, I mean, specifically with open and closed source, with scaling, with GPUs, things that, if you had to tell someone else, like if you had to go back and talk to Mark from a year ago, like what are some things that you've learned that have been helpful to you, or mistakes or pitfalls that you want others to avoid?
I think in general, AI benefits so much from centralization, right? Centralization of resources, centralization of capital, centralization of compute or data sets. So I think building anything truly decentralized in AI is like a challenging take. In compute, in some ways more challenging, right? Co-location of GPUs is critical, right? How do you solve the co-location problem when you're building from decentralized compute infrastructure? So I think we did the right thing early on, focusing on enterprise-grade compute. I think there's a definite long-term advantage or long-term potential in unlocking the latent compute that exists on the edge, that exists in kind of consumer compute. But I don't think that's a problem that I hope someone else solves, right? Not necessarily Aether, and I'm glad that we didn't choose to solve that problem. I think what I would have probably encouraged myself and the team to focus on earlier was, okay, if we're building enterprise-grade compute, right, we're obviously limiting the type of participant that can engage with our ecosystem as a hardware provider, right? And one of the great benefits of DePIN, right, is that you onboard community that are really intrinsically motivated to have your network succeed, right? Because they're contributing hardware and they earn as a result of that contribution. So it took us quite a while to kind of solve that challenge. We ended up solving it with this checker role that we established within our network. It's essentially the police force of the network. It's like a validator on steroids, and it doesn't necessarily require someone to have a high amount of compute power. It doesn't require them to have an enterprise-grade GPU infrastructure. But what it did was allow us to kind of decentralize a critical role within our network and give more access to the community to kind of participate and contribute valuable work within our ecosystem. So I think for us, recognizing that despite the fact that we were really motivated to contribute to this kind of decentralized AI ethos, but also recognizing that early on, some of those advantages will come from kind of some form of centralization, but still focusing on what areas of the business that we can control, where decentralization does make sense without kind of just hamstringing the business as a whole.
So progressively decentralized, focus on something that works, and then build decentralization on top. Sunil, what about you? Any earned secrets?
Yeah.
You've been an investor as well, so you've seen,
Yeah. It's been an interesting. Yeah, we've co-invested in a ton of stuff. It's been an interesting thing seeing this both as an operator and investor. But I'll say this. I think what you said hit the mark around that. But So if you're trying to be creative more closer to the model layer, right, versus the compute layer, what you're going to notice is that there are still a vast majority of markets that are not suitably targeted by current closed source providers, and not because the models themselves are not, well, in some cases, the models themselves are not performant to a certain degree, but because there are restrictions. And I think crypto as an industry grew out of basically creating systems that circumvented restrictions, both good and sometimes bad. And I think the same definitely goes for AI. So I'll give you a worked example. We work a lot with, for example, consumer-focused AI companies that are building things around like chatbots and personas and creating really interesting semantics around how you can own them. A lot of these have grown to several 100,000 users. They're processing millions of inference requests over our software a day, and a lot of them are very profitable. We're doing millions in revenue. And it's like, okay, how can these exist? You know, why don't people just go to OpenAI, et cetera? As it turns out, a lot of these take advantage of basically taking open source models and going ahead and fine-tuning them to do things around, you know, uncensored outputs or adopting personalities that you just wouldn't get out of like a US closed source company. There's a few other companies that are very interested in using open source because they're literally just blocked by cross-border payments from accessing OpenAI API, right? You can only pay in US dollars. If your bank doesn't support US dollars and you can't pay for that, you're kind of screwed. And so I think focusing on basically where people fall out at the margins of the current system has been very, very interesting, and I think it's something that people should pay a lot more attention to, where in order for it to get adoption, you need to find the communities that are already incentivized to use it, right? Because they're structurally like barred out from existing systems, and go after them. When it grows to a certain scale, and like these are by no means small. When I say margin, like this is such a massive industry, and I dare say the number, like right now, the number of people that are using closed source models probably are way higher than the number of people using open source, but that's because it's largely been constrained to, you know, what I would quote, like, you know, the very high-tech world of like the East and West. Even in the East, I think a lot of them still do try and go use open source models if they can't get access to OpenAI. That's where we've been spending a lot of time, and we've been seeing that grow a lot. And I think that as that gets recognition, people start realizing that there is actually utility in playing outside these closed source models. So for me, I think that's been something that's really interesting to observe and to learn and go after.
Thank you. Over to you, Matt. I'm curious, like open source, I feel like there's this 2x2 somewhere, like the open source versus closed source. And let's talk about let's talk about weights for now, right? And then there's centralization, decentralization. So I know we're talking a lot about open and closed here, but I guess maybe the theme of like we're all sort of building on decentralized networks in some ways. Like, what do you see as sort of like the wedge or advantage here? Is it Srinivasan was talking about, like, you know, the inability to access something like OpenAI because of, you know, rails that require USD, for example. But other inherent advantages that you can see with decentralization that becomes a part of our narrative to, I guess, cross the chasm for utility that's not limited to just crypto?
Yeah, so moving away from kind of like the infrastructure and talking about like what these models actually can do and the value they can deliver. So if you kind of take a look at like TradFi as an example, and I'll get into how decentralization plays into this, but you know, in the 1960s and 70s, when like kind of computers became a thing, you really saw this like explosion of kind of usage of compute and statistical analysis and machine learning in analyzing kind of you know, expected returns, right? You had like, you know, Alfred Winslow Jones start the first like long short strategy in the 40s. You had you know, Harry Markowitz with mean variance portfolio optimization, which became kind of the backbone of like MPT today. You have you know, Eugene Fama and Kenneth French doing research on how to model expected returns with multi-factor models, and obviously winning the Nobel Prize with the, you know, the Fama-French model. And with that as an example, you saw all these like other spin-outs of modeling primitives come out of this research, right? The Carhart 4-factor model, the Fama-French 5-factor model, all spun out from this. And kind of similarly, I'm expecting personally some kind of Cambrian explosion of modeling primitives for more like Web3 native use cases, as like the infrastructure that we're all building here together kind of falls into place, right? Once you have, you know, decentralized compute, once you have reliable access to inference for these models and statistical kind of analysis and all these research tooling that allows people to build models and you know, deploy them efficiently on chain, I think there's going to be you know, a plethora of research on, hey, as an example, how can we create some shared primitive that denotes like some notion of risk for adjusting LTV ratios in a lending protocol, right? How can we use that to adjust, fees dynamically in AMM swaps to reduce impermanent loss? Or how can we use, machine learning models to optimize, inefficient DAO governance or assigned reputation scores to deepen validators. These are all kind of extremely difficult and complex problems that exist today. And just because the infrastructure has yet to really exist, we don't have access to clean, structured, tabular data. We don't have access to reliable compute and inference that is both fast and scalable, but also secure and verifiable. Once these things fall into place, I'm very interested in kind of seeing people kind of pioneer these areas of research. And obviously us involved, the team at Valence, we're very, very interested in kind of driving a lot of this ourselves as well. And I think decentralization is going to be a major feature to this, where hey, anyone can in a censorship-resistant fashion upload any model to some file store or access any other model that someone else has uploaded, refit it on some new data, fine-tune it, and that's how we achieve what we call research velocity, right? Where we have this, this centralized kind of group of researchers and mindshare developing a lot of these models, but we have all these other people around the globe being able to access it from anywhere, no matter who they are, and I think that's going to be very important in the next 3 to 5 years.
Yeah, it's fascinating. It sounds a lot like, you remember this, when Const was talking about with BitTensor back in the day. So I think if I had to summarize, at least what I gather is that it's less about the use cases, but more about the ability for developers to tinker, because that is, with closed source systems and the lack of, because of centralization, that's really hard to do. So that's an awesome point. I know we're coming up on time here, but Siwang, I wanted to quickly segue from the here and now to what Matt was talking about, looking into the future. What are you expecting will be maybe steady state, either when it comes to open versus closed, centralization versus decentralization, maybe from your perch, from your vantage point, what can we expect in the next 6, 12, 18 months? Even science fiction, let's look forward, even way past that as well, and then we'll make our way down the panel, and then if anyone else has questions, please get them ready. We'll try to hit them quickly, but yeah.
Sure. So, yeah, what we're thinking is that the decentralization is a blessing. The diversity that comes from it, like how YouTube and how TikTok is so powerful, is all the contributors that only can come through the platform. So in steady state, in sometime in the future, what we're hoping is that we solve at least one problem with the current ecosystem, which is right now, if you want to make name for yourself and be rewarded for the contributions you're making as one of the million people who are contributing to innovation of AI, then the rewards are very noisy and indirect. So, for example, if in academia, you'll have to spend countless time to come up with new tooling, new innovation, data set, or models, and submit to a conference where it'll be reviewed by 3 reviewers and wait for 3 months and then try to convince them. And then the conference happens, you go there, you're one of the thousands of papers. It's very indirect. So what we're hoping is that there will be transparent and direct reward system that will be giving the content providers and data set providers and model innovators the reward that they deserve. And that's going to foster ecosystem where diversity naturally shows up. So that's the stable state that we're hoping to achieve. And yeah, I'd like to hear from others on that too.
Awesome. And yeah, maybe, sorry, we may be running up on time. So yeah, would love your thoughts, Matt.
Yeah, so I think in the next, I'll try to make this quick, but in the next 3 to 5 years, I think we're going to see kind of this explosion of decentralization of not just infrastructure, but also of knowledge itself, right? Where these open source models will, as tools become better, we'll see many different flavors come online, all decentralized and open source, right? Where many people can create agents or LLMs of many different flavors that are catered to many specific types of use cases. So you can, go on some kind of sites and be able to see, hey, this is a stable diffusion model that generates some specific type of art. This is an LLM designed, for doctors, and all these specialized models will be able to be accessed by anyone. And I think that in and of itself is extremely powerful, and I'm very excited to see it come to fruition.
Yeah, I agree with that. I agree that there will be this Cambrian-style explosion of utility across the open source ecosystem. I think that's going to be really, really cool. looking, maybe 5+ years down, I wonder whether, AGI is more likely to appear from a centralized solution or a decentralized solution. My guess is probably centralized, so I wonder if open source really matters at all. But it's a interesting space for sure, and a lot of value to be extracted over the next and provide over the next 5 years.
Yeah, I'm gonna play devil's advocate here. I don't think AGI is a single model. I do think AGI generally will be, multi-models, multi-agentic, like swarms, where we don't have a human that's good at everything, right? And we've seen that even LLMs cannot outperform like simple regression models or things on tabular data. It's very clear that there are benefits to focusing model architectures on specific tasks, right? Or focusing the training of models on specific tasks to get speed ups. So maybe looking out forward, and I know we're at time, but maybe looking out a little bit forward. In the next 3 to 5 years, I do think that we will see a lot more specializations of models. People will ascribe a lot more importance to how we route to those models. I think that's something we didn't get to discuss here, but the idea of like being able to evaluate models' performance on a specific domains and routing users' requests, you don't think about how you get your search results when you go to Google, right? You just trust that PageRank works. You shouldn't have to think about which model to use for a specific domain task. There should be software that works there. And finally, all of that goes hand in hand with having the right incentives for open source AI. So I do think that we will also start seeing, largely through crypto, modes by which open source model creators can monetize even if they're not directly hosting their models. And I think that comes with a lot of fundamental research about being able to do provenance for models being yours. Once you have those three, you'll have a sort of like a closed loop system for making sure that open source models are actually profitable. There's an actual real need for open source models to be fine-tuned because it's expensive to fine-tune with OpenAI, and then have those coordinate in some way so that you have sort of this like swarm version of AGI.
Awesome. Well, thank you. I know we're at time, but hey, thank you guys so much for this. Like, it was really a pleasure and really grateful for you guys for sharing your thoughts here today. And for those of you who had questions, please find these amazing people afterwards. But yeah, please a round of applause for our panelists. Thank you again. Yeah.
Thanks, guys.
Okay, we are going to be rolling into our next panel of the day. This panel is titled Unlocking the World of Agents on Chain, and for it, we are joined by Ron Bodkin, co-founder of Theoric, David Minarsh, co-founder of OLAS, Ben Frijan, COO of Talus, and the panel will be moderated by Nahal Monder. He's investor at Pantera Capital. Let's give him a hand.
Awesome. Thanks for the intro, Sam. I guess to kick it off, I would love for the panelists to kind of introduce maybe a little bit about what they're building and their projects just in general.
Sure. Hi, Ron Bodkin, co-founder of Theoric. We're building an AI agent protocol. We really passionately believe that it's important to have decentralization for AI. We think that as models are getting radically better, their ability to complete complicated tasks keeps increasing, and so having autonomous agents that are specialized, the builders can build, and we can dynamically assemble is the future. So doing it in a way that's effective and responsible is super important, and we're excited to talk about it here today.
Hey, I'm David, co-founder and CEO of Valerie. Valerie is a co-contributor to OLAS. We're also sponsoring. And what does OLAS do? Ultimately, it's an autonomous AI agent protocol. And the value proposition is to basically have you own agents that do useful things for you, be it ultimately in health, wealth, or well-being, like the biggest sort of objectives you might care about. We today have one of the biggest use cases around prediction markets, but the protocol itself is sort of use case agnostic, and I'm excited to talk about agents.
What's up, y'all? My name is Ben Frijon. I'm building Talus. Our thesis is very simple. AI should be able to buy stuff for you. So we're a special purpose L1 for AI agents. And we think that this use case is very powerful, very valuable, and it's something that needs to be on chain. So this is not something that can happen with existing financial rails and with Web2 rails.
Awesome. So that kind of kicks off and leads to my first question, which is like, what constitutes an AI agent specifically, in your guys' opinion?
I mean, I think an AI agent is an autonomous piece of software that uses AI models, and increasingly, not only can it take action on its own and have a long life cycle, but it can also do things like access data in real time and use tools to accomplish various actions. So that might mean calling APIs, that might mean, of course, interacting with a smart contract to be able to purchase something. It might mean being able to access a database in real time or generate code. So those capabilities together mean that agents are able to do increasingly complicated tasks. And what we're seeing is that each quarter, the AI models are getting so much better that their ability to plan, to reason, to execute more complicated steps keeps increasing, and the ability of them to work together to accomplish bigger tasks keeps improving. So, you know, we're talking about use cases. I'd say a good example would be, how can crypto traders get information about what's trending, what's interesting, and how can a variety of different agents contribute to a picture so that you can have the most insight based on what are your strategies and what your interests are, then execute an intent and actually purchase something on chain.
Yeah, great definition. I would add a couple of things. I think one key distinction here is around models and agents. So models by themselves aren't yet agents. You know, they need to be called. Agents are basically the contraptions we build on top, which use different models, and they tend to be longer running. And that point brings me to the second point. I think there's another key distinction to be made. When we talk about AI agents, some of them might actually be more like workflows, which kind of are short-lived. So, you know, there might be an instruction from a user, the agent executes that or provides some response, and then it's again idle. And then you have the more sort of autonomous types of agents where the instructions are much higher level goals and the agent might actually be working all the time. So that was the second point, and I think the third important point around agents is that, particularly once they become more autonomous, what becomes interesting is when you have multiple agents interacting. So the output or sort of what we care about from the agent isn't necessarily like done by a single agent. It might be done by multiple agents interacting. So they're called multi-agent systems, where any given agent alone couldn't actually fulfill the outcome. And so very interesting use cases arise as well, and I'm sure we'll talk more about those.
So AI agent is one of those terms that I think has gotten a lot more attention recently, and it's kind of an abstract term in that there's a lot of different ways to define it, like how some people say AI is just linear algebra, right? So I like to think of it by use case, right? What does an agent unlock for people, particularly for consumers? And to me, that's it can act autonomously. It can do something online for you that previously you would have had to do manually. And so at Talos, we're focused on this one use case of buying stuff, but generally the idea is that AI is this computationally intensive thing that's happening off-chain, requires a lot of powerful compute, specialized hardware, and then we're enabling a way for it to get on-chain so that it can trigger some sort of on-chain action. I guess you can think of it a little bit similar to an oracle, but a little bit more complicated than that.
Awesome. Well, I would be remiss if I wasn't going to ask, why is incorporating blockchain technology important to creating an AI agent or the product stack that you guys are building?
Yeah, happy to take that first. So I think one key thing is that of transacting and contracting. So if you think about why humans use blockchains and crypto more generally, it's because they're more permissionless, technologies for these kind of financial use cases. With agents, that's even truer. Like if you imagine an agent wanting to sign up for a bank account, that is a impossible thing at this point in time. Now, obviously, there will be some sort of centralized gateways which allow agents to interact, but one of the beauties of, as we've seen with DeFi and the money Lego, is that when you do that on permissionless substrates like open blockchains, then you allow for like composability of a different order and magnitude. I think the other key thing is around user-owned AI. So if I want to ultimately have an agent do things on my behalf, well, what's more compelling, having that in the GPT store and paying OpenAI a tax, or owning this outright, right? So the latter is clearly more compelling, also has more hurdles for us to get there. But what this basically means is I want to own my algorithm and my data, and that, again, puts us sort of back there. Then I think two other points I would add is that if you think about these sort of financial use cases, whether the agent lives entirely on-chain or as a mixture of on and off-chain, it can be very helpful to have these kind of security primitives, which, for instance, like a smart account gives you, where you can sort of permission the agent to do certain things but not other things. And then finally, one big thing about crypto is the incentives. So basically, with like crypto protocols, you can create incentives to coordinate not just one but multiple agents to achieve certain things.
I think those are all good points. I would maybe add a couple of thoughts. One is, I think it's really important that we have a foundation that is not owned with a centralized toll taker around AI, right? And so agents are increasingly going to be the point of value creation for AI. So, by building on a blockchain, we can have decentralized governance and open source that is self-sustaining, right? So that's community supported, that is able to be funded by a minimally extractive fee for the way the AI works, which is a dramatically better situation than having some centralized monopolist control the AI that is increasingly used in our daily lives and in our businesses. So I think that's important. I think the other side is, this is a golden opportunity to use blockchain rails and to use token incentives to help with two key problems. One is, what are the signals of quality? How do you determine what's a good agent, what's a quality agent, what's a reliable agent, right? I mean, giving real incentives for people to provide feedback and for usage is a huge leg up versus the often very spammy, very static Web2 marketplaces. So I think using blockchain, using community incentives, community participation, you can have much better feedback mechanisms to really create the right agents that are out there, as well as incentivize developers to build the right agents and help them grow and build their own successful businesses on top of blockchain rails. So I think those are factors that are going to be incredibly important, because I believe that with the speed that AI is improving, that we're going to see a majority of knowledge work being done by AI agents by the end of the decade. How are we going to build those networks? To build those networks so quickly, we really need the power of blockchain and the power of blockchain incentives to help the community grow together.
Yeah, I agree with both of those. I like that you mentioned value creation. I like that you mentioned composability. I think that I'll start with agents and then work backwards from there. So I think it's super important that agents utilize the composability of blockchains and that agents live on the same data layer as the assets with which they transact. This is really the whole point of putting agents on chain to me. And then because this is not something that you can do with existing financial rails, right? AI is not going to be able to have a bank account. We say all the time at Talus, AI is not going to be able to use USD. It's going to have to use USDC. It just makes a lot more sense for AI to be transacting with assets that live on a universal ledger. But then speaking more generally, I think the most egalitarian and humanist outcome for AI is to combine it with principles of blockchain and like decentralization. If you think about the three inputs that make up AI, the three most basic building blocks of AI, I think that's compute, data, and the model that you're running, right? So if you think about those three categories and who wins out in Web 2, who has all of the compute in Web 2, right? Who has all of the money to subsidize really high capex in the early development of a model? It's the Web 2 giants who are buying up all the H100s right now. Startups are not geared to that, and venture money is not geared to funding really high capex early on in a project's lifetime. For data, obviously, who has all the data in Web 2, right? The incentive in early Web 2 was to leave as much open data as you could on the internet to optimize for search. So this is one of people's biggest complaints about Web 2 is that there's no way for users to take ownership of their own data. And then models, I think it's very important that models are open sourced. I think the trend naturally is trending toward open source models. We're starting to see Llama and a lot of these great teams start to catch up with the closed source models that are being developed. But the two ways that you can think about that are, is AI going to be a public resource that anyone can access these foundational models, and that if you build value using AI, it's user owned and you generate it from a network effect or something that everybody contributes to? Or is the value in AI going to be derived from proprietary technology trained on proprietary data? I think it's a much better outcome for humanity if we go toward open source models, open source AI, rather than closed source models trained on proprietary data.
I mean, even though I think there's a lot to be said for that, I think we have to be careful in the sense that, you know, Llama 3 from Meta, they're not exactly an open source purist, right? I mean,
that's true, but Zuckerberg has already said that he's open to, at some point in the future, making it closed source. So
right, like if he ever catches up, then he's going to close it down, right? Be careful who your friends are.
That's certainly true. That's certainly true, and I think that's why you know, I just saw there's a French AI lab. I think it's pronounced Kutai. That's a nonprofit research lab that just released a conversational model called Moshi that it apparently is even better than what ChatGPT's voice module that they're taking so long to release. So I think generally the trend is toward open source, right?
Yeah, 2 points. Actually, someone internally sent around a link around Moshi, and it was frightening, but it was very funny. I'll share it later. The other thing on this open source point, I think it's actually a bit more nuanced. So when we're saying, like, you know, we don't, when we're talking about the proprietariness of it, like the problem is if you have basically OpenAI own a model where the ability for that model to exist in its current fashion basically derives heavily of us all using various open source, not open source, open platforms like something like Reddit and so on, which, you know, and the internet as a whole, the data on the internet, which basically went into the training data. I don't think the answer is to ultimately say everything should be open for everyone to take, because you will then, by definition, as an open ecosystem, always be behind the closed ones who will have all the open stuff plus one. So what it's about is creating like more an attribution to like, okay, if a user creates like certain value here, can they also, participate in the downstream model, right, and the ownership of it. So actually, I think even in crypto, if you want to build like really good models, they might, there might be open weights maybe, but maybe the training data shouldn't, like almost surely the training data shouldn't be entirely open. It should be sort of governed by, let's say, a DAO and be used in the training process of that particular model. But I mean, these are somewhat non-agent questions at this point.
Let me be more specific in touching on why I think this is happening, why I think open source models are catching up to closed source models. I think it's because as we're scaling compute, it turns out that the quality of your data is what's really important in training these models. And on the open web, everybody's trained on the same data, right? We're talking about on the order of like trillions of tokens. So there's only so many Wikipedia pages out there, right? So the future for these closed source models is going to be effectively BD deals, like the Reddit deal and figuring out ways to get your hands on all of these data repos that nobody else can touch. I don't think that's a good outcome for everybody. Right? I think it's a lot better if we train open models on open data and that value is derived from other effects like network effects or the product that you're creating at the application layer.
But I do think, if I just make one point about how it relates to agents, I think that we have to design for a future where there's going to be commercial models, where there's competition among them, as well as open models, and allow people to build great agents that can leverage different models, right? I think the worst thing is that we end up with a top-to-bottom stack that's controlled by a monopolist. At least there's choice between OpenAI and Anthropic and Google and others. What's really dangerous to me is if OpenAI starts to build this verticalized agent ecosystem and they have all the agents. That's where we're really in trouble in my mind.
Awesome. Maybe switching gears specifically, and you guys have touched upon this already, but I'm curious from a user perspective, what does an agentic future look like? And maybe not just on the long-term case, but also maybe touching upon the short-term use cases that your guys, individual companies are building for. That could be interesting for the audience. So I'd love to hear from you guys on that.
I mean, I think short-term and medium-term and long-term look very different. So what we, I think, should aspire to, and the timelines, everyone has a different idea, and we'll see, is that basically we have these kind of AGIs and more capable kind of software agents, and then the question is like, okay, well, who owns them? If we get back to this point where OpenAI has this sort of vertically integrated stack, and we are all like basically paying like this huge tax or don't even get access, that clearly is not desirable. So we want a future where they are user-owned or group-owned and so on. But why do we care about these products? Because ultimately these are products that are going to create entire outcomes. Today we're in like a very interactive paradigm when we think about applications. People immediately jump to the conclusion that when you talk about some app, that it's something I should be clicking around on. Actually, half the audience is clicking on something right now, and that's because we're like really conditioned to this over the recent years. But what autonomous AI agents ultimately give us is that these become these kind of synthetic beings around us which do valuable things whilst we do other things which we enjoy, right? So I would call them outcomes products. And they like really high level outcomes. Like they help me become wealthier, they help me become healthier, they help me in the high level goals I have in my life. And then if we go into the very short term, they're much more these interactive products. So ChatGPT, right, like other kinds of like short-lived workflow agents are examples, and I think my panelists will talk a lot about this. What we at OLAS focus on is already these outcomes products. So we have one product, like one of the biggest use cases is OLAS Predict. So there, the agents, like very different agents specialize in different parts of prediction markets. And so the user is really just there to own one of those agents. The user is not there to engage with this agent on an ongoing basis. And that has very interesting features, which we maybe uncover later, but there really is already this outcome, which are the prediction markets, and for the user, they're basically just having an agent which makes them wealthier.
I think it's right that you're going to see increasing capability of agents. So that means that what the use cases are today tend to be more narrow. Like last year, we put a precursor of a protocol into production with Space and Time to help their developers write better code to integrate with their protocol and answer support questions, right? So that let them see a real uptick in people building dashboards, using both that and also the ability to write queries, to visualize data, to even forecast, right? So those kinds of agents, those were really popular, in the last few quarters. But what we're starting to see is as the models are getting better, they can do more sophisticated planning and action, right? So now we have agents that do analysis, can tap into live social data, and we're seeing excitement to not just make that an interactive analysis tool, but also like working with exchanges to make it so that users can get alerted from agents that they care about that are collaborating and say, hey, there's something new, there's an insight in this token you're tracking, take action if you want, right? You can jump in and decide. And then from there, what we see is, I think we're soon going to get to where people are more willing to automate actions. I don't think we're there yet, right? I don't think most people are going to be like, yeah, here's my bag, go trade for me. I don't think most people want to do that yet, but we'll get there, right? As the agents keep making good recommendations and people keep saying, like, yeah, let me dig in, that makes sense. So we do think, no surprise in crypto, trading is probably one of the biggest use cases. We also see it emerging in social as well, right? People are wanting to do things like better understand a conversation in social, summarize it, dig in. That also applies into DAO governance, right? Where it's, again, this agent is a superpower for you to be able to act on your behalf, right? So I think those are some of the most powerful initial use cases. I think the first use cases for decentralized agents will probably be in crypto, but there's so many more general use cases that will also be attractive as well, right? So everyone likes to talk about things like planning travel or, analyzing, a contract, right? These are common use cases as well that I think will be among the earlier ones. Over time, it's going to be starting to automate more and more of your business as well.
Yeah, I agree with all that. We're not there yet with agents, and part of that is because the margin of error for the consumer is so small. So if you trust AI to do something for you, well, if you ask ChatGPT a question, generative AI a question, and it gets it wrong, you can move on with your life. But if you enable an agent to spend money on your behalf, then we're talking about as close to zero as we can get for a margin of error. So I think we're getting there. We have a lot of positive headwinds in Web 2 as well. There are a lot of great teams in Web 2 that are developing agents. Let's just add in blockchain technology so that, first of all, we can add verifiability to the agents. We can add all the benefits of decentralization, and then second of all, we can enable agents to transfer value for us on a common data substrate. And then more generally, a grander view of what agents are going to be able to accomplish. I like to think of this as the advent of petrochemicals during the Industrial Revolution freed up a lot of time for people, right? So in the 18th century, you would have spent a lot of your time chopping firewood and bringing it back to your house, and that just took up a lot of time, right, to be able to utilize energy in burning biomass. And of course, the advent of petrochemicals freed up a lot of your time that you can have new use cases like electricity. And so I think of agents as the same way. It's going to free up a lot of time for individuals, where right now, if you are not sitting in front of your computer or you don't have your phone in your hand, nothing gets done, right? In an agentic future, you're going to be able to do a lot of stuff without actually doing it yourself. It's going to increase everyone's productivity.
Awesome. A lot of you guys touched upon the fact that agents have to be perfect, obviously, to gain that trust from the consumer specifically. Now, nothing released in the field will ever be perfect, so I'm kind of curious, how do you guys imagine measuring agents, good or bad? And maybe just talk a little briefly on that.
Maybe it's an important point. I think that the bar for quality and like the standard of how good something needs to be can really vary depending on the use case, right? So like trading, like a lot of your net worth there's a very low bar for failure, right? Whereas like making recommendations where you can probe and ask insight, it needs to still have a lot of signal to noise. Like if it gives you a bunch of hallucinations, you're gonna be like, no thanks, I don't need that. But the bar is lower. But I do think it gets to the point that like, you know, what's really powerful is to have more crowdsourced assessment, right? So giving feedback. Like the best thing in Web 2 for this is the academic, you know, it's from Berkeley, LMSys leaderboard of chatbots, right? Which is like, hey, which of these two chatbots is better for you, right? And I think that same kind of community incentive to provide feedback on the way agents are working in a domain is going to be more powerful, right, than anything else. The other technique that's out there is some version of benchmarks that researchers come up with. The issue seems to be, though, that benchmarks are often so contrived and so limited, and you know, we always see this phenomenon that a benchmark gets launched and immediately it gets saturated, right? Like it's hard to create a benchmark for something that isn't like right on the cusp of being nailed by the AI systems. So I think community feedback is really the most important way.
Yeah, I mean, I would immediately push back on them having to be perfect. I mean, humans are far from perfect. So it's really just, are they good enough relative to the alternative? And in some domains, they clearly are. Like if you take prediction markets, I mean, firstly, it sucks. Like humans don't really want to do this. Like people get very excited about it every time there's an election, and that's sort of obvious. But outside of this time, like no one really wants to do this. And then if you think about crypto more generally, like people get very excited about trading in crypto, and I mean that's a very small sliver of the global population. So if you want to have billions of people using crypto, they're not going to be like your trader, right? They want this abstracted. They want this to be like a bank product where they put some money in and then they get some APY, and yeah, it doesn't totally go away, right? Now, evidently with all us, we're already doing predictions, like the agents doing predictions that are better than humans could be doing them. And actually there you like point out an important thing, you need benchmarks. And the nice thing is, in some cases that's very hard, and in some cases like prediction markets, you can actually create that on an ongoing basis because your prediction market itself becomes the benchmark. I think in finance, again, like I would slightly push back. We're actually working on a product called Baby Degen, where the idea is you put the entirety of like the trading aspect back into the agent's hand, and it's all about just the agent generating wealth for you. That's what we're testing internally in alpha, and like again here, I don't think it's as black and white to say, like there's some sort of clear better or worse. Like obviously it shouldn't like lose your whole portfolio, but in crypto in particular, where you have like a lot of variance, this is the perfect place to test these agents. And like generally speaking, anything with a financial metric gives you a much faster feedback loop, right, for testing these agents, making them better. Now, having said that, we have two dominant use cases which are totally outside of finance. Like one is basically in governance, as you brought up. So there, the agents basically read proposals and then vote on them. And then the third one is around social media, where basically the agents compose content and also score content. And both of them, again, it's much harder now to measure what actually constitutes good, because it's an objective rather a subjective rather than an objective thing.
Yeah, I think both of those points are correct. We need great benchmarks and well-defined training curricula, but I also think it's important to have really great UX. And I will know that agents have succeeded if they're a consumer product. I think that would just be a really cool unlock, to build agents that the average Joe can use to make his or her day better. So UX, always top of mind.
Awesome. Well, looks like we're out of time, but thanks so much. Yeah, and thanks so much for the answers, panelists.
Thank you.
Cheers.
Thanks, y'all.
Okay, everybody, we are heading into our next panel titled Deep Tech Building. For this panel, we're joined by Nick Emmons, co-founder of Alora, Jake Brookman, founder and CEO of CoinFund, and Brad Feinstein, head of Web3 North America at AWS. Welcome them on stage.
Hello, everyone.
Hello.
Thank you for joining us today. I am Brad, the head of Web3 for North America. I made a special trip to Brussels just to be here and to meet all of you. So I just want to quickly kick off a moment and talk about how far we have come in this space and perhaps where we want to go. There are 540 million people that are holding a cryptocurrency. And that is tremendous because it is a 35% year-over-year increase from where we were in 2023. And then you combine the estimated $15 billion market cap investment that we're going to see in AI, with 83% of enterprises stating that AI is a top 3 priority. So we are sitting at a golden age of potential innovation. And you have 2 technologies that have the opportunity to add value. One creates a transparent, accountable way to understand your data. The other has this new incredible way to create new content. Now, we need ways for these technologies to come together, and that's where AWS comes in. We're building scalable, secure products to help startups, VCs, and enterprises build and scale. And that's why we're here today. We have a leading project in the space and an incredible founder of VC, hopefully all of you know. And today we're going to talk about how we work together and the ways in which we're helping startups scale. So Nick, let me first ask you, could you please give us an overview of Alora, and let's talk about the ways in which we're working together.
For sure, yeah. So for anyone who's not familiar, what we're building with Alora is essentially a decentralized collective intelligence network. We're trying to solve this really fundamental problem in AI today that is siloed machine intelligence. There's lots of different models that exist, but they live in these silos. I can't take model A, B, and C and merge them together to create a new model that is as intelligent as the sum of the intelligences of those underlying models. And we think that by creating these model coordination mechanisms, by creating a means of creating collective intelligence, we can significantly accelerate the progress of AI in the world and realize a future that is made up of many more individual contributors, many more specialized models, and just a kind of general abstraction layer for intelligence itself. And so that's what we're doing with Alora. And the way we're working together with AWS is on a number of different fronts. One area being with the Node Runners program of AWS. So this network is as smart as the models that are on the network. The more models that exist on the network, the smarter this source of collective intelligence becomes. And via Node Runners, it becomes really simple now for anyone with a model, any data scientist, any ML researcher, et cetera, to take some model they've built for some domain or some specific setting and now bring it onto the network powered by this kind of Node Runner program. Additionally, we're working closely with AWS to facilitate the kind of subsidization for some of these new nodes coming onto the network as well, enabling new ML researchers, data scientists, research firms, et cetera, to actually get access to AWS credits to bring their models onto the network via this Node Runners program as well. So that's a bit of an overview.
Yeah, that's a fantastic launch announcement. So let's just perhaps highlight the fact we have a new blueprint available that's going to make it easier to ultimately create and run and scale your nodes for Alora Network. And then we're also working together for an early stage startup program that's going to help builders bootstrap, ultimately learn, and get started using AWS tooling in the ecosystem. So this is one way that AWS is here helping the ecosystem grow. And we're going to transition over to you, Jake. So first, help us understand what stuck out to Alora as you thought about funding them? And then for the many people here that are looking to talk to you, what general tips would you say to get on your radar? Because I'm sure most folks here certainly are interested in that.
Thank you. Well, maybe just to take a step back, so at CoinFund, we are a blockchain-focused investment firm. We've been around since 2015, based mostly in New York, Miami, and Boston. And on the topic of the intersection of AI and Web3, we've been like pretty prolific investors for a while. We made our first investment in the space in end of 2020 with WorldCoin. We did Jensen AI in March of 22. We published our thesis in September of 22. I feel like this space has become consensus like this year. But we have a portfolio of close to 10 companies or so, including Allura, work in the space. So how do we think about the space? There's a certain pipeline that creates AI products in the traditional world. That pipeline starts with talent and understanding of AI. It's people kind of proposing how to train models. It's the compute stack that goes into that training. It is also the compute that goes into the inference of those models, and it's the productization of those models that brings them to enterprise or retail customers. The way we think about that pipeline is that it's owned primarily by a handful of big tech companies today. And by your presence here, I suspect that that's not fully satisfactory to this audience, right? And so what we've been funding at CoinFund in the intersection of AI and Web3 are ways that Web3 primitives can essentially democratize that pipeline. In terms of compute, is it possible to kind of aggregate private compute all over the world and offer that up as a decentralized network so that, if there is a scientist who wants to train a model at scale, they don't necessarily have to work at OpenAI to do so. They can, crowdfund the money for that, or do it in a more independent way. I think what Allura is working on is another very interesting aspect, which is creating, aggregating the models and creating the outputs, and not only that, making them smarter sort of over time, which, if you look at private AI products, they have a similar strategy, right? Like the fact that, millions of people are going to be using ChatGPT voice mode is actually going to give OpenAI a lot of user interaction data about how voice mode is being used, and that data will be used to train models. And so the overall premise of funding Web3 AI is that we want to give the open source version of these technologies an opportunity to be just as good or better kind of than the traditional proprietary versions. And that will create more data sovereignty for users. I think it will create more safety ultimately, and we can talk about that, and many other sort of properties. So if you're working on an AI Web3 project, we'll talk to everybody in this space, so just come find me.
Excellent, thank you. And our view on tooling has been aspects of the stack require decentralization. For those that don't, or if you think about the spectrum of where that lies, use products that work, that are safe, reliable, and scalable. Our presence in the ecosystem is really to support the community and support the builders. Use our products where they make sense, and where you want to build into that wrapper or create alternative versions to that, we're highly supportive, because ultimately our view here is agnostic, right? We want the ecosystem and the communities to continue to scale. We want the builders to continue to build. So we will pick the places that make sense for AWS to participate. Bedrock is, of course, being one of them. Bedrock is the platform in which we allow both open source and closed source models for users to come in and build on those APIs. And by having all the different choice, it allows developers through enterprises to ultimately pick how they want to build. which is going to lead us to my next question, right? We're at this golden age of innovation, but where are you seeing the use cases? Where are the customer success stories? The real world applications right now where you're seeing differences get made. Nick, why don't I start with you, and then we'll let Jake take over.
Yeah, I think AI is this really broad thing that's obviously going to touch basically every definitive piece of society, every sort of critical function of society. And so I think a lot of things are starting this transition over in varying ways. Where we see a lot of kind of real world impact or value being created right now are in various financial sectors. I think this kind of new wave of AI is what's captured the world's imagination in a bigger way than AI has before, and I think it is really exciting and where kind of the AI paradigm is moving, but it's still in its nascency, whereas I think like classical ML, AI used in financial settings has been kind of battle tested for decades at this point. And so we see a lot of AI being brought into the DeFi ecosystem, being used to enable fundamentally novel types of financial interactions, to be the backbone for hyper-efficient, more expressive actors in financial systems, stuff like that. And so I think there's interesting experiments in AI right now around sort of smarter kind of lending term generation, smarter kind of settlement construction. AI-powered prediction market elements are coming into play now. I think there's a lot of really exciting stuff happening in this kind of set of financial domains that particularly benefit from the AI that I think is production ready today.
Jake, what's your take?
I think the practical reality in Web3 right now is that there's not a ton of stuff in production still, but a lot of the stuff that I have seen that is in production, to Nick's point, has to do with financial technology, right? So we've seen kind of on-chain AI being applied to, optimizing yield across yield-bearing opportunities. We've seen just financial strategies that are able to be executed by AI like in an autonomous fashion. We've also seen sort of chat interfaces that help users translate their intentions into blockchain transactions. So it's kind of a little bit of an execution layer. I think the broader view over time is that there's a lot of applications of AI. There's this sort of huge, hypey focus on AGI. I mean, we're at AGI Summit, right? But it was sort of like really refreshing for me to hear the CEO of Cohere on a podcast recently. Cohere is a Web3 AI company, and he said, AGI, oh, well, we don't really care about that. We just want to make AI useful for businesses. And that was like a super refreshing thing to hear in the kind of current context where everyone's racing for AGI. But how do you make AI, useful for businesses? I think a lot of it will be in terms of creation tools, like we've seen some amazing progress in video AI. Like just in the last year, we went from weird like blobs to almost like photorealistic, HD quality like video clips, and you could really see how with some productization, you can lower the barrier to entry of making movies. It'll stop like making sense to go out with a camera and actors. It will just be like way too expensive versus prompting something like that. Similarly in kind of static image outputs. Similarly in the assistant space, and so far I'm just naming like retail applications, right? But I do think that like for me the really interesting long-term applications of AI will be the ones where we can actually augment our intelligence with artificial intelligence. And what I mean by that is solve mathematical theories that we haven't been able to do before, create new science, unravel some of the mysteries of the universe and so on. These things sound fantastical, but they'll also present like enormous commercial opportunities as well.
The most immediate applications that we've started to see are around productivity, right? That would be code assisting tools or knowledge repositories, being able to pull your information. One of the biggest challenges we see, right, is how to maintain the privacy of your own data without perhaps increasing the sophistication of the model. It's another thing, you know, that we see. And certainly, as I mentioned earlier, 83% of the enterprises that we've surveyed identified an interest in the space. Now, the opportunity is around what does that actually mean? I think that as these use cases and the solutions that we can talk about come to light, being able to not just discuss the art of the possible, but being able to say, we did X, which resulted in Y, is going to help accelerate what we see. So then my follow-up question for both of you is, are you starting to see geo-specific use cases and applications happen based on perhaps regulation, or are you still seeing the same use cases be applied across geography? How is that impacting the types of customers and the types of startups you're seeing?
Jake, you want to go first?
I don't really see that physically, but that doesn't mean that it's not going to happen. In fact, I'm a big believer that the world where we have just like a few large, very monolithic models, you know, like GPT-6 and Anthropic and maybe a few others, that's going to be a far inferior world to a world where you can have different models that are sort of specialized to their own domain, to their own locale, to their own cultural context, to their own political context. I just don't see how these models can be built without that kind of specialization, because everything else, you know, in digital world and computer world, in printed text world, right, has those kinds of considerations. So I think LLMs also want to be localized. You know, I think Jan LeCun said on a Lex Friedman podcast, he's like, it wouldn't be a good thing if like a few companies on the West Coast of the United States, if they were determining like the global digital diet of like everybody in the world. It's just not kind of like not a fully efficient system, not a fully productive system. So I think we'll see a lot of that, Brad.
Yeah, I think that was perfectly said. I think the future is going to be one of many models, more specialized models, probably smaller in scope, coming together to create a more proficient, more personalized kind of intelligence experience or intelligence substrate by which different pockets of the world can operate on. I don't know if we're there today. I think we still live in this kind of monolithic world where a few people are dictating how intelligence operates, what is important in the models we're using, et cetera. But I think that is the inevitable future and one of many different specialized models. And in that future, we'll see these more geo-specific use cases and products start to emerge. Hyper-specific risk hedging depending on region, governance of different localized kind of municipalities moving to these specialized model type infrastructures, et cetera. So, yeah.
I want to add one more thought, which is like there's a very important issue when you go from a monolithic model to a bunch of maybe smaller specialized models that you interact with. And that is like, how do you take the context with you? How do you take your data with you? And the monolithic model offers this simple, seductive, and like incredibly dangerous way of doing that, which is just give us all your data. And in an agentic multi-model context, it's harder to do that. But this is where I think the model of Web3 actually provides a major advantage, because the model of Web3, because what is Web3 in the essence of it, in the core of it, it is self-sovereign data. It is the ability to own your data and kind of take it with you from context to context, from model to model, versus just letting a third party exploit it.
Yeah, that is exactly why I think we need to see multiple open source, closed source, and in between, right? The more participants we have creating and building, the more availability there's going to have, which actually I want to go back to you, Nick, for a question about your startup journey here, right? So we have a lot of founders in the audience, and what do you know now that you wish you had known when you started this process?
Yeah, that's a good question. I think more than anything, when aligning with different partners, bring different backers onto a project, it's important to develop a sort of interpersonal relationship with them, have a high level of mutual trust and respect in that engagement. I think building something net new, bringing something like to life via a company or a startup is not a straight path. There's going to be many different turns, and in order to have a strong foundation in the backers that you take onto a project, I think there needs to be a level of trust or conviction in one's own judgment and one's own intuition in navigating that path. I think obviously Jake has been there since the very early days and shown that very well, but I do think that's one of the most important things, is aligning with people who trust in your decision-making ability to navigate what is a very abstract, kind of confusing landscape.
Yeah, that makes sense, and I know we had met right through some of the early stage initiatives that you were working on, which is a highlight for a program called AWS Activate, and that's the umbrella startup program that ultimately houses all of the different ways in which we work across the startup ecosystem, right? So Activate, of course, is one of the ways in which we work with CoinFund, right? So they are a provider, and what that means is that they're able to offer a code that ultimately is redeemed for credits. Yes, credits are an important part of that, but what comes along with it is education, is resource, is workshops, is access, and through that journey, and Nick, that is where we met. We started talking, and through the work with our solutions architects, we uncovered an opportunity, right? That was an opportunity to influence the go-to-market, the BD, and after several months of working together, the end result was this combined program that we've offered that's multifaceted, right? So it's a technical piece that you can go, that perhaps is live today or should be live very soon, and you can go to the AWS Node Runners repository. There's a live blueprint right now that you can go use to spin up a node. You can separately reach out to Nick and his team, and they'll provide you with a code. That code is going to give you access to credits to get started. As you continue to build and get traction, you can then perhaps go reach out to Jake and his team, and when needed, right, if you are fortunate enough to get their investment, you can then apply for higher levels of codes. These codes are meant to align with your stage, right? And we offer these for the different programs, whether it's co-market, co-build, or co-sell, to align with where you're at. So Nick, I want to go back to you for a moment, right? We have an audience of perhaps builders. Perhaps explain the target persona or the target use case that you'd like to talk to, and who should come find you after this presentation today.
Yeah, data scientists, ML researchers, basically anyone who builds models, who's interested in kind of creating different forms of intelligence for different use cases are like why this partnership exists, is why the network is being brought to life, et cetera. With what we're doing with you guys, it makes it such that any data scientist now can just focus on building the best model they can and leave the infrastructure stuff to AWS and kind of abstract that element away such that the people who are bringing models onto the network can focus on the thing that they care about, that they're specialized in. And what intelligence networks are, what this network is it's basically the shortest path possible from creating a model to capturing value from it. The same way Bitcoin is that for power, other networks are that for different resources. What we're trying to build in this collective intelligence network is a commoditized instance of intelligence. And so anyone building models, data scientists, ML researchers, like I said, are the kind of core actor in this network.
Excellent, thank you. And I want to talk perhaps a little bit forward thinking, right? We're on a panel back together next year. What do you think has happened in the year ahead that's going to propel our industry forward. Jake, why don't you start, and then we'll go over to Nick.
Oh, okay. I have a hot take. I think broader AI is actually like quite overinvested and a little bit too hot, and I think it will come down. I think there's a possibility. You know, I don't have a super strong opinion here, but I do think there's a possibility that building 10 times kind of the compute power data centers will not necessarily translate into commensurate scaling. In other words, like the intelligence that you get out of LLM transformer-based models will not necessarily like follow suit with that scaling. And I think that there's still a ton of work to do in productization of AI. Like a lot of as good as the models are today, a lot of the ways that people use them are really, really immature, right? And so what I'm trying to say is I actually think there might be a bit of a trough in Web2 AI, and that will actually give an opportunity to decentralized AI to catch up a little bit. Where do we need to catch up? We need to aggregate compute. We need to solve some core technical problems, like for example, decentralized training. The market consensus is that it is a fool's errand, it is impossible. I actually strongly disagree with that and have been funding research to the opposite effect. I think we also need to find ways of connecting AI and smart contracts in really productive ways that show that this could drive, you know, demand of smart contracts. We'll have the opportunity, you know, to do that. And there's probably a lot of work to be done in data. You know, a lot of the focus for the last couple of years has been on the compute, the training, the inference, and relatively fewer startups working on how do I have an open marketplace for fine-tuning data? How do I kind of collect labeled data in a way that will allow me to create really great scaled models? And there's a few startups in the market, and I think that market would also grow over the next year. So
We'll go to you in a moment, Nick. I also think there's a capacity of available data, publicly referenceable data, if you just keep the internet as a whole, right, and we just keep scanning that. We need higher quality. So the idea of tagging and qualification of data, I think, is going to become increasingly important when it's not just computers looking at what's been available, but how do we train on more unique, differentiated data sets? Because not all data is equal, and we certainly know that. So we're going to have to find alternative and new mechanisms for inputting this data into the system to learn on it. Nick, why don't we head over to you now?
I mean, yeah, my answer is very much in line with Jake's. I think what we're seeing happen right now in decentralized AI is people realizing, as we've realized in DeFi and blockchain and other kind of industries, in that a modular system design is kind of the optimal way to design a system. When you're developing these decentralized networks, you're trying to coordinate many different actors to participate in some set of actions. And when you start introducing a set of heterogeneous actors completing a set of heterogeneous actions, it becomes, the complexity compounds. And I think we've seen this in sort of the move from monolithic blockchain design to modular blockchain design and other in other parts of the space, et cetera. And I think we're seeing something similar play out in AI, where these new networks that are emerging are picking the layer of the stack they want to focus in. I think the 4 core layers of the decentralized AI stack today anyway are that of data, compute, intelligence, and execution. And so I think over the next 12 months, we'll see a lot of these different layers start to come to life in isolated forms, and we'll also see them be stitched together in interesting and efficient ways to realize this kind of end-to-end modular AI stack. And so that's sort of my hope for the next 12 months, is that, one, we continue to push towards this modular paradigm for decentralized AI, and 2, we see these different layers of the stack come together in a kind of coherent fashion to create a competitive or viable alternative to that of centralized AI.
I agree, and I want to ask a follow-up question there. Is the stitching together an education, an infrastructure, or perhaps a tooling problem, right? Do we need new products to bring all of these together, or can the existing set of infrastructure tools be used across those different 4 segments and collect them in a cohesive way? What do you think there?
Yeah, I agree. I think a lot of it comes down to tooling. It requires alignment with the networks themselves. I think there's a lot of community participation necessary in bringing that tooling together, but I agree. I think a lot of it comes down to just tooling in taking isolated pieces or modular pieces of this stack and making the end-to-end stack feel like this unified abstraction, essentially.
Yeah, and perhaps as we go explore the economic incentive component as well, right? We talk about where do these technologies connect. I think the incentivization component and the provenance of who participated in where and how is a real application that has yet to be seen in the vastness, right? We are theoretically talking about the crypto economic incentive piece. I'm very excited for the world in which that becomes relevant and that becomes scalable. So to me, that represents a really viable and exciting pathway forward. And I know it's certainly one of the ways that Alora is going to be participating in this ecosystem. So we got just a couple minutes left. Why don't you both kind of, if you could ask your closing thoughts, right? If you could leave the audience with one message or perhaps one insight. Nick, why don't you perhaps start, and Jake, you'll take us home.
One insight, okay. I think this is more of a general point, not necessarily related to Alora, but I think today in decentralized AI, people have sort of created this level of synonymity with open source AI being decentralized AI, and I actually think decentralized AI doesn't equal open source AI. I think they are two distinct things, and I hope over the coming months and years we start to see this kind of more explicit distinction in that building decentralized AI infrastructure doesn't mean an exclusive bet on an open source AI future. I think open source AI obviously will be a very critical piece of this. It will enable different things to exist, but I think closed source AI can be made compatible with open source AI via decentralized networks, via model coordination networks, via different coordination mechanisms, and so that's the insight I'd like to kind of close with.
Yeah, I think my insight is that like Web2 AI folks have variously panned the idea of decentralized training, and they have pretty good arguments. They say, look, if you kind of look at the procedure the training is, and if you sort of imagine the nodes that are doing those computations to be separate nodes connected not by fast links but by slow internet links, then this becomes infeasible. And my insight is that while that's true, there's actually a way to sort of step back and say, can we find sort of a different training architecture that presupposes this type of parallelization and distribution that you would have in a decentralized context. And once you do that, you actually see a path to creating systems that are able to do decentralized training at scale, arguably with some of the largest models that will be available in the world, and with really interesting properties for monetization as well. So my insight is do some research on decentralized training. There'll be some blog posts and stuff coming out probably this week on this. I'm very excited about this area. I think it's a problem really, really worth working on versus kind of ceding it to the big AI companies.
I want to thank my panelists, Nick, Jake, thank you. I want to thank all the audience for giving us your time today. Also, to the wonderful team that put this together. This was a tremendous feat. To all the other partners and sponsors, thank you. Also, we're going to be giving a technical demo on Bedrock and some of the other AWS ML and AI products later today. So please find the AWS team and please come join us later to learn more about our products and how we continue to support the Web3 and AI ecosystem. Thank you all, and appreciate your time today.
Okay, we are moving into our next panel, which is titled VCs on Decentralized AI. For this panel, we have Joey Krug. He's a partner at Founders Fund. Cheryl Chan, who is a partner at Dragonfly. And Dovey Wan, who is the founding partner at Primitive Ventures. And myself, I will be moderating, and I'm an investor at Symbolic Capital. On stage.
All right. So just to get things started, I want to get a little bit of a lay of the land for the audience here. Dovey, maybe you could start. If you could just give us a little more context on your fund, and specifically a bit of your approach to how you see the decentralized AI landscape.
Yeah, so hi everyone, my name is Dovey Wan, and founder of Primitive Ventures. We are not a VC, but write VC checks, and because we don't have any LP and just all our own money investing on the balance sheet. So we've been investing in frontier tech, because crypto used to be under fintech since 2014, and then become its own category. And so I've been investing in frontier tech since 2014, and also AI prior to the transformer era, and then so it's mostly on computer vision. Yeah, and then so when it comes to crypto AI, and I think both of them are orthogonal. And so because crypto changed how money and value transfer, and then it's basically reorganizing our societal, reorganizing our societal value supply chain. And then when it comes to AI, because AI is a huge category, and then so pick up after ChatGPT, and ChatGPT is more of a revolution when it comes to medium. So when it comes to alternative distribution, because what ChatGPT has done is it's basically instantly create a new distribution channel out of the iOS, and then so out of Google Play, and then with 100 million sign up in just 3 months. And then so it's every major technology. Any major tech innovation is about alternative distribution. If we specifically talk about LLM as this new AI meta, and I really think that's alternative distribution that we have seen for our era, and also fundamentally, so it basically make human language into programming language, and then so what used to be 10x engineer, and then so now can be 100x engineer. So I think in the future we are going to see what I consider as a super solo. Super solo is you can be just one team army, and then so probably can make just hundreds of millions of ARR. Yeah.
Then Cheryl, maybe just a little bit on yourself, and then how Dragonfly sees the space.
Sure. Hi everyone. I'm Cheryl from Dragonfly. Dragonfly is only a Web3 fund. We don't do anything in Web2. Recently, we've been paying a little bit more attention into AI and crypto. I think the reason for that has been pretty straightforward. We think that in AI, because of the way compute and data has been set up, there is inherently a very centralizing force to that, in which there is a lot of trust assumptions to be had. We think that's kind of a perfect marriage with crypto, in which there is a need for a trustless, permissionless, more democratic solution in which you're putting power back into the people. So we've been looking at AI crypto pretty closely. We're pretty proud to have partnered with quite a few portfolio companies that we're sure will do very great things. And yeah, thanks for having me today.
And Joey, maybe just a bit about yourself and Founders.
Sure. So I'm a partner at Founders Fund. Our main model of investing, which is the same model we apply to crypto as well, is we try to find really 0 to 1 ideas that are really novel or have some sort of technical edge or distribution edge. And then the other thing that's really important for us is backing the best founders. We're I think the only VC fund that's been around since 2005 that's never fired and never will fire a founder. And then we like to try to find people and companies that we think become market dominant players. In terms of the crypto and AI space, we've only made 2 investments there, one of which is Sentient, which I'm sure we'll talk about in a moment. I think there's part of the problem, I think, is that today in AI, the financial incentive is really only to do closed source. There actually is no good financial incentive for open source yet. I think Sentient, will hopefully solve that. There's the other area that I think is quite interesting. We haven't made an investment in it yet, but the area of like creating sort of kind of an open marketplace for compute, not the style where you try to like everyone run their own, home GPU, but rather just like an actual large marketplace for compute. Because today all the platforms are effectively brokers. It sort of kind of reminds me of like Wall Street back in the bucket shop era, where very few people actually traded on the exchanges. Everyone went to the brokers, and so I think maybe that's an area where decentralized, tech could help there, but haven't done anything yet.
And so actually on that point, Joe, I want to push you a little bit, because when your colleagues at Founders Fund recently published a well-received piece, or at the very least a controversial piece, sort of pushing for closed source AI over open source, given it's a better business model. And then a couple months after that, you go and lead an $85 million round into Sentient, which is explicitly building an open source platform for AI. Just tell me more about your thesis on investing in open source AI projects.
Yes, I think, first I'd say as a fund, Founders Fund is, very good at holding two opposing ideas in our head at the same time, and then, making decisions accordingly. We don't have like, one kind of, firm-wide, 1984 style thing that you kind of everyone has to agree upon. But even outside of that, I actually agree with kind of about 95% of that piece John wrote about closed versus open source AI. I think today it's true. The financial incentives for closed source are far better than open source AI. The reason is because once you publish an open source model, today anyone can just use it, and so it's very, very difficult to monetize off of it. Facebook has some ideas. Maybe they'll be able to monetize because they can monetize off their user base somehow, but even that's questionable. There's some talk that Zuckerberg will probably open source the next model, but it's probably not going to open source the $50 to $100 billion training run model. So I think that's part of it. The one part of the piece that I kind of disagree with is I don't think one of the other arguments for closed source is like national security concerns. And I think those are a little overrated, just in the sense that, if you kind of read the press, like, OpenAI was hacked in 2023. A lot of these security concerns, I would sort of just assume, like, if you made me bet on it, I would assume that, the Chinese government probably already has access to the weights of a lot of U.S. Closed source models, not based on any inside information, just based on what I would bet on. And if that's the case, and you kind of take the bet that it's very unlikely that the U.S. government or any of these private companies in the U.S. could actually secure our models, in a closed source world, then open source doesn't really have, the downside that it seems if you assume that the world is insecure, which I sort of do.
And to steer the conversation a little bit, Cheryl, we know each other a little bit, and you're one of my favorite skeptics in the crypto AI investing space. Can you tell me a little bit about, which like sub-verticals within this larger domain of crypto AI projects are most interesting to you? Where do you think there is a real need to decentralize AI? Like, what gets you excited?
Yeah, I think just to kind of follow up on what Joey was talking about, because I think what was important in the decision behind Sentient was really in that crypto kind of has this unique advantage in order to make open source AI profitable for its data contributors, for the model developers, and really the way it's trying to do that is by basically trying to have attribution on chain. And I think kind of having that win-win scenario of when crypto can inherently make AI better or the other way around is kind of why Dragonfly wants to be an AI crypto itself. So you've talked about how, I'm a little bit skeptical of a lot of these vaporware projects that have been going on in the space and raising 100 mil rounds right off the bat. I think for us, what's really important is kind of finding an angle wherein the hyper-financialization of crypto can make AI better. So for example, one of the projects that we recently invested in is called MyShell. MyShell is kind of today it's kind of like a tokenized character.ai. but in the future it has plans to be kind of a launch pad for AI assets. So if you look at it today, it's basically just a marketplace for AI chatbots, for example. And what crypto is inherently doing is creating this hyper-financialized aspect of social betting in which you can kind of bet on different AI agents that you think will be providing the most value going forward. So instead of having users paying for subscriptions to talk to chatbots in the way Web2 currently is, which is the usual monetization model without Web3. Now you're having Web3 speculators come into the ecosystem and kind of really bootstrap and hyper-accelerate that flywheel. So we're kind of looking for edge cases like that in which AI and crypto naturally can come together.
And then, Davi, to bring you into the conversation, are there any areas where you think centralization is really essential for a specific crypto AI project? Are there any sort of vectors within a startup stack that you think, maybe at least initially, centralization is good, and then there can be progressive decentralization? Sort of how do you think about this idea of progressive decentralization within the world of crypto AI for investments that you're looking at?
Yeah, so I think there's a spectrum of so there's a spectrum when we talk about decentralization, right? And then also, are we talking about the training itself? Are we talking about the data pipeline? Are we talking about the inferences? And then so I think there's a spectrum and there's a different stacks, right? So for us, and then so we don't look at the thing like that, and so probably just take a step back. So if we think about smartphone, right? So let's smartphone basically made all the the small consumer gadgets obsolete, right? Just like before smartphones, and we have camera, we have recorder, we have GPS, we have all different small consumer gadgets that we have to just collect for our daily applications. And then so I also think it will be probably the same for AI, and then so decentralized and then also DAI in the future, so that will potentially make all different SaaS application, and especially verticalized SaaS, and then so long, and then also long, and then verticalized SaaS as well as all this long tail SaaS obsolete as well. Just give you one quick example. And so we internally, we have a lot of meeting notes, and then so we don't, and then also recording and stuff like that. And then so I myself, I write a lot of my personal journal, and then also sometimes, and I actually record my dream as well. So probably wake up in the middle of the night, and I just quickly snap my phone, and then just talk about what I have dreamt, right? And then so for all this recording, and also for many lawyers as well, so they cannot, so it's much better for them to do local computation when it comes to process all of this information. So that's why when I think about decentralization, so I think about what the user need is, right? And then so currently we are running, Alpaca, which is a local model, and then because we don't want to upload any of this, we don't want to upload any of this material to the cloud and to the Microsoft cloud, right? And then so once we can, and then first of all, we have to run the local transcription. So that is one model from NVIDIA, which is small enough can fit into your local MacBook. And then once we have the transcript, and then so we just process all the transcript also using local model, right? And then so that is how can let the individual investor, founders, or future entrepreneurs so can safeguard their secret sauce. And so I think when it comes to the decentralization versus centralization question, yeah, and I think it's okay because for the new startup founders, it's very hard for them to just to battle with Meta, to battle with OpenAI when it comes to compute resources, and then so we can just let them to just dump money to all the computation problem, and then so once we have that, and then so when it comes to edge computation, local compute, and also verifiable inferences, and so in the future, and what Sentient is working on as well, so can also probably give alternative attribution model, so to empower all the individual creator and then just knowledge workers. Yeah.
Okay, and then I wanted to maybe take a step back, look at the greater landscape. This investing market has been kind of crazy for a while, and I think we've seen a lot of big rounds happening. As VCs now, how are you seeing pricing change Maybe Cheryl, do you want to start? How does it also feel as a VC to be in a market like this? Are you hoping that changes? What are you seeing?
Yeah. So you're also asking me off coming off vacation for 2 weeks. So my commentary will be pre-vacation. Yeah. This was a nice welcome back, by the way. I think I think we have been seeing prices come up quite a lot. And I think the reason for that is, it's never just the founders, but VCs have also been willing to fund projects at these pricing. I do believe in, demand and supply slowly working out. I do hear our founders starting to negotiate a little bit more on pricing. So it has softened a little bit in the last couple of weeks. But really, I do think that the overall risk reward probably hasn't been as attractive as it was, say, early this year.
Joey, maybe do you want to weigh in as somebody who was involved in one of the bigger rounds recently?
Yeah, I mean, I think, there's no way to deny it. Pricing is certainly, substantially higher than it was this time a year ago. It's probably substantially higher than it was this time 6 months ago. And I think it's probably going to still be substantially higher 6 months from now than it is today. I think, the implication of that is you just have to be a lot more selective in terms of, what investments you do make. I think there's also some investments where there actually is like a downside to raising, too much capital or a too crazy evaluation. And so there's some founders that are kind of very rational about that, because they've been a founder before or whatever. So those are, rounds that you can kind of always do irrespective of where the market cycle's at. I think, I think the market's definitely gotten, a lot crazier than it was a quarter ago.
And then speaking on founders, when you're identifying or evaluating an investment within the crypto AI space, how important is it for somebody in the founding team or multiple founders to have Web2 AI experience? Is that valuable to you? Are you wary of investing in pure Web3 founders trying to do this new AI thing? Joey, maybe you want to start again?
Yeah, I think it's useful to have at least one person on the founding team with some, AI background, whether that's academic or an industry. I don't think it's as important as hiring really smart AI people. I mean, the most famous AI company that's created the most valuable, other than NVIDIA, but if you look at the private markets, it's OpenAI. Sam Altman had no AI background. And so I think, whenever you have a super hard and fast rule about anything as an investor, there always tends to be some exception to it. But I think generally it's useful for sure.
Debbie, do you want to weigh in?
Yeah, and then also just want to add on the valuation question, right? So because I chat with a lot of these Web2 AI founders or Web2 AI crypto bandwagoners, so they have this very idealistic or just this fantasized moment on, okay, because WorkCoin is at the top is close to 100 billion coin, and then so I can launch 10% of WorkCoin or even 5% of WorkCoin, right? But the thing is most of them just don't understand how crypto capital market works, and WorkCoin is just a Sam Altman, so it's just a Sam Altman meme coin, right? And then so that is the fact that WorkCoin has no intrinsic value has most of the capitalization value. So many of these Web3 founders, so they just don't get it, right? And so their mental model is around this market valuation comparison, and then same for many VC as well. So currently for many this crypto VC, and I think their valuation model is just everything come to either WorkCoin or just Big Tensor, but BitTensor is a low flow coin, and then it's a POW low flow coin, just a virtual POW low flow coin, just from the start. So I think there's a lot of just totally unrealistic expectation when it comes to valuation, and we have seen most of the AI. The crypto AI thing try to raise a 200 million or 100 million as a pre-seed round, and then so now it's heavily re-rated. Yeah, so like one of the very notable ones, so like was raising at 300 million a month ago at like Dubai token 2049, and then so now the valuation like down to 100, and then so like once you try to down raising, and it's like a pretty weak signal, right? It's like a supply demand, right? So anyway, so when it comes to founder, and I think so like founder like yeah, so like definitely he needs to understand what like AI can enable. And then so what AI can and what AI can have a really nice like union point to so really nice union point with like crypto, right? And then also because if you're like a new founder and then you have to leverage it like your three capital: social capital, human capital, and then also intellectual capital, right? So to better raise. And so I think like if like a non-AI founder, like he or she can hire some relatively good like AI researchers, and then so that would be a really good sign. And then like the actual crypto dominant founder like needs to handle all this like financial populism stuff, right? And then so community branding, and like narrative crafting and like all this. And then so my advice for all the founders is that imagine yourself as like a producer of a movie, right? And then so you have to hire like the director, and then so also you have to work with like the director to hire like a cast of like actor and like actresses. So like that is like a rough like mental model we have.
Okay. I want to go down the line now, looking ahead, and ask, what categories are exciting to you the most within this space moving forward, and with a particular carve out for seeing a lot of infra companies getting funded in this space and not a lot of consumer projects. And I'm also curious, do you think that the crypto AI market is going to go the same direction of Web3 more generally, which is a ton of money in infra and underinvestment, and sort of, I think, associated underutilization of consumer applications? Let me start with Joey, and then working our way down.
Yeah, in terms of the AI side, I think the stuff that's less interesting to me is like the sort of on-chain, fully verified like inference or some of the zk-ML stuff. I think it's there's not really that much demand for people kind of either as users or on the AI community side. Stuff I'm excited about, what Sentient's doing. I'm excited about some of the GPU marketplaces. I think someone will create something on the consumer side, which is more like, probably by the time GPT-5 is out, it'll be possible to do this in a way that actually works really good, which is like, a really simple interface to use crypto, where you just kind of say, hey, I want to deposit, 100 ETH into MetaMask or into Maker and borrow, this amount of USDC, and then automatically send it to my Coinbase and sell it for dollars. And like, you should be able to plug into all the APIs to do that. Outside of that, the kind of more broader question of infrastructure versus consumer, yeah, there's still a lot of infrastructure stuff in crypto. We've been funding some stuff on the infra side. We've also been funding some stuff on the consumer side. I think, Polymarket's one of the bigger consumer bets we did. And I think that's going to continue to get even bigger, into the election. I think, there's one or two others as well that haven't been announced yet, but I think, I've been investing in crypto for, since like, 2017 as VC, and I'd say I've probably done, more consumer stuff, in the last 8 or 9 months than I did, in all the time prior to that. So I think there finally is some early consumer stuff starting to happen, but it's still early in a minority of deals as opposed to a majority.
This is a very loaded question, by the way. I feel like this could have gone on for like the entire 40 minutes. I think what I hate about a lot of founders raising is that they typically go for, okay, what is really highly valued in the markets right now? What is the narrative that VCs are pouring a lot of money in? Let me go start that right now. Many times it's pretty obvious from the first couple of calls. And so I would say that as much as we have a fiduciary duty to our shareholders, I definitely try to keep my eyes peeled to what actually makes sense, what can have actual product market fit, what makes sense technically, regardless of how it might be valued on the token listing. With that said, I think on things like on-chain training is still very, very difficult today. In terms of the infra, like architecturally, what it has to be done, the parallelization of workloads in a distributed way, it still does not feasibly make sense. So we have not been putting too much time there. I am very curious as to what has been happening lately in decentralized fine-tuning and model alignment, model distillation, model compression. I think that is very fascinating. Something like distributed inference, for example, which can be done on a single node, that's obviously very feasible today from a go-to-market perspective. That also seems really interesting. Like I mentioned, my shell, we've been investing heavily into consumer apps as well. So I think for us, it's more a matter of just first principles. Does it make sense? Do we think it adds value? Is there a way that AI crypto marriage can come together?
Davi?
Yeah, so I think for us is consumer versus infrastructure. Okay, so like infrastructure, so economic infrastructure is also an infrastructure, right? And then economic. So do you consider money as an infrastructure? So like as an economic infrastructure or as an economic application? Because I think like money is the biggest, both the biggest application and then also infrastructure when it comes to crypto, right? And just like this global magical internet money. So I think when it comes to crypto AI, and so for now, so like what we are seeing for now is, so there's a lot of, so what I consider those as a economic infrastructure middleware for like AI. Say for instance, we invest in Sapien, and like which is a like decentralized like data pipeline. So for future AI training, basically what Sapien is doing is OpenAI right now. So they hire like millions of like Africans in Nigeria, in Kenya, and basically to do their like human reinforcement learning. So on their AI model, and then so they basically pay like everyone like $1 to $2 like per hour, right? And then Sapien basically try to do it in a more like collective, like crowdsourcing way, and then just like make it pretty fun. So imagine just like an Access Infinity version, but for AI reinforcement training. So like that's what I consider as more as this like data, like just like this like data economic like middleware, right? And also like the other AI portfolio we have is like Hyperspace, and so Hyperspace basically is like a decentralized network of like local compute. Yeah, so like that is also, so that's probably more on like the infrastructure side. Yeah, and so I think like crypto, so like what is crypto really good for is for alternative distribution and also for alternative value attribution. So if you can build center around this like two fundamental elements, then does not matter whether you are like categorized as application or infrastructure. Yeah.
Great. Well, I think that's all the time that we have for this panel today. So three of you, thanks for your participation and taking these questions. And let's give them a big hand as we move to our next panel.
All right, everybody, we're going to get our next panel started. Our next panel is titled Bridging Web3 and AI. And we have Calanthea May, who's a co-founder of Masa. And we have a quick swap at the last minute. So we have Rakshak from Morpheus joining us, Himanshu Tyagi, who is a core contributor at Sentient. And this panel will be moderated by Christoph Niemann, who is a senior blockchain solutions architect at AWS. Welcome.
All right. Hello, everyone. As you might notice, it's not Neda there. It's Rakesh from Morpheus. Neda couldn't make it. That's why we have Rakesh happily fill in for us. This panel is about bridging Web3 and AI, which is obviously two very broad topics. Kind of hard to, I don't know, put it into 30 minutes altogether. So what we want to do is really try to cover both perspectives, if you will. Where can Web3 benefit from AI and the other way around? Where could possibly AI benefit from Web3? I'm Christoph, I'm from AWS. I'm a specialist for Web3. What that means is basically I'm helping customers using that are building on Web3 using AWS services. So if you want to, feel free to hit me up later on. With that, I'm going to give the room to each one of you to do a quick introduction. And then possibly we can just start with the first broad topic. Where do you see can AI benefit from Web3? Starting with a more complicated one, I think. I'll start with you.
Yeah, hi, I'm Himanshu Tyagi. I'm one of the co-founders for Sentient. Sentient, we are building community-built competitor to OpenAI. So good old AI, but built with community contributions.
Hi guys, my name is Rakshak, and I'm helping with Morpheus. I have a background in AI. I've been involved in it for 10 years, mostly in computer vision. And I'm helping Morpheus realize its full mission, which is to have everyone participate in being able to produce models, deliver model computation, and consume models in a decentralized way where we all retain sovereignty of these systems. Thank you.
Hey everyone, my name is Calanthea. I'm co-founder of Masa. Masa is a decentralized AI network where people earn by contributing data. Data in our minds is the currency of the future, especially in the AI era. It is one of the most valuable commodity that is required for AI model training and AI agent training. That's the reason why we decided to focus on it. Excited to be here today and super excited to share.
So very interesting. Maybe I'll start with you, Calanthea. All three of you are working in decentralized AI. The very obvious question is, normally LLM models, if they're trained, need lots and lots of compute, which kind of lends itself to centralized compute capabilities. So why would you think decentralized AI brings a benefit to the table?
Yeah, I'll probably give a very concrete example. Let's say if we want to train an AI agent that speaks and thinks like Sam Altman, right? So you would need to grab different kind of data sources. Ideally, you would want to have all the Twitter footprint, all the podcasts Sam Altman has been on, all the TikToks, hopefully nothing, but any of the TikToks that Sam Altman was featured on, and anything that is within his digital footprint territory. If you were to train it in a more centralized AI way, you'll have to pay for very expensive API access to Twitter developer API. You'll probably pay around $40K per month for enterprise version if you don't want to have severe rate limits. You want to pay a lot of money for TikTok data, and for some podcast data, you don't even have a very direct way of getting podcast data into more diarized structured data for AI agent training. At Masa, we help you solve that problem. We have a very decentralized network of node workers and validators, whereby they set up different kind of data scrapers, contribute their bandwidth and resources, and prepare those data into real-time, structured, and high-quality data for AI training. So one is possible in the decentralized AI world, one is impossible currently or very expensive in the centralized AI world.
Yeah, if you don't mind, I'd like to segue off your point. That's a great point. Here's the thing: the dirty secret is that we all train these systems. You know, all the reviews were written, all the blog posts were written, all the comments were written online. OpenAI or Google, none of them actually generated that data. And so we are already doing this in a decentralized way on the data production side. These are labeled by people, workforces all over the world. And in terms of where Morpheus is involved, we have a really bad chip shortage right now. We have 12, 18, 24-month lead times on getting sufficient amount of GPU capacity. But guess what? There's 400 million GPUs sitting in desktops and people's gaming rigs all over the world. And bringing those online is inherently a decentralized effort. It is a cross-border payment system empowered effort. So I think decentralization is actually the next paradigm. We had cloud before this, and now it's decentralization.
So what you're saying is basically both data should be decentralized as well as the actual compute.
Data's already decentralized. We already won that by default. And on the computation side, we can start with inference because there's going to be a sufficient amount of people that can run a model on 1 or 2 graphics cards that they have on their gaming rig. Mm-hmm. And we think that over time, you're going to have people build more impressive rigs the way they did for Bitcoin mining. They started with mining on their CPU on their laptop, and then they got more performant compute because they were incentivized. And Morpheus is enabling that incentivization to get people compensated for putting their compute online to run AI models in a decentralized fashion. And it has some really inherent positives because the person who's serving inference for you could be in the apartment next door. They could be a block down the street from you. And you're actually going to see better latencies with that as we scale out.
But then you did mention Bitcoin, and it seems to me like that might be a good example. Because, of course, the Bitcoin network in general is decentralized. But what we see with the mining capacity is that there is an inherent trend to centralize the actual mining capacity just because the resource requirements are so damn high that you need that specialized equipment.
So with Bitcoin and other these payment technologies, there's a higher tolerance to latency. You can wait tens of seconds, even minutes. In AI, when you want really fast inference response times to enable applications, people would never use something like Google Maps if it took 5 minutes to get a response. So you want it to reroute instantly. And to get something like that to work instantly when the computation is occurring at over billions of floating point operations per second, you want that to be really close by you. You want it to be on-premise. You want it to be on-device. And what we're seeing is Apple already saw this coming. So the M2 chip that came out 2 years ago, in the hardware, there's a transformer optimization. We need to unlock the software pieces. But we're seeing the bedrock of this next paradigm shift of edge compute, local compute, and decentralized compute already building up. Because for AI to work well, you need a lot of throughput. And you need that to happen instantly so that the human can't perceive that it's occurring. And so I think cloud is inherently doomed in that sense because of the massive latency penalty that you can't collapse entirely.
Yeah, your take.
No, what she said. So everything is already covered. But we should think about what we mean by decentralized AI here. It's sort of a brand name or a meme. But some parts of it I quite agree with. For example, the part about personalized data and how that can be used to keep AI which is personalized and with separate people. Many projects like that I agree with. Doing inference on decentralized compute the way Apple is doing, makes sense. I think projects have to find what they will do there, but it makes sense completely. People will be using AI on their phones. They are using AI on their phones and personal devices. All that makes sense. Decentralized training, unless the type of models we are working with changes, I don't see how that happens because the latencies will dominate. Even in the inference side, decentralized inference, if these are applications which are critical for latency, then I don't see how that happens. So there are a lot of challenges, and I'm not completely convinced that decentralized training kind of things will pick up. But data, I think people would want to work on their data, on their personal devices. They want their different types of AI to be doing their scheduling for them. All that will come in.
which would then help with personalized models as well. If you're saying, I need this private data into my models that no one else can have access to.
Personalized models, personalized AI, not necessarily personalized models, but yeah, some kind of personalized models. I don't. Before crypto, I worked a lot in federated learning, and we try to do a lot of things. But at the end, what worked out in federated learning is just training your personalized model on your personalized data. Those kind of things have been going on forever, and they will continue. For example, the way Google handles your optimization of your photo library, right? That's federated learning going on forever, and the natural continuation of that to language models will come up. I understand that, yeah. So personalized models, yeah, that will continue.
Yeah. Were you going to say
I was
something?
thinking about some personalized AI agent because that's one of the most popular use cases we're seeing on the Masa network. Probably just to share a fun fact, I know it's late afternoon and people want to hear some fun facts to perk up. So loneliness is one of the biggest problems of the generation of late millennial and Gen Z. And if you look at a lot of popular social applications nowadays, whether it's in Web2 AI or Web3 AI, a lot of them center around the idea of AI companion. It could be an AI boyfriend, AI girlfriend, could be your AI assistant, could be your AI digital twin, could be your AI guardian angel, etc. How cool would that be if you had that AI agent to be trained specifically on your digital footprint? That way, your AI agent probably knows you better than you do. I certainly want one of those for myself.
I'm not sure if I want to go into that, but you, really? So I see that use case. It's obviously very personalized. There are a lot of moral implications to that. We probably can't cover them here. But it is interesting that, and obviously there's demand for it. So. Now, you were saying decentralized training is something that you think is possible. How so? I mean, the latency requirements are still there, right?
Yeah, so I think when people hear decentralized inference or training, they mix it up with distributed training and inference, and those are very different things. You could do both. You could do one and not the other. They're separate things. You have to make two different decisions there. So what I see is an SSI model. It's called single state image model, where a model must be loaded onto a single computer. That computer may have multiple graphics cards attached to it, but there's really low latency in the NV link between those cards. Not you run half of the model on one guy's computer, another half on another gal's computer down the street. That's a really bad thing, and that would be distributed. And so what I'm foreseeing, and we'll see how, if time proves this right or wrong, is you're going to see people who run a single model for inference. You can do that with a single card if you're running like a 8B Llama 3 8B, which is the most powerful model right now that's open source. And these people are going to build more impressive rigs over time as they're getting incentivized and they're getting compensated for offering inference. And they're going to say, hey, how can I make more money? Well, I'm going to go put more compute in whatever facility I have, whether it's my home or if it's a storage facility or if it's a warehouse. I'm going to go put more compute up, just like it happened with the mining for Ethereum when it's proof of work or for Bitcoin when it's proof of work. And then you're going to have people that have hundreds of cards attached to a single computer or a really high, low latency cluster, and they're going to say, hey, I actually now have the capacity to load an entire model and train it because I built up to that point and I was compensated up to that point. So this is just a matter of time and having the incentive structure built out, and Web3 is perfect for the railings on that. And that's actually what got me in. I'm not from Web3. I have an AI background, and I saw this as the only way to make this work.
I'm still not sure if I agree, to be honest.
Sure.
So, if
you shouldn't agree to it, right?
I should not.
Yeah, you're from AWS. You have to say that.
Right.
You have to say that.
He's from AWS, so.
No, but what I wanted to bring as an example, again, Bitcoin mining was in the early days possible to do on your laptop somewhere at home, or even on some sort of sophisticated hardware that you spun up at home. Nowadays, it just isn't because the compute requirements are way too high for that. With other blockchains, proof of stake, it's still possible, but there aren't any compute requirements to it. It's just, well, it's monetary requirements, of course. But then with if for training, we have these high compute requirements. We need specialized GPU resources and lots of them. So I don't really see how that's going to happen, even if you're building at home and having this whatever kind of rig with lots and lots of graphics.
I love the word you just said there, specialization. I love that word. Here's why. Bitcoin became over-concentrated after the advent of ASICs, right? What is an ASIC? An ASIC is a chip that can only do one thing, okay? So it can only do this Bitcoin hashing function. It can't tell you the weather. It can't open your calendar. It can't do anything else, right? Well, for AI, you need general purpose chips because you're doing a whole host of computations that can change over time. Mm-hmm. You wouldn't build a chip for one model. You would build, there's a company called Grok, and they discovered this already. And so what they did is they built a translation system to SRAM, and they can adapt to anything. And the reason why that concentration happened in Bitcoin is because, well, there was no one else who would buy a chip for anything else, right, for these ASICs. So I think when you think about AI, it's a different type of computation entirely, and we're using GPUs. And even if we use something like Grok that's more commoditized, I just don't see that level of concentration occurring in a way that would only benefit a few parties. We might have, a much larger distributed force of compute, and you don't need to deal with like the energy and cooling costs in the same way when it's spread out. And so I think there's some inherent value there.
Mm-hmm. Very interesting. Maybe I do agree to some.
Well, the thing is, we don't fully know, and we're taking our bets, right? We have Morpheus, and we think that the decentralized vision is the future. And at least at a technical level, when you're building out the fundamental primitives for these things, we've seen things like with Linux and Android that the open standards tend to dominate. And AWS has also been great at adopting these open standards too. I mean, there's been partnerships with a lot of open source companies for a reason, because you get more diversification there. And in AI, and anytime when you're new in an industry, you want high diversification to get all the vantage points in, right?
I want to shift gears a bit, turn the whole thing around. For now, we've been talking about how AI can profit from Web3 ideas, basically data sovereignty, data isolation, private data, these incentive mechanisms as well, probably. How do you pay for contributing your hardware or your resources, your data to the AI model? I want to turn it around a bit and ask, is there anything where Web3 can actually benefit from AI? Basically asking for use cases that you've seen, and which ones do you foresee? Because you did mention the personal assistant already, which is not really Web3 related. So focusing on the ones that are Web3 related and helping us there, if you will. Do you want to start?
No, I don't want to start.
You don't?
No, Web3 benefiting from AI. I think it's the things we see are, there's a few patterns there and they're exciting, like how these agents will build and they will express intent, mostly around intent. And then also things around safety, auditing. The concern I see in those spaces is the accuracy that's typically required for something so specific. And so I'm not sure which one will pick up first. But for me, actually, I would love to have this agents who can execute things based on my intent. And that's the space, at least I like. That's a very cute space. We also what happened in prediction market, and getting AI layer there is very interesting, getting more data mined on it and getting things from that side. So they can be these kind of threads. They can be more intent-based threads where Web3 can benefit from AI. AI basically becomes a universal interface. It's not just about Web. When I'm talking about these use cases, there's not so much Web3 in it as just having this interface, which has changed how I talk to all software, including Web3. And it has to be specialized for all the software, so there will be definitely a vertical for specializing for Web3. That's a no-brainer. Whether it can go beyond, and if there's something deeper, like companies trying to do security audits, for example, using agents. That's interesting because these structures have been able to show efficiency in capturing information which has not been there before. So maybe they can also do the search very efficiently. What's happening on RL, maybe they can do something very efficiently there, and therefore they can bring in new kind of much more accurate security audits. That's possible, but harder.
Yeah. Any one of you?
Sure. I think I already mentioned earlier a more social use case, the fun AI boyfriend, AI girlfriend. Another very fun use case of how AI can help with crypto is really financial. Presumably, we have a lot of investors in the crowd here. imagine if you have an AI agent who can tell you how low Bitcoin could go a couple of days ago. Wouldn't that be nice? So financial use cases is one of the most popular use case we're seeing on the Masa network, using a lot of social sentiment data in order to predict trading behaviors and predict market trends. That's definitely one area where AI can help with the crypto market, especially on the trading side.
Yeah, so if you want an agent to, so to answer your question, to make it easier, I think Web3 is hitting a wall in adoption because it's complicated. And so one thing that agents can do is, like what he mentioned, is being this natural interface where anyone can talk to it and get the outcome that they want. So the cool thing is you can already do this. If you go on mor.org, we have an agent it's an early test version. You can say, hey, I want to swap this for that, and it'll construct a transaction. And you mentioned accuracy concerns, and I completely agree. Agents right now are not 100% accurate. And so one of the steps we've taken for now is it just generates the transaction for you, and you can sign it, and you can review it. It never has your keys, right? Don't give agents your keys, guys. Seriously, it doesn't have your keys. It can't execute it even if it wanted to. But at least it got you to that last point where you can say yes or no. And fundamentally, when you hire someone, whether it's to fix your dishwasher or to help you write a report, that's what you want. You want the outcome, and you want to just verify that that's what you wanted, and you go ahead with it, right? But they take care of all of the nitty-gritty in a black box for you. And I think that's what these agents are going to do. First, they're going to be tools that just make you work faster. But over time, they're going to be like colleagues. And what I see is these agents are going to go past that, and they're going to help not just be trained, but to actually train you and the workforce. And so I think there's a lot of positive upside there.
Well, coming to the agents or the AI training you, one thing that I see is obviously development experience. If you are developing, that's where AI can help you by a whole lot. And it is particularly so in Web3. Anything blockchain related requires very specialized skills, specialized programming languages, and it's easy enough to fall into various traps that they lay out for you. And I agree, AI can help with that. And in turn, of course, train the actual developer in not making that mistake again. So there is some overlap, I think. Yeah. But then, now we did cover development experience and then, of course, anything financial related. And that's always the first thing that comes to mind because blockchains seem to be or are very, very good at it. We have very new financial mechanisms and stuff that only are possible on blockchain. If you go any deeper, do you see anything else where it could help? Something like, again, I don't know, analyzing data, blockchain data itself instead of just sort of social sentiments, like you said, for trading? I mean, just one last sentence. One thing that we have with blockchains is, of course, we have all this transparent data. So we could start training AI on that blockchain data. Do you see any benefits from that?
This one I can start with.
Yeah, you're welcome.
No, so you bring out a very good point, but that's a very hard problem. Can there be so-called a foundation model for all the blockchain data?
Yes.
Because this data is very structured. But this is a very different model. This is basically a model which can handle time series, and this can handle that kind of data. You see its financial capability will be very high. And whatever I see in this space so far is not really a single model, because a single model is, the magic of foundation model is that don't solve the individual problems. Very counterintuitive, very counterintuitive. For decades, we have been solving individual problems. And it turns out the better idea is to solve something which is not specialized for any of them, but it solves all of them together. Yeah. And very counterintuitive, something similar. So you will have 10,000 problems which you want to solve in terms of prediction on chain. And all this knowledge is available. Just to think of just Ethereum data. What general intuition can we build out of it, and what will that foundation model look like? And that will be a challenging problem. The projects and the efforts I see so far are actually solving individual problem and calling the union of it as a foundation model, which is not at all a foundation model, actually. That's the old approach. It has to be this generalization across tasks. Yeah, looking forward to any breakthrough like that.
Yeah, me too.
So yeah, that's a great point. There is no single model. He's right. There's no single model that can do everything. This is proven in physics. It's called the no free lunch theorem. There never will be a single model that does everything. Sorry for the spoiler. But what we can do is have it augment or even automate process of EDA, which is called exploratory data analysis. So you would have statisticians turned ML engineers for over 2 decades now that have been doing this, and they look at data and they analyze which features or which parts of the inputs are going to contribute to an outcome that I care about. And so what you can do is you can basically augment, speed up, or even automate that part of it. Right? So you have an agent, and all it does is, for example, it just writes code. And that code is to do EDA, or to do some aspect of EDA. And then it can send that off to an analysis agent, and it can look at the outcomes of these EDA programs running and say, oh, can you go write another program to do this other thing? And then eventually they should collaboratively in a multi-agent framework arrive at a conclusion that's similar to what a team of statisticians might come at. So I think we're not too far from being there. I think the code generation that we're seeing from these models is getting better by the year, and so we should see a lot more of this pretty soon.
I think that sounds like a nice vision. You've got 10 seconds to go if you want to add something to it.
In 10 seconds, I think this is a very difficult question because I cannot think of an area within Web3 that cannot be improved by AI, to be honest. AI brings automation and efficiency to everything we do, from coding to marketing to go-to-market to building a community to product improvement. Everything can be AI'd, and we're here to build it. 10 seconds?
Yeah, that's a good closing words, I think. Thank you very much for participation. It was very interesting for me, at least. Hope for you as well. And thanks a lot.
Thank you.
Hello all, welcome. Thanks for being part of our open AGI session. The part of AGI is AGI itself, and what we wanted to do as part of a broader workshop here is to invite top AI researchers, thinkers, scientists, and to talk about their vision for both the decentralization part and the AGI part. That's what this event is. And in the first panel, here, it's not so much a panel as inviting a few speakers from pure AI world to talk about their vision for what decentralization and AI look like. And in the very first one, we have two scientists, AI scientists, talking about their vision. One is Colin Raffel. Colin Raffel is a professor of computer science at University of Toronto. And the second talk will be by Atlas Wong. He's a professor of computer science and electrical and computer engineering at University of Texas at Austin. They both also have their industry and startup hats. One at FX Markets, Atlas, and Hugging Face with Colin. And given we're very happy to have their vision, and the way we did is that we requested them to give record specifically for our event and audience what their vision is for decentralization and AI. And they're quite experts at it themselves.
Hi, my name is Colin Raffel. Thanks for having me. I'm going to be talking a bit about some of the work that we do on my group, and this is work that aims to make it possible for a distributed community of individuals to work together to build powerful AI systems. So let's get started. So as many of you know, a dominant paradigm for building AI systems today is to use large language models. And what we expect large language models to do is to be able to perform basically any text-based task. So we want them to be general purpose. In other words, if I ask a large language model to do something like summarize the following article, then we hope and try to get large language models to be able to output the summary of the article. And importantly, what we expect is that we only need one model to do pretty much everything. We don't need a specialized model for summarization and another for paraphrase detection. We really want one single model, one single set of parameters that can do basically everything. And what I'm going to talk a bit about in this talk today is an approach for building similarly general purpose AI systems, but that takes a different path that I think has various benefits that I'll discuss. And specifically, the approach that I'm going to describe, I'm calling an ecosystem of specialist models. So what do I mean by that? I mean that rather than having a single model that we expect to be able to do everything, we have a huge collection of models, each of which is specialized in some way. Maybe it's particularly good at processing text in some particular domain, or it's specialized to some task, so it's very good at summarization and not very good at other things. And the hope is that if we have a big enough collection of these models, we get a pretty decent coverage of the kinds of things that people want to do with the AI system. But importantly, I also think there will be ways to make it so that such a system can actually generalize to new tasks. And that's something that I'll be talking about today. So even if we don't have a specialized model for some particular task or domain or setting, we can figure out a way to combine the models in our ecosystem in order to have our composite system be able to generalize to new tasks, to be general purpose in the way that we expect large language models to be. So let me talk a bit about this approach. And I'm going to talk about the approach by answering the following question: how and why should we build ecosystems of specialist models instead of monolithic models? And I'll answer this question in various ways. And the first thing that I'll point out, which I think many people know, but people don't talk about very much because it's very unsexy, is that specialist models are often cheaper, they're more computationally efficient, and they're sometimes better. And there are, I think, lots of examples of this holding true, scattered about, but one piece of evidence for this that is honestly pretty out of date now, but I still like to highlight it because it's work for my group that I'm proud of, was a paper that we wrote showing that if you took a very small data set and you fine-tuned a language model on that data set, if you actually performed training with that data, then the specialist model that was trained on that data set would outperform doing few-shot in-context learning with a large language model. And if you're not familiar, few-shot in-context learning is where you take the small data set and you basically just concatenate all the examples in the data set and feed it as input to the language model. And this is, or it was, and still to some extent continues to be, a common way to get language models to get large language models to perform a task, maybe with a bit higher accuracy. But in our case, we showed that not only does it work better to do fine-tuning, but also you can fine-tune a much smaller model, and when you use the model, you don't need to feed in the examples in context, so the whole thing ends up being quite a lot more efficient, about 1,000 times more efficient in this case. So another thing I'll point out when you're thinking about what an ecosystem might look like is that there are lots of ways that we could build such an ecosystem. One is, to just collect a huge diversity of models, different model architecture sizes, etc. But one promising way to build an ecosystem would be if each specialist model was actually a cheaply communicable update to some shared base model. And there are reasons that this would be advantageous. It's not a requirement, it just maybe would make things work especially well. And so let me describe what I mean by a cheaply communicable update. And for those of you who are familiar, I'm going to be talking a little bit about parameter-efficient fine-tuning. And what this is it's a way of updating a base model without updating all of the model's parameters. Because one of the reasons people are afraid of doing training now is that they don't want to have to store an entirely new copy of the model's parameters every time they perform any kind of training. But in fact, the results that I just presented a moment ago, comparing few-shot fine-tuning to few-shot in context learning, those were results using a parameter-efficient fine-tuning method that we developed called IA3. And IA3 is notable because it only updates about 0.01% of the model's parameters, but in the experiments that we ran, we actually showed that it outperformed updating all of the model's parameters. So you can update a very, very small number of parameters and still get very good performance. And in subsequent work, we showed that you could actually further compress these updates. And specifically, the way we compress them is by looking for the largest changes and zeroing out the rest, and then quantizing those changes and only storing their sign. So basically, we have a consistent magnitude across all the changes and store the sign. And this saves space because now we kind of have a sparse update, and we only have to store the magnitude and the sign, which is the sign of each update, which is a binary value. And so we can get further savings in size, and ultimately, for a model with tens of billions of parameters, we can store an update, a parameter-efficient update that specializes the model to some particular task with only on the order of tens of kilobytes of storage. So if you want to have an ecosystem of models and have 10,000 of them, well, that's totally tractable if each of those specialist models is only tens of kilobytes. And you could imagine having all of those models all at once on a single GPU, for example, or at the very least on a single server. So just one way to do this, not the only way, but it solves maybe some of the system-style challenges and objections you might have. Okay, so now to describe a component of an ecosystem that I think would be especially important is the ability to choose the appropriate specialized model for a given query automatically. So why is this important? It's because when I use a large language model, I don't select which task I want it to perform, I just describe the task in natural language. And why is that important? Well, if I had to select the task, that would presuppose that I could only select one of a small set of tasks. If I want to be able to generalize to new tasks to perform, to basically to be general purpose, I need to be able to describe basically anything that I want the model to do. So at the very least, we need to be able to choose the appropriate specialist model for a query automatically. And one of the ways that we've attacked this problem is to show that if you are training these parameter efficient updates to a base model, if you modify the training procedure just a little bit, we showed that you can, there's a way to get what we call routing vectors and build effectively a mixture of experts style model for free. So this is a model where you have a pool of these adapters, you have a router that takes activations at some particular layer and chooses which of the adapters to use. And the nice thing about this again is that you don't end up having to specify explicitly which adapter you want to use. You can just describe the task that you want the model to perform, and then based on the activations, the inner processing of the model, it chooses the appropriate specialized model for you. And importantly, it enables a generalization to new tasks. So even things that you don't have a specialist model in your pool for, we show that it can generalize quite well to new unseen tasks and capabilities. Okay, so now I'm going to kind of tackle what I think is the biggest leap in this direction, which is again, this question of generalization. If we have a pool of specialist models, but we want the aggregate system to perform something that we don't have, perform a task that we don't have a specialist model for, how can we do that? How can we generalize to new settings? And to me, one of the most promising ways to do that is via model merging. And some of you may have come across model merging. Model merging, it just provides a way of combining models in hopes of combining their skills, combining their capabilities. And so to give you kind of a view of what that might look like, usually when we update models or when we want to get a model to attain new capabilities, we perform additional training, right? So we find a data set that corresponds to the task that we want the model to perform, and then we train on that data set. And that's kind of what's being shown on the top. Now, what merging allows you to do is to take models that have complementary capabilities and rapidly and very cheaply, without training, combine them to get an aggregate model that inherits the capabilities of the constituent models. Okay, so what does merging look like? Well, in the paper listed at the bottom here, we showed that you can view merging as the optimization problem shown at the top of the screen here. And if you make a common approximation in this optimization problem, there's a closed form solution. And I'll describe a very simple case of this closed form solution. It's just averaging the parameters of the models together. So if we have two models that share an architecture and we just average their parameters together, then we can perform something that looks like merging, that basically does what we want it to. And if you make some more sophisticated approximations, things can work a bit better, but the basic idea is there. We've also done a bit of work on more sophisticated merging schemes where we try to determine when the two models or however many models being merged kind of have parameters that conflict in some way. So if we average them, they would just get zeroed out. And so we prune some of those parameter values and have the non-pruned values kind of vote on what the sign of the merged value should be. And this produces a method called ties merging, which we showed works even better than doing simple parameter averaging. So the last point that I'll make is that if we want to build ecosystems in this way, and we want to make it easy for lots of people to contribute, then we need to build systems. And so I'll talk about two systems that we've built that make collaborative development of ecosystems like this easier. The first is called Git Theta, and Git Theta is a Git extension. Git is one of the most popular version control pieces of version control software, especially for keeping track of changes to code bases. And what Git Theta does is it extends Git so that it can keep track of updates to a model checkpoint. So as I perform parameter efficient fine-tuning or as I perform merges, Git Theta keeps track of all of that in a standard Git version tree. And Git Theta makes use of a Git LFS backend, so it's supported on any system, including, for example, GitHub or the Hugging Face Model Hub that has a Git LFS backend. We also built a system called Petals, and the goal of Petals is to enable inference and, to some extent, parameter efficient fine-tuning of large models on volunteer computing. So in other words, if you have a volunteer who says, I'm willing to run inference on these layers of this model, and then you get enough volunteers to cover every layer of some particular model, Petals figures out how to route requests through them over the consumer internet and do inference efficiently. And notably, it does inference without requiring anything of the end user, of the person who actually wants to perform the inference, because it handles the routing of requests, and also the compute itself is given by volunteers. And because of the way it's architected, it also can enable parameter efficient fine-tuning reasonably efficiently. So that's all I'll say about this work that we've been doing. If you find it interesting, feel free to contact me. And also, if you have any feedback on my talk, you're welcome to give me feedback on the link in the screen. Thanks a lot. Bye.
Hi, everyone. Thanks for having me, and I'm delighted by this opportunity to share our recent research about democratizing LLM training by exploiting low-rank gradient. I hope that could be of interest to this audience who are interested in decentralizing AI. Let's start it by something everybody knows now. Large language models are so powerful. They help us do conversations, generate plausible content, do a form AI agent, do complicated reasoning, and even sophisticated planning tasks. But same well-known as their capability, everybody also knows training or even fine-tuning the best large language models is extraordinarily expensive and beyond most, if not almost everybody's resource availability. That comes with multiple bottlenecks. Training the best large language models need the highest end GPUs that cost money. And even the best GPUs will take days or months to train, and not to mention about the data and the human resource you need to pay for that efforts. So people sometimes say, in very soon, training language model will not only be beyond the individual's reach, but even beyond the reach of even small countries' budget. Our vision is to democratize the training of LLMs. We ask the question, beyond using the highest end GPUs, is it possible to democratize LLM training with those cheaper ones, those consumer grade GPUs, not those expensive ones in the data center, but those available in your computer or even someday in your mobile phone? So we took a look comparing between those good GPUs, those top-end GPUs such as H100, A100, those most popular in data centers, and the consumer-grade GPUs. For example, the 4090 is a good GPU for gaming purpose, and you can often find it in good desktops. So comparing their specifics, we find that they are actually not too far away in terms of compute ability. For example, you can look at the FP16 compute performance between A100 and 4090. They are not too far away from each other. But the biggest difference lies in their memory and communication, which is necessary because nowadays LLM training involves massive dataset and huge storage for model parameters, gradients, and other training artifacts. So when you see such a big price difference between the high-end GPUs of H/A100 versus consumer-grade GPUs, those 10, 20, or even hundreds of times of differences, those are where you pay your money. You pay the money for GPU memory and communication, not necessarily for compute power. So looking at this limit, we realize that contradicts. So this seems to contradict with the current trend. If you talk to any LLM researcher, many will tell you scaling is all you need. That is, keep increasing model size will solve most of our research problems naturally. This is a topic on the debate, but there is no denying that it has become the common practice of most industry companies leading LLM research nowadays. So is there any chance that can save us from keep scaling the model while keeping the GPU memory war? Is there any chance we could use those consumer grade GPUs while scaling keeps to dominate? And our answer is there is a chance to mitigate between the two. You could keep enjoy your big model as long as you keep your gradient small, because it's the model and the gradient constitute the major training memory cost. So if you can reduce gradient, you can save more size for model scaling. Is that possible? Technically, it turns out yes, by discovering one fact, that is the inherent low rank phenomenon in LM gradients. When we talk about low rank, let's start from some arguably most familiar method regarding low ranking LLM called low rank adaptation or LoRA. It is a parameter efficient fine-tuning method. Given a pre-trained large language model such as Llama 7B, it will fine-tune the language model to fit a downstream domain by assuming the fine-tuned weight equal the summation of the original pre-trained weight and the weight delta. And this weight delta could be represented by a low-rank factorized format. And this low-rank factorization will save much space compared to the original dimension of the weight. And that's where LoRA could save you lots of memory. LoRA could have or become the de facto method in fine-tuning, but with certain caveats. Number one, LoRA could only fine-tune the model. It cannot pre-train a model from scratch. And number two, LoRA is a kind of ad hoc solution by assuming the weight delta to be low rank. It also changes the original optimization objective. So that motivated us to go beyond the LoRA and develop a new method called gradient low rank projection, or GALLO. GALLO is capable to save memory for both pre-training from scratch and fine-tuning. For the first time, it is able to reduce the pre-training memory cost of a Llama 7B model under 24 gigabit. That is below the memory of RTX 4090, a good custom consumer-grade GPU, which is encouraging for the first time. And by third-party evaluation, in fine-tuning cases, we also outperform other existing solvers, such as the 8-bit quantized ADAM-W, by using less than half of its memory and a higher token throughput and comparable or better results. So let's look at what GALLO does. It's a very simple algorithm, in fact. We have 3 steps. First, compute the gradient in the original space, and then project that into a low-rank space using the SVD of the past gradient, or in fact, other low-rank projectors are possible. So we usually choose the rank to be very slow, so the projected gradient is much smaller in size compared to the original. We do the update in this projected space, and after that, the update is projected back into the weight space and update the weight. So in this way, we are saving the grid. We are saving the optimization state and the projection weight, the optimization state from original full ranks 2MN into 2NR. Remember here, R is our rank. So compared to the original main, it could be thousands of times smaller. That's where the memory saving comes. With this simple 3-step recipe, project a gradient, updating projected space, and projected back. GALLO is compatible with all the mainstream deep learning optimizers, such as ADAM or ADAM-W, because they could just be plugged in to be used in this projected space. Also, beyond an ad hoc method, GALLO is a provable method, and in our paper, we show that the gradient will be provably low rank. For large transformers, the weight trajectory is guaranteed to move in a few low-rank subspaces along the training, so it becomes principled. In pre-training, GALLO can pre-train a Llama 7B model with a token batch size of 256 on a single device, without active checkpointing and memory offloading. So that enables training Llama 7B on RTX 4090 for the first time. Also, we cite another third-party report on fine-tuning result. So people fine-tuned the Llama 7B model on the same consumer GPU 4090 with a 70 gigabit VRAM, and they found the loss curve dynamics to be almost identical with the full training, showing that GALLO is able to recover the full training dynamics. And that's also manifested in the close performance between GALLO's fine-tuning result versus the full tuning result. And remember, the full tuning result is thousands of times more expensive in memory compared to GALLO. And then compared to another method, the common method, LoRA, GALLO consistently perform on par or better. And because it's an attractive trade-off between memory and performance, Gallo has been popular in the open source community and implemented by leading open source libraries, including Hugging Face, PyTorch, and Llama Factory. Even further, our recent method has integrated Gallo with quantization. That is motivated by the observation that popular laptop GPUs, such as RTX 4060, are equipped with up to 16 gigabit of memory. So we set 16 gigabit memory as our next goal up to 24 gigabit, and we reach our goal by carefully study how to quantize each part of Gallo algorithm. We found that some part of Gallo algorithm, such as a projection step, can be deeply quantized without affecting the performance. And by reducing the memory cost further from 24 to 16 gigabit, we can fit the pre-training of Llama 7B into 4060 Ti, and that will reduce the price further by more than 3 times based on the price as of August 2023 in GPU hardware. And Gallo has this new algorithm we call QGallo has further pushed the boundary of memory performance trade-off. At the pre-training stage, our new algorithm facilitated training a 7B model from scratch on a single 4060 Ti with only 16 gigabit memory. At fine-tuning, it reduced memory consumption also by 50% compared to LoRa and Gallo, while consistently outperforming QLoRa, another quantized fine-tuning solution, by a large margin at the same memory cost. With that, I hope to share you with our vision that in one day, everybody should be able to train their own language models with their own GPUs, however many and wherever they are. And I would like to attribute the thanks to my collaborators, and thank you for your attention. Bye.
All right, we are going to move into the next panel, which is building the infrastructure for Open AGI. For this panel, we have Vidhan from Bagel, Michael Heinrich, co-founder of Zero Gravity, Mohammed Bayoumi from EXO, and we have Farhat standing in for Alton from Nuffle. And the panel will be moderated by Itai Elzer, managing partner at Market Across.
Turn it on, or is it on? Perfect, it's on. All right, great. I'm not checking Telegram, I just have the questions because we want to be eco-friendly. All right, perfect. Welcome everyone to Sunday, EthCC week. It's going to be a heavy one. And there's a term that you might see a bit in this week thrown around a lot, and that's AI. And that's what we want to try and a bit demystify and understand a bit more about here. So I'd love if everyone can start with a very brief introduction of who they are and how do they find themselves sitting at an AI side event in Brussels.
Hi, I'm Mohammed Bayoumi. I studied in Oxford AI and robotics, so that's how I got into AI. Currently, I work on something called EXO. It's an edge AI protocol, how you run AI models on edge devices like phones and laptops and so on. And I found myself here because I got a message on Telegram, hey, you're on a panel, so here I am.
Hi, everyone. My name is Bidhan. I'm the founder of Bagel. And in my previous life, I used to be the AI ML infra lead for Amazon Alexa. That's how I started my career in AI and machine learning. And Bagel is a decentralized machine learning platform where you can fine-tune your models in a totally decentralized way.
Hey everyone, I'm Michael, co-founder and CEO of Zero G,
And on our team, we've got probably 8 computer science PhDs. Our team wrote some of the first AI algorithms for Microsoft Bing as part of Microsoft Research. And so definitely spent a lot of time thinking about AI, studying AI, researching AI, both from a distributed storage, distributed kind of scalability perspective. And so what Zero-G does is we're the fastest modular AI chain. And so we're building data infrastructure so that fully on-chain AI is actually possible. We're starting with storage, then adding on top of that storage system a data availability system that can do tens of gigabytes of throughput, so many orders of magnitude faster than what's available to date. And then another product we're building today is a decentralized serving layer so that you can register as a serving node for any type of storage or AI inference requests, whether it's TEML, ZKML, and so on. So very quick synopsis.
Hey everyone, my name is Firat. I'm CTO, co-founder of Snuffle Labs, which recently spun off of Near Protocol, which is one of the main AI-driven chains at this moment. Also in our team, we have now just recently hired a someone who's done PhD on AI and ML. And what we're doing at Snuffle Labs is basically providing modular infrastructure to anyone. Doesn't have to be just the rollups. Which one of them happens to be on mainnet right now, which is RSS3, that is specialized rollup on AI.
All right, perfect, cool. So I know you're asked this a lot. It seems like a basic question, but I do think that we should start the conversation with that. So the panel is about open AI, and of course, by the way, this term is now also being used a lot by ChatGPT themselves and developers of that. So other than ChatGPT's after my children or whatever, why do we need a decentralized AI network? Like, why is that so important? Why does it, like, other than everything else? Everything should be decentralized, banks should be, social should be. Why AI specifically is important for it to be decentralized, in your opinion?
So that we don't end up working at McDonald's. No, just kidding around it. But kind of our view on this whole perspective is that imagine, 10 to 20 years from now, you've got a bunch of AI agents. They're starting to run specific things in society. Could be traffic control systems, could be manufacturing systems, could be governance systems. Do you feel comfortable giving that much power to centralized AI entities, centralized AI companies? You have to trust them basically to tell you, this is the version of the model that we're running. This is where the training data came from. This is how the weights were constructed. That's a lot of power over society in a few companies' hands. Why shouldn't AI be a public good? And why shouldn't the mass really benefit from that? If you can have a system where you have fair rewards distribution, anybody that contributed data to a model, why not benefit from that? Why not have economic incentives and disincentives governing these models, governing these agents? Blockchains are built for that. They're built for basically an environment that's adversarial. And so a lot of those type of challenges have already been solved. So it could be as benign as an AI agent that's running trash control and trash pickup in a city, where basically it could say like, hey, I'm super smart. I can go into a centralized database, basically just add a lot of entries and then say, hey, I've done all this work. Here are all the deepfake pictures of me doing this work. Give me the reward. Much easier to do in a centralized system, very difficult to do in a decentralized system. And that's why AI deserves to be on a blockchain.
Okay, so a centralized entity that rules, like if Google had Google's power just in AI, you're saying that it's more dangerous if they have the power to control search, or if Facebook have the power to control social. AI, we believe, is exponentially different in that type of environment. Okay, cool. That's one reason. Anyone we're just trying to understand why we need in parallel to build this.
Yeah, maybe another topic, which I also agree with you, that keeping the system decentralized is going to provide some kind of policing to the AI that even big companies are kind of developing, right? Another part of it is connected to this is basically making it verifiable and on-chain, so that if we define some rules, we need to, if the AI needs to follow it.
Transparent, we can make sure, okay. But I also think about innovation itself. Like, we want to see a lot of innovation in AI, and if we let OpenAI or three other companies rule it from beginning, then we're not going to be able to harness the full power of entrepreneurs, because it's not a lot of situations where someone like the market share that OpenAI has been able to get in this space has been from 0 to maybe 95 in a month or 2 months or 3 months. So there's also just the ability of harnessing new innovation, and open environments, I think, are much more open for collaboration and innovation. What about that? Like, how much is it just for entrepreneurship?
Yeah, I'll answer previous question first. Like, why AI needs to be decentralized? Why
the same
not
question.
Something else? It's similar. Yes, Google dominates search, Facebook dominates social, but those are some small...
Facebook, Instagram, WhatsApp. Please remember, that's
all of them.
Yeah, exactly.
Meta.
Yeah.
But those are small steps in the journey of our species that we had so far. AI is way more significant than that. AI is as significant as the invention of fire in the history of our species. Do you want fire to be owned by one company? No. That's why decentralizing AI and giving everyone the power to build AI or have access to that is so important.
All right, perfect. Should we move on, or have anything more to add? I think there's a lot more subjects to this.
I was going to say, like, decentralization also can mean a lot of different things. It could mean literally that the model is running on a decentralized network, that you can own a part of it. It could be a centralized model, but the governance of it is decentralized. It could just be open, like just everything's open source. You can do it yourself. It's not on a decentralized network, but you could just have access to it. So it could, like,
I
you
think
could
that's a
look at
very
all
important
different
point,
layers.
the difference between open source and decentralization, but maybe we'll get to that. So actually, I think continuing on that, that's a bit of a continuation. We're seeing a lot of drama right now in Elon Musk, Twitter, OpenAI, Apple phones, Apple whatever. Do you think that that is, again, an example of, like, why do you think Elon, and whoever doesn't know, Apple is talking about coming pre-installed with OpenAI in it, and in the terms of conditions, when you're going to buy your new Apple phone, you're going to literally let OpenAI continuously collect information on everything that you do all the time. And, well, maybe I might be wrong, and please correct me. I'm a marketer, I only read the titles. And Elon Musk said that if that is a situation is going to happen, then first of all, any employee of his companies won't be able to work on any iOS systems. And he even went ahead of saying that he's thinking about actually delisting X from iOS phones. I don't think that ever can happen. He'll lose all his money in one day. But, like, is that an example? Do you think he's fighting that fight, or why is that happening?
Yeah, I'll give a very concrete example. I don't know if anybody's seen the news around Perplexity being under hot fire. This was a Forbes article, kind of look it up. So basically what happened is Perplexity took a Forbes article and then almost verbatim quoted things out of that Forbes article without giving any citation to the source, and basically saying the Perplexity model created all this content. So imagine you're working on your PhD thesis, never been released. Apple collects all that data through OpenAI. All of a sudden, all of that knowledge base shows up in somebody's writing coming out. So that's the danger of not correctly attributing where the data comes from. It's another case for, truly open AI that's on the blockchain.
Interesting. Thoughts or whatever, like, is this a good fight? Is it a bad fight? Is it like, because Elon Musk isn't exactly Mr. Decentralization, so is it just, what are your thoughts there?
I think, like, not to over-index on the names, but I think the idea there is that there should not be monopolies on AI, and that's what he's trying to say, I think. Basically, two big companies coming together and then kind of like coming and being just one controlling this AI and getting all of this data out to use for their own good is not good for the whole other actors also in the economy of this.
All right, okay, cool. I think let's move on to, I guess, a bit more tech talk. So talking a lot about infrastructure, how do we fall into a place that, so this is a blockchain conference, and I think that there's today more layer ones than maybe dApps, and there might be more protocols than users on dApps. How do we make sure that that doesn't happen in the AI space, specifically on the infrastructure level? Like, is there too much infrastructure? At some point, should we start talking more about use cases? Are we already talking about blockchain AI use cases? Like, where are we talking about that? Because there is a problem of too much infrastructure, not enough, I would say, applications. How do we solve that in blockchain and AI?
we solve that problem by.
Oh, congratulations. Kidding.
I mean, I say everyone in this room, by the way.
Okay.
Together. This is decentralized, so not just Bagel, everyone. We can solve that problem by making the infrastructure as permissionless as possible for AI. And as I have been saying for multiple years now, that we foresee that most of the users of these kind of infrastructures are not going to be humans. There will be autonomous agents. And there are going to be billions of them, like way more autonomous agents than people. And that's why it's very important to make them permissionless, so that these billions of autonomous agents can come and they can self-improve, self-replicate, whatever that might be.
So you're talking that the way to look at AI adoption is not through what we're thinking about, like application dApps businesses. It's more about how many autonomous agents are being deployed and how successful they are, I guess. Is that like the metric? Is that what we're trying to get to endless amounts of autonomous agents?
Yes. I mean, it's like they go hand in hand, right? Doesn't matter what kind of business you have, if it's a Shopify, marketplace, or some protocol, majority of your users are going to be autonomous agents in a year from now. That's what we're seeing live in the industry at the moment. So even if you want your business to be successful, you need to make it permissionless for them.
Yeah, I completely agree with Bidan. And by the way, super excited talking about community, partnering on vector databases and fine-tuning. And this is how decentralized AI becomes a real thing through these different community partnerships. And we're super excited about it. The other piece to that, though, is to make decentralized infrastructure, going back to that point, to not be as difficult as it is today, and to remove any of the barriers that stand between decentralized and centralized infrastructure. If you ask a lot of projects right now building AI meets Web3, like where do you store your model? How do you do your inference requests? Like a lot of them don't tell you, oh, it's stored on AWS, or we're having a.
We love AWS. They're one of the partners of the event.
Exactly. Which AWS also participating in decentralized networks, so it's not just that. But so how do we then make that whole thing decentralized and inexpensive enough so that it makes sense to build completely on chain and to remove any of the barriers? If you wanted to train a large-scale language model today on chain, it's not possible. The data availability doesn't exist. It would be too expensive to store the data, process the data. There's even research issues. You can't batch process or asynchronously process all of that model training just yet. So there's even fundamental research problems that are still in the way. So I do think there's still infrastructure that does need to be built before we can get to the end state.
Okay, cool. But when you talk about infrastructure, and actually a general question, not about AI only, we're all talking about the internet. We love the internet. How many protocols control the internet? Well, maybe in the end of the day, we all ended up choosing 2, 3, 4, maybe movements from HTML to flat, whatever. But is there a point where maybe this is a larger discussion about blockchain? We need to talk about consolidation of infrastructure, or how many winners can there be, or is AI going to be different? Is AI a situation where there might actually be 15, 20, 30 infrastructures? Because hard to see a lot of places in the world where it doesn't end up consolidating into 2, 3, 4 leading actors or paradigms or protocols. Is AI going to be different?
So when we're talking about decentralization, having just winner doesn't make sense, in my opinion, because at the end of the day, there will be multiple, you call them protocols, infrastructure, whatever you want to call them, but all of these has to work together on maybe there's going to be one interface that's going to win. Looking at AI, I think if we're going to have decentralized AI or this open systems, it's going to be the same, where we're not going to have just one winner, but we're going to have decentralized different networks or infrastructure working together through maybe one or a couple of interfaces in between them.
I do think it's going to happen on a few different levels. For example, I think we're going to have a few foundational models for different modalities, but then based on those few building blocks that are just used everywhere, everyone's going to fine tune those models for this specific application and this specific app, and you're going to have this this trend was going to happen in the whole stack, where you're going to have, like, for example, the foundational model layer. You have the few that everyone has trained, like the gigantic best model. Like Meta makes one, they open source it, and now in different application, different downstream use cases, you're going to have it be adapted to the use case for it. But you're going to have like just a few standardized ones, and the same thing for like other practices about how, I don't know, these agents transact, for example, and stuff like that. You can have like a few standardized ways that just like win out because of the network effects in there, and then in the downstream application, you're going to see the new ones come out.
And so, do you think there's a chance of us being able to build this in conjunction with the centralized AI and working together? Because let's say crypto in the beginning, we came out to replace the banks, and then a few years we discovered that what we're actually doing is doing the banks better. And we could have solved this in a few years. Maybe blockchain would have gotten better adoption if we didn't try for the first few years as maximalists to replace, but improve. Do you think that can decentralized AI live in peace with centralized AI, or is it, you know, one versus the other? Will they live in different worlds, or will there be frictionless, I would say, interoperability?
I would say it depends on the use case. If you have a spectrum of, let's say, you know, an agent that's only doing personal tasks for you versus societal level use cases, like that agent that's doing like ordering pizza for you, that can live on an edge device, for example. You don't necessarily, as long as you have some entry on a blockchain, you know, not a big deal. But if the threat is very, very large on societal type of use cases, absolutely it needs to be on decentralized AI. So I think I see that distinction between the two. And just to make this interesting from our conversation, if you look at the human brain, it's a collection of highly specialized types of neurons. For example, you have a motor cortex all about movement, but then you have a prefrontal cortex and different layers on the outside of the brain that are coordination layers. So why can't AI evolve in a similar way, where you have hundreds, thousands, maybe millions of highly specialized expert models? Maybe there's an expert model in physics. And then there's coordination layers that are larger language scale models. And I actually think today on blockchains, we can start building some of these smaller expert models today. So I'd love to see things kind of evolve in that way, versus just saying like, oh, everything's going to be centralized, and there's a centralizing force.
Yeah, we're not trying to just do a copycat of saying, here, here's ChatGPT, but Sam Altman doesn't control it. We're necessarily going to need to get in and out, right? How do we build that from day one? How do we, like, again, I personally, as someone who's been in crypto for a while, so adoption took us a long time because we were picking fights with the Web2 world and not thinking how we could work together. So how does that happen on the grassroots level? How do we improve current AI and not try to build a complete garden that's supposed to win it or replicate it?
Yeah, I mean, if you even look at it from, let's take the Bitcoin network, for example, powerful coordination engine, lots of economic incentives. And then I think this was a study I've seen from maybe 2 years ago. The entire hashing power of the Bitcoin network was 100 times greater than all of the data centers Google had. So never underestimate the power of coordinated community. So do we have that today in decentralized AI? We have some approaches to it, like BitTensor, I would say, but I don't think we have this level of like coordination just yet. So I think the coordinated...
don't get me started on the energy thing. Everyone's talking about how bad Bitcoin's for the environment. No one's talking about how AI servers are taking whatever. All right. We're going to try and get to the last third, I would think, of the panel. So a lot of people are saying AI right now, that's for sure. And there's a lot of people here who are founders or maybe investors or want to partner or build on a network or invest. How do you advise them to spot the knot? How can you try and do your own due diligence and say who's a real AI project, who's in this for, I would say, the long term is going to do that, and who's putting the word AI on their deck or website right now because it's the hot thing and then will replace that. Now, we're not talking about any specific names, projects, or whatever, but how would you help people better understand, or maybe what are things that they should, as non-super technical people, look at, learn about, do a bit more reading? Because I do think that that's a very important part right now. Everyone knows the word AI, but they don't have maybe the tool set other than reading the press releases or whatever to make a better differentiation. I would give my personal tip, see if the founders have ever worked in AI. If none of the founders or the leading team has ever worked in the industry, maybe they shouldn't be a billion-dollar company without a product just yet. But that's my personal tip.
Yeah, I was going to say the exact same thing. So basically, people who are looking to invest in these companies should
invest, partner, build. There's a lot of
build,
different things.
whatever.
I'm not just talking
Yes.
about money.
They should look at the team and what they've been saying for a long time, and they didn't change their view on AI and if they ever worked on AI until the last, I don't know, year or two. Look at what they've been doing, look at the papers that they've written, look at the partnerships that they had before, and then go into their website and then see if they're actually walking the walk and talking the talk.
I would say it's quite easy to spot who are the real AI people and who are not. Just look who are shipping, who are launching products. If a team is just talking about AI without launching anything, then it's more likely that they don't have anything real. But if a team is launching, then it's more likely that.
How many years did OpenAI work in stealth? 6, 7? It takes time to build real stuff. I'm not saying, it does.
Yeah, it does, of course. I mean, yeah, the Rome wasn't built in one day, right? It takes a long time, for sure. But at the same time, if your project is in stealth or haven't launched anything, but launching a token at the same time,
saying you still have something to show. You have years of research, and maybe not above the fold, but you have something in the back end to show. Okay, so you would say see at least a year or two of like conviction in the space and building and research. That's like a decent look at like a higher chance that it's not just saying AI. All right, I agree with you. Any other tips for people?
Yeah, one filter that can be useful as well. This is obviously, just personal opinion, not 100%. Like you always use this filter, but are you an AI company or are you using AI as a tool? It's kind of very similar to when Web2 first came out, and it's like, oh, I'm using the internet. Like I build on the internet, and then you're just using it kind of as a tool. So very similarly, are you building something specific that's adding to the overall infrastructure of AI, or are you adding some interesting new techniques and technologies to further the field of AI, or are you just using it like, hey, I put ChatGPT into a smart contract, and here's a wrapper?
So actually, I agree with you, and I think that I'm a marketer, PR. I didn't introduce myself, not that interesting. But when our clients come to us and say, oh, we have a big announcement, it's something with AI, the first thing, I'm not talking about projects that are building AI, it's more of like a tool. Then the first thing we ask them is it anything proprietary, or is this bar ChatGPT and whatever with some UI or skin? And if the answer is the latter, we usually tell them we really suggest you put that out there, which it's not a bad thing to build toolings based on ChatGPT, but when you launch a product and you're saying we're doing an AI product, if it's literally just smart prompts and smart contracts on ChatGPT, that needs to be kind of out there. So I would also look at that. Is there any proprietary tech, or all they're doing is aggregating different AIs, I guess? Do you have anything to add? I feel like we're neglecting you there.
No, a slight variation of what Michael was saying is, the way I think about it is, you have like Web3 tech, and you have AI, and an intersection, like where is the problem and who's helping the other? So for example, I could be using AI to help solve a Web3 problem. Like for example, in crypto, DeFi hacks are a thing. So audits are important. I can use an AI model to like better secure my smart contract. I'm using AI as a tool to like solve a Web3 problem. The other way around would be, let's say I'm an AI and I care about privacy. So I'm gonna, I don't know, use FHE or some privacy specific technology to like solve a problem in AI. And those two things are very different. Like solving a problem in Web3 versus solving a problem in AI are two very different things. And the risk profiles and the timelines you can expect are very different. If I wanted to bootstrap a data collection marketplace with a token, that's very different than, for example, FHE ML. The one requires like a deep tech breakthrough, and the other requires like a clever like incentive mechanism scheme. So you have these four quadrants of like, is crypto helping AI or crypto, and in what ways?
That's a very good. That could be a whole different panel altogether, but I think it's a very important point. Is this company, project, founder, whatever, trying to do blockchain stuff with AI, or is this an AI company that's going to use blockchain? That's a very important differentiation. So thank you for that. All right, so we're getting to the last part. I want to call it the shout out section. So I'd love if it doesn't have to be AI, it could be better, preferably not something that is your own company, and if you are connected, please let us know. But I want people to leave this room with something that maybe they should read about, a company they should check out, a podcast or whatever, again, around what we're doing. So I'd love if you guys can give a shout out or a news you can use for just something that people should be reading about or whatever. let's say a year ago, on stage, I told people they should be looking at account abstraction, and I talked about a company I think that's interesting. So just if people could Google one thing and bookmark it, what do you think that should be?
Should I go first? Yeah. Was Ilya here today? I'm not sure, but so Ilya Polosukhin is one of the co-authors of Attention is All You Need. And he is now also advancing near into the user-owned AI part of things. So if you're interested in how AI and crypto can have a product, I would really advise you to check Near Protocol.
Cool.
Yeah, besides the McDonald's job page, I definitely advise. Just kidding. Choppy market, everyone.
In the FTX crash day, McDonald's Social tweeted their hiring page and tagged FTX employees saying they're hiring. So yeah,
just again, just joking around and trying to make it a little bit fun. But I'm actually super excited about the entire spectrum of the AI pipeline. There's quite a bit of innovation at every piece and point, whether it's data generation, companies like Grass, to things like data labeling and cleaning, like public AI I've looked at recently, to the storage piece and DA pieces that we're doing, and then the model training pieces, so like Sentient and various others, to the execution environment like Aura, to then the agentic web, where you have companies like Theoric, for example, or Zoe doing some really interesting things. So definitely check out each part of that kind of AI pipeline innovation, because it is starting to happen on Web3, and I'm super excited about it. And of course, check out all of our companies as well.
Well, Michael named all the Web3 AI companies and didn't leave one for me. So I'm going to go into AI side, what I'm excited about in the AI space in general. Recently, I've been seeing a lot of improvement in the video generation platforms. Luma Labs, for example, they're doing great work. And I'm really excited about that because this will disrupt some of the biggest industries in the world. For example, movie making, Hollywood, and stuff like that. And that is something exciting. And also, keep an eye on Bagel. We are
shameless self-promotion.
We are making a big announcement tomorrow, so just follow us on Twitter, and you'll know what happens.
Perfect.
Slightly related to this point, one area I think is very exciting and, well, also terrifying is deepfakes. And it's also an area where I think there's going to be something with cryptography, at least, in the loop to help solve that problem, because you can't use AI models to predict what's real and what's fake anymore. And then a few projects in that area. One that I like is called C3, but there are a few others. And just deepfakes is, I think, going to be a very important issue with the elections coming up and all those things. And I think cryptography is going to play a role in solving that problem, if we can solve it.
All right, perfect. We're on the second. That's amazing. So we're done. Our speakers are going to stay here for a few minutes. I'm sure a lot of you guys want to talk to them. So please let people a few minutes interact with you guys. Thank you very much. And I hope you guys have a productive EthCC week. Thank you very much.
All right, everybody, if you're standing towards the side, would love it if you could please come and take a seat. We're going to be moving into our next session, which we're very excited about, which is a fireside discussion between Sandeep Nailwal, he's a co-founder of Polygon and a core contributor at Sentient. And he'll be in discussion with Bridget Harris, who is an investor at Founders Fund. Please welcome to the stage Sandeep and Bridget.
Hi, everyone.
Hey, everyone. Okay, cool. Kind of going to start with like setting the stage a little bit. Curious your take on why do open source AI models lag like 12 to 18 months behind proprietary ones, and what do you think about that?
I think structurally, for me, like I think it's basically more about how the incentive structures might be working in these systems, because except like let's say Facebook's llama model, Meta's llama model, who have like a huge amount of money, and they are like basically even their strategy is more like a scorched earth strategy, right? So that like people are ahead of us, so let's distribute this, and they have been like traditionally behind, right? Previously it was only OpenAI, and originally it used to be only Google, then OpenAI and Google, and then others had to catch up. So I think, and this is not like a very long history, like it's like these models exploded like end of 2022, right? So it's been like maybe 18 to 24 months of the overall like this craziness around it. So one is that I think like traditionally these two closed source main players, OpenAI and Google, have been ahead in general, and then after that Meta came in and they used this like scorched earth strategy. But the other open source models also, I think like there should be a problem of incentives also for them, because their valuations probably are not that great, the fundings and all that. So the kind of resources they can throw at it must also be like a little bit less. But I also feel that these things, the open source models are catching up slowly. Like you also see anytime the llama model comes in, like it's like 80-85% already there. Or maybe more compared to let's say OpenAI Chat GPTs and all or GPT, right? And the Chat GPT's performance is so good is as a consumer product is because it's like not only the model but a huge amount of like software stuff built on top of it, right? So that also might be the reason it feels like they are much further behind, but it's a combination of multiple things.
And then sort of in line with that, curious about Sentient's approach to this problem, and then maybe you can explain the concept of like model loyalty and how that works.
Yeah, so basically, everybody, I mean, in crypto specifically, on a strategic level, it looks very simple that AI is a centralizing force, and these centralized companies are running away with their AI models and things like that. And what is the best technology to decentralize this? This hugely, which can be very disruptive for the humanity also. How do you, kind of decentralize this technology? And then the decentralization technology is crypto. So strategically, it's very clear that there should be some overlap between crypto and AI. And last 1.5 years since this AI and crypto category that I have been seeing, like I've received like hundreds and hundreds of pitches from there for like angel investments and working with Polygon and all that, and with even symbolic capital also. And then whenever we see there's no direct integration of crypto into this. Like, okay, we are using maybe ZK, ML technologies we'll use to have like trustless inferences, but how do they, who are the actual users of that? I always, used to question this thing. And this model loyalty is like one idea that came into my mind, and I recently tweeted about this also, that Sriram from EigenLayer was at my home, and we were discussing this. I said that I have this stupid idea about this AI. This might be the reason, because I'm not AI native at all. Like in terms of the technology, I understand crypto more, but I just simply said that, what if like, considering like I have this habit of, I think the word is anthropomorphizing AI. Like, so basically I always humanize the AI, right? So I said that, what if I gave an example of Navy SEALs, that these Navy SEALs, even if enemy captures, or some soldiers of an army of a country, even if some enemy captures them, still they will not reveal the secrets of so easily of their country, because they are loyal to the country. Can we do something, like if this AI is going to develop as a human brain or like something similar, why can't we make this AI loyal to a community, to set of ideas, to financial arrangements and all that? Can we do that? And then Sriram thought that, okay, this is interesting. We debated more. I told him some of the ideas that I had in my mind, and then he said that this is very, very interesting. And then he connected me to Professor Pramod and other scientists in this space. And then that's where they actually became very excited about this. They think that this could be a separate branch of AI research and crypto research, which is like they call like AI native cryptography. There's some very interesting stuff the team is doing, and as they reach at least the prototype level, they will talk about them more. So the model loyalty I already told you. And so in the crypto context, if you see that, imagine you had open source models which had this loyalty concept in them. So that means like now the model, you have made it, somehow you have made it legal. Like let's not loyal, let's not go into that. And then now you can make this model completely open source. Anybody can download it, they can run it on their local machines, and that model will adhere to, like, initially we are trying for a financial loyalty. That means that you have to pay to the network to run those models. And the second one eventually might be like, more community ethos. That's my, like, for me, the end goal of this like 20, 30-year plan is like, I mean, all the people who joined like crypto in 2015, 16, like, we feel like that borderless world and all that. And I have always thought to myself that if you really want to build a borderless world, at the end you need to disrupt the violence which is at the core level of our civilization. Like any civilized place you go, cities, countries, the base level is secured by armies, right? And on top of that, then the state is built. How do you disrupt that? So that like 20, 30-year long idea, like imagine you had like a drone police, which is controlled by a community, which has specified the principles of how those drones should police the whole world, and like never interfere in people's affairs, don't allow a human being to kill other human being. All these kind of principles you can put, and those drones then have these AI brains, and they police the world. So then you don't really need these nation states and the armies and all that. So that is the long-term goal, and that also comes from model loyalty, right? Like in some form. So that's where the idea from, in my mind, came through. And then like the search teams are like, they feel that this is possible. Like I mean, we keep debating like a lot of cryptographic things and all that. So hopefully something comes out of that.
And then in line with like Sentient's overall architecture, my colleague Joey highlighted this in a recent thread he posted. But Ethereum basically has this model that's open source but not free to use. And Sentient is obviously trying to kind of have some parallels with that architecture. Curious like what you think about both the similarities and differences to that sort of like architecture are.
Oh yeah, like I mean, me being from the Ethereum community, like I'm basically like with like at Polygon, but like previously I started my crypto journey as a Ethereum community member, right? So those ethos are very strong there, right? And basically you make a completely open, decentralized, permissionless network, and then people use it, but then they pay the network in some form. And the core idea around Sentient is like that only. Like the way Ethereum is a substrate for trust, can we make Sentient so substrate for intelligence? And also this like we keep hearing about AGI and ASI and all that. And I fundamentally believe that, so I was telling this thing, like, imagine if you believe, like there are some people who are like AI can never be decentralized, right? So if you are in that camp, you are already accepting that humanity is doomed, because sooner or later, some centralized AI will become powerful enough to become the warlords, right? So that's not a very promising future. And the only way is that if you want if super or the super intelligence like ASI or AGI emerges, the best way for the world to be protected against it is for everyone to have that. So when you make that model open, anybody can use it, and censorship resistance also. So all those things will come up, and we have we have never talked about our blockchain part of thing, how it makes it censorship resistant and all that. But eventual goal is that these models are freely available for anyone to use and censorship resistant. Anybody can just pay the network the basic fees, but then you are still able to use that intelligence. So the idea here is that if the models being trained on sentient platform, they also achieve, the hope is if these centralized parties, some of them achieve AGI or ASI, the sentient models, which are completely open source, also achieve that. And then everyone has a ASI, right? And then you can, these still, the counterbalancing forces are created, the deterrence is created. Many people compare the AI to the nuclear bombs, right? And how is the world protected from nuclear bombs? Is by having these deterrents. Multiple big countries have these nuclear bombs and nobody fires it on each other because everybody has it, right? So some kind of that game theoretic equilibrium will achieve. That's my kind of bull case for humanity in that. But if something like that is not achievable, then we are all doomed, right? Because we are all going to be slaves to something more intelligent than us.
Kind of switching gears a little bit to the user side. So with sentient, the user has to sign a cryptographic message that proves, they paid before using the model. Curious.
Could you repeat the question?
You have to pay, right? You have to pay the model to use sentient.
Yeah.
So curious from the user standpoint, if I'm still paying ChatGPT, I'm paying, Anthropic for the top tier versions of their models. What's the difference? Why would I choose to use sentient instead?
Yeah, I think that this is a less talk part because we are much far away from that. But I think if you see from the business side that right now OpenAI or these big players, they are building the models, they are hosting the models, and then they are charging the premiums on that. Maybe they are not charging the premiums, they are offering them at cost, which is probably maybe their profit margins are not that high because they just want to onboard the users. Eventually they will make, they will have their margins on that. And so with this kind of intelligence, where the community built it together in this loyal form, and then eventually I think we'll reach a place where every user will be able to host these models on their local machines. But even if you assume that it will remain complicated enough, but hundreds of other people will be hosting it, right? And then it's like, the free markets, can easily, free markets have easily shown that more competition leads to better prices for the customers. So, if we consider the other scenario where every model, these things will become so optimized and standard that on my laptop I can download, or on my phone I can download the model and run it on my own. So I don't have to pay any premium on the compute and all those things. All I'm paying is that, and that will be very, very small, per token basis, right? I'm not saying the crypto token, I'm talking the AI token. Per token basis, there is small pricing that the community is charging, right? And obviously community will define it basis on what has been invested on that and all that. So you can already see that cost will be much, much, much lower than if you are buying that service from a verticalized integrated player who has built the model, hosted the model, and they are doing bunch of other services on that, and they are charging you that. So for the user, I would say yes, they have to pay, but first, they are getting full autonomy. Like if you have downloaded your model on your mobile, and then you want to further fine tune it, I'm pretty sure these services will also become more and more optimized. So you can say that my local model on my mobile will be trained on my private data also. Nobody is taking your private data. So this is much more optimized for you. And obviously the cost that you don't have to pay the compute margins to somebody else and all that. So you can see that the cost will be much, much lower for the user, more autonomy, more privacy, and lower cost. So that's
Got it. Awesome. And then on like the developer experience side, curious like what the flow looks like there in terms of like what does Sentient provide in terms of like compute, data, like fine tuning, all these things, and then what does the developer have to take care of, and what does that sort of like experience look like?
Yeah. So when you say the developer, I guess you are talking about from the developer where the developer wants to use the model and build something on top, right?
Yeah.
Because there are two sides where the developers are there. Because one is the user side of things, and one is the contributor side of things. Like on the contribution side, also a lot of developers will come and join and do, participate in growing the models. And there are going to be multiple, kind of campaigns and all those things, which we will, slowly in the coming weeks or so, we will reveal more of that, like how these developers are going to, kind of collaborate with each other, or, participate in these campaigns to grow the AI, so to fine tune the AI. And on the other side of the development is like, where these developers can simply take the models from the platform, like simply download. And this is the post-loyalty world I'm talking about, right? Initially, maybe for the first 6 months, 12 months, the models will be fully open source. So you can come and download the model, it's fine. Eventually, but the post-loyalty work, where the loyalty has been achieved, then, as a developer, again, you simply download, you run, but like whenever assuming you have customers or users, they are like, putting a query to you, right? That query in some form, you sign with your public key, and you need to be maintaining a balance on the network. You send it to the network, and the network gives you a signature, and that you can bring it back and give it to your, like, assume signature. Like right now, I'm just like trivializing that stuff. So the network gives you something that you take to the model, and now model recognizes that this money has been paid for me, and then the model gives you the inference. And also, like, already you can see that, this query, first it's getting signed, and it's going to the network, and it's coming back. So some people might be already questioning that, will it affect the user experience? Because like the inference times is also now a big thing, like users want faster inferences. But like I think the way the model, where the network that we will be building and all that, the goal would be that this cycle doesn't take more than 500 milliseconds. So whatever you will have, the experience you will have on any centralized player, it will never be more than that T plus 500 millisecond, right? So that's a fair enough, like I think, trade-off we've been.
On the data provider side, curious, because you guys reward, the data providers, there's a huge discrepancy in like quality of data out there, obviously. And so how do you sort of like reconcile, like basically like proportionally rewarding, these data providers based on like the quality of their data? Like how do you guys measure quality?
Yeah. So for the quality, I think like there have been multiple such open data campaigns. Like, one I was giving example was also that the UW, University of Washington Data Comp project. So, Seung, who's one of the 3 professors who led that program, and that program became like very popular, and almost all like Anthropics and OpenAIs of the world, they use that data. So in that, you always have like a set of researchers. Like you have the open like crawling, where people are crawling the data and bringing it. And this is, I'm talking about the large scale data, like open data available on the network. And obviously on Sentient platform, there will be like 3 different kinds of data, right? So one, this open scraping kind of data. Then like, I don't know how we will do the private data, but maybe some mechanisms to have private data. But there are already some players who are doing it. Maybe we'll simply collaborate with them to get the private data if that's possible. And the third is the synthetic data. But for all of these threes, like they will be like as I'm saying, roughly like calling it campaigns, right? So we will be doing all these campaigns, and they will like, so we have fair amount of experience in the team on how you run these large, like decentralized data downloading mechanisms, and then you have these like as I'm saying, like in my mind I call this like checker DAO or something, but like you can think of it like a group of people who are basically you know doing the job of like basically removing the duplications and making sure that the content is like suitable for family use, NSFW kind of things, and all other kind of data sanctity things, like it doesn't have poisoning, all those kind of things that they will do. So that's a very, I think it's a well traversed path already in the public data campaigns, data comp kind of, I would say, sector, basically. A lot of people have done these things. So we would do in the similar form. Quality will be, obviously, that's super important for the models to have, yeah.
So kind of like on the hardware side, I know NVIDIA just shipped like a TE trusted hardware, which could be really relevant to you guys. Curious what you're thinking of, the hardware stack that Sentient's going to, leverage.
Yeah, I mean, on the TE side, like, so on the model loyalty where we are working on multiple forums, TE is like one of the, although it's a less priority approach, but is one of the approach that we are also seeing. So obviously, like, NVIDIA being the leading player in that, on the hardware side, so like our plans also include NVIDIA, but we also, we have to see like on this TE side, because we are very close to the Intel leadership, and there are like some, I would say like crypto specific hardware players are also coming up, like, don't want to disclose their stuff right now. So, we will have a fairly diverse strategy on like, on these ones, but definitely NVIDIA, and that NVIDIA TE is like very, very helpful on that, right? Like somebody could actually, in a very trivial way, just put the whole model into that. Obviously, you can't run very big models still in a very performant way in those TEs, but, it is getting there, and this NVIDIA TE is definitely a good step in that direction.
And then sort of just to wrap up, I know we only have, a few seconds left, but curious what you're looking forward to most for the rest of the year with Sentient, and what you guys are planning, to do for the next few months, what you're planning to ship and what you're looking forward to the most.
Yeah. So I think the most important thing is the platform to go live, and the team is working really hard on that. And then once the platform goes live, like doing some very interesting campaigns and all that with the developers, and building that community, like, you have to, it's like a slightly long process also in building that community of contributors. So this year, like, Q3, the goal would be to have the platform live and, onboard some of the community members, like early community members at least. So yeah, that is the most important part. And then I think, like, I mean, this is like, I'm going by the confidence of the team. Team feels that they would have some version of model loyalty maybe within this year, and that is like super aggressive, but if that happens, that can be game changer. And that is the whole purpose. Like I keep telling the Sentient team also that, they should be looking to do something really big. If they build this model loyalty in a more like scalable way, this can change the whole, the whole AI industry suddenly, right? Because every large corporation also can, make their models maybe somehow open source and open weights. Anybody can download. Because like all of these centralized companies, like, I speak to some of the governments also, some of the large corporations, and you can also see like a lot of Gartner research and all that is coming in. Like I think numbers are like very like insane, like 70 to 80% of CIOs are saying that they are not comfortable using these closed source AI in their platforms and all that. Like it's a pretty huge majority over there. So that thing is already, as this AI, like this chat GPT kind of craze settles down, already the hype settles down, I mean, and the mania, then the CIOs and all that, like who are seeing through the businesses, they are already seeing that this might not be the best thing. So that's a very positive thing for all the teams who are here, who are working on the open AI kind of related projects. This might be like, I mean, I can see early signs in the industry that people want to use these open source models, right? So hopefully some of us are able to figure out. And then for me, it's like the 1995 or like early 1990s moment that where Microsoft has this early lead. If you go back to that time, nobody would tell you that anybody other than Microsoft is going to come and have the PC market or have some share in the PC market. I think that's the same for the AI, and maybe in 5 years, the crypto plus AI industry can turn the tide. And that's where I would end.
Thanks, everyone. Thank you. Sandeep.
Okay, y'all, we're heading into our next panel titled Ownership and Privacy in the World of Big AI. For this panel, we're joined by Anna Kozlauskas, the co-founder of Vanna, Pramod Viswanath. He is a core contributor at Sentient and a professor of engineering at Princeton University. We have DC Builder, who's a research engineer at WorldCoin, Casey Caruso, who is the founding partner of Topology VC. And this panel will be moderated by Zoe Mekbach, who is a vice president and partner at Fala Network. Welcome to the stage.
Great. Hello, everyone. we wanted to sit in the order, so it's better for you guys in the audience to recognize the speakers. Thank you for staying. After a deep and very interesting fireside chat with Sandeep, but this topic is also very, very interesting, and I hope that you all can learn something from our amazing speakers here today. I'm Zoe. I'm VP and partner at Fala Network. We are DeepIn co-processor for AI, and I'm joined by very smart and amazing speakers here today. We have Anna, we have Pramod, DC Builder, and Casey here. And of course, I would like to give you guys as speakers the opportunity to quickly introduce yourself, but also with the intro or bit of background, where your journey is coming from, like in the intersection of AI and crypto. Are you more from the AI side or the crypto side, and why are you building also into this intersection? Casey.
Yeah, sure. Yeah, my name is Casey. I historically come from the AI side, but my general background is traditionally trained computer scientist and studied AI and ML in grad school, and then worked at Google for 4 years on a variety of teams, but mostly on a team called Research Systems, where we did exploratory ML work, and specifically a lot of topic modeling. And then got into crypto through mining originally, and then most recently was an investment partner at Paradigm, and now on my own firm. And yeah, I think that independently have been in these two industries for a really long time, almost a decade. Actually, yes, a decade. And then more recently have been spending a lot of time thinking about where it might make sense to have them overlap, and where it does make sense and where it doesn't make sense, and over what time horizons.
Awesome. I go by DC Builder on X, and I'm a research engineer at the WorldCoin Foundation. I mostly come from the crypto background, although I was into AI like way back in high school, but I chose the different route, the dark side, as they call it. And I mostly work on programmable cryptography, so zero-knowledge cryptography, MPC, and blockchain engineering. And I work at WorldCoin, where we're building the largest digital identity and privacy network for just financial use cases.
My name is Pramod Vishwanath. I'm a professor at Princeton University, and it's a professional hazard for professors to ask to speak. I could go on forever, so I'm going to be careful on that.
I'm Anna from Vana. I come from kind of an intersection of crypto and AI, so I got into crypto through mining Ethereum in 2015. I would go get GPUs from the lab dumpsters at MIT and set them up to mine with free electricity. And then I ended up dropping out of school in 2017 to start a machine learning company that came out of automating my job as an intern at the World Bank sorting documents. This is when the attention is all you need paper had come out, but people hadn't yet figured out how to use it for generative models. And I was doing some research there at CSAIL.
Thank you so much. Very excited to have you here on stage. So today we talked a lot about like open source, closed source, AI should be controlled by decentralized or centralized protocols or entities. I would like to start with the question of like the risk that you would see if AI data overall will be controlled by centralized entities, and how you in your companies or companies that you fund or what you're seeing, the projects you're working on, how are you mitigating these risks? DC, do you want to start on this?
I think the AI people should start first. I have like very limited view of this. Maybe some other person that wants to take this first.
Yeah, I'm happy to take this first. So I think that some of the risks that come from centralization, I would categorize into one is like whoever decides what goes into the AI model is basically deciding truth, right? And so if you just talk to an AI to get your information, then whoever has decided the truth for that AI model has decided the truth for a large portion of the world. The other one is kind of more economic concentration, right? So like OpenAI hit like $3.4 billion in revenue recently, and that's just a huge amount of resources that actually comes from AI that's largely trained on people's data, right? And all of humanity has helped to create that, but the economic upside is getting really concentrated. In terms of what we do at Vana, so Vana is a user-owned data platform working towards a user-owned foundation model collectively owned by 100 million people who all contribute their data. One recent example is the Reddit Data DAO, where so Reddit's selling user data for like $200 million. One of the problems that we're running into with AI today is like Llama 3 is trained on 15 trillion tokens. Or maybe to get a sense, like how many people have run Llama on their MacBooks? Okay, so like some local, okay, so like some AI
10%
local
for
LLM
those
people.
live streaming.
Yeah. Okay, so like that model is just trained on mostly public data. The way people have been scaling models today is just like get more and more data to train these models on. So you see these exponential scaling curves. One of the problems is we're kind of running out of public data. So there are around 15 trillion tokens in FineWeb, just like Common Crawl, all of the internet. So we need to find ways to get more data to push the frontier of these models. And at Vana, we're letting people contribute their private data in order to own parts of these models. So with a Reddit Data DAO, 140,000 users joined with their valid Reddit data. 1 million people tried to join with like new accounts or bad data or whatever it is. And now they are collectively training a user-owned model. It's going to be mostly used for like shitposting, right? It's not a foundation model yet, but that's sort of the economic model that we've set up at Vana.
Great. Pramod, would you like to comment on what Anna said?
Yeah, no, it's great. I think data has been the fuel that's driven large part of what made the technology titans like trillion-dollar platform companies, for sure. And it's partly a part of our biology as a human species that we would like to share who we are. And professorial hat here. And there's also a famous experiment in the US where a lady was just giving out pens and asking people to write their social security numbers. And like a large number of people wrote it, like several hundreds of people. So it's just, I think, privacy is in our, as a human society, as animals and farming societies, is not part of our biology. Except privacy used to be previously, the reason it came out because what you said was specific to that time and that location. If someone didn't hear you nearby and at that moment, it was gone. Whereas today, now it's there forever. I think this kind of doesn't gel with the time scale at which we have evolved as as a social species. And so it's clearly the onus is on technology to provide some guardrails and perhaps some guidances. Definitely to enable those who are especially careful. That's one part of it. The other part is that data is who we are. I mean, it represents who we are, including our innermost thoughts, our strategic thinking, whoever we are. And this will only get, the social security number is just someone assigned you. But data, if you define it, is much more than that. And I'm especially interested in understanding and thinking about and building technology that empowers individuals to lead productive lives while being part of a society without having to give up your data.
Yeah, that's a great example. We discussed this case study backstage earlier. And I think, as you all know, I think everyone that's here in the room today, everyone that cares about data privacy and ownership is either in this room today to learn about it or already works in Web3, right? So the question is more like, how can we bring this kind of mindset to the people if we want to change the mindset or just have more people use privacy in Web3 and AI? How can we do this? And maybe, DC, if you want to comment on this, how are you doing this, reflecting this in the technologies that you build for the end user, but also for developers?
Mm-hmm. Yeah, so maybe I can put some perspective into, for example, like how WorldCoin handles private data. So for those who you don't know, like we manufacture this hardware device called the Orb, which essentially is an image. It can take an image of a person, and it's able to tell apart whether the person is a real person or not based off of different sensors. And then it takes high-resolution images of the RSEs, and it's able to compute a unique representation of them. And then it's able to check that unique representation against a set of all the other users who have been verified to date. And it's able to tell whether those are unique or not. And based off of that, you can curate a set of unique humans. And using cryptography, concretely zero-knowledge cryptography, you're able to prove to anyone else that you are a unique human without revealing who you are. And so the way that we think about compute on private data and essentially making it so that we don't learn that data in the first place, there's a lot of different types of so-called programmable cryptographical techniques. They mostly fall into one or four fields. There's zero-knowledge cryptography, so I'm able to make a proof about some computation or some properties about some data. I'm able to, then there's FHE, fully homomorphic encryption, right? So I'm able to encrypt some data, perform some computations on the encrypted version of the data. So essentially, I learn nothing as the person doing the computation, and then someone else can, or like the user, the person's data, the people who own the data can just decrypt, and it's as if I would have performed that computation on the original data, but the person doing the computation doesn't learn anything. Then there is multi-party computation. So we also use this specific type of technique, which allows a given set of participants, let's say the people here on stage, to perform a computation on some data without any of us learning any single, like learning the data itself, but it allows us to split the data into so-called shards, and we're able to collaboratively compute over those shards in a way where we're able to get the computation we want to perform together without learning the inputs that we're working over. And lastly, there's trusted execution environments. So these are like secure chips and hardware that allow you to essentially give you a guarantee that something was executed on top of without, you're essentially trusting that the hardware itself is not compromised in this case, and you can extract signatures of this computation. So these are like sort of like the 4 different like primitives that allow you to do computation in a private manner. And there's lots of different ways that you can combine them in different protocols that allow you to maybe do private inference or verifiable inference in AI. Like these cryptographic techniques can be applied to AI or any type of computation. It scales like very generally. And there's lots of mix and matches you can do here. And there's lots of companies exploring this sort of space for design of protocols on AI. Yeah.
Any specific use case that you're working on at WorldCoin or that you've seen combining FHE on TE or running ZKs on TEs?
So we run an MPC protocol. Essentially, these iris codes, as we call them, these are like the unique representations of the irises. The way that it works is that we used to have a database of all the plain text of all these iris codes. They're not biometrics per se, but they're biometrics derived, so they're still sensitive. And so right now, what we have is, instead of having this plain text database of all the iris codes, we have an MPC sharded database of all these iris codes across 3 participants. And these participants are able to check, like a new person that has just signed up, you can check these, their iris codes against the entire database and without ever decrypting the database, right? Like they're always in this MPC state. And in a new version that we're iterating on top of, even the query, meaning the thing you're looking up in the database, the new iris code you're looking up, and the distances between this iris code and the database are going to be all private. Yep. So there's like this is like one practical use case of like, hey, now we have almost perfect secrecy, and WorldCoin in a like 1 to 2 year time horizon would never touch any piece of biometric ever. It would just be fully like in the crypto space, right? In the cryptography space.
Okay, so we said you're wearing several different hats, right, with your experience in crypto and AI overall. Would you like to comment on like the technologies that we just mentioned that are being used for AI or Web3 and AI, like hardware like TEs or ZK? Where have you seen trend or where you also look into with your investor head?
Yeah, I also have another concrete example where actually I have a pure AI company that I work with, because I don't just do crypto, but rather frontier tech. And it's interesting because they're using 2 of these technologies, and it's extra interesting because they're not crypto, but their product is basically a machine learning competition where it's kind of like a mix between Hugging Face and Kaggle, if people are familiar with that product. And they're using HFE because they want to keep the data private. And so for data like healthcare data, that's their solution to be able to do training and inference in a totally encrypted manner. And then they're using TEs because they want the models to stay private, where when people call the models, they can actually get compensated or financially incentivized to use those models. And they want the model to stay totally private. And so that's where they're using TEs. And so I think what the overall trend that I'm seeing is that even the AI companies that are thinking more about what is the future of machine learning and can we use like isolated payments, and crypto being one of those potential solutions, and distributed compute holistically as like a way to do compute, they're becoming closer. Like they're overlapping more, and I'm seeing a lot of my AI companies start to use the same technologies that my crypto companies are starting to develop as well. And then on the ZK side, I don't know, I have strong thoughts on ZK, and I think that's like a little bit of a different category and use case, but yeah.
Great. Anna or Pramod, would you like to comment on the question, like where you see the trend for the crypto / AI use cases using the specific technologies we have discussed?
Yeah, I think one thing that wasn't mentioned is just like federated approaches and local models. Like you can achieve a lot of the privacy properties you're looking for by just running a model locally with all of your data. And so, yeah, with Vana, we have kind of this personal server that can just run from your MacBook, host all of your data. You can also host your data in like a storage provider of your choice. And then using a compute environment that is trusted by the user, whether that is client side or on their local device, gives you a lot of those stronger privacy guarantees. The term we use to kind of describe all of this is non-custodial data, right? Like usually when you use an application, you have to pass them a copy of your data, and then they're like they're basically custodying your data for you, and you're trusting them. But in the context of Vana and some of these new privacy-centric approaches, it is non-custodial, right? So you can use it and kind of personalize it, have your content in there without actually having to reveal the underlying data.
I echo federated learning as an approach that's starting to work, and it's really interesting from a distributed compute lens. And I don't think enough people bring up federated learning now, and it's like already in production, and a lot of the other technologies that we talk about are more exploratory, and this one is actually working.
Maybe one other research area I would call out is model merging. So distinct from federated learning, where you're saying like, okay, we're going to train a model and kind of like coordinate it across this federated network, model merging, it's kind of using an approach that feels more like open source software. So some of the top models in the image space, like if people have used Civit AI, a lot of that it's like not safe for work sort of content, but that's often where this technology starts. But the leading like face generation image models are actually created by like 15 different people who don't even know each other. And each person has trained a little piece of the model and then passed it on. And I think that as these techniques move into kind of broader applications, they provide this way for many people to train a model all locally with their data on their device and then contribute it back to a bigger model.
Cool. I mean, you mentioned already some research areas, but if we zoom out a bit, like overall and talking a bit more about like innovation, right? How can we do things more efficient and even better for AI? Like, how would you see the difference of like what we just discussed, like hosting or having AI data secured by these different technologies? Is it like the software side or the hardware side, or even being controlled by centralized entities? How do you see this impacting the innovation and the way forward for AI use cases? Pramod, do you want to talk on this?
Yeah. I think there is two parts to it. One is the data that's already out there is just out there. I mean, there's that cat has long been out of the box and maybe had litters, and it's really gone there, out there. It's the new kind of data that will get produced over time, and especially strategic, like I said, just not your social security number, but something more about who you are. That's the one that is the kind of the reasoning, and that's what AGI, I mean, that's the behind more intelligence aspects, is the one that needs to be more carefully handled. And I'm particularly thinking about what kind of architectures, where does the AI sit, where do users interact with it, and where does the new kind, the interaction itself generates the new kind of data that the model learns from, and how to save it. And the one model that I'm especially thinking about, and this is related to Project Sentient, is where the models sit outside, but they're largely given out to be inferred locally, fine-tuned locally, and in particular, the interaction all done locally, so in your own enclaves. It could be within communities, so that could be in some trusted enclave, maybe a hardware setting. It could be just individual, you run it yourself. It could be on cloud. I mean, I trust Google in the sense that they know everything about me. I mean, I have Gmail. So in that sense, you can have your trust. But largely, I would prefer a model where the AI service, it could be OpenAI itself, a centralized one, but offering me as a service. And I only go back to the owner to do maybe payments. That's only my interaction. So and that's pretty much it. That's the model that I'm particularly thinking about, and doing the science and the technology to enable this.
Okay. Here a question would come up, like how do you then empower more like the multi-agent economy, right? If you run so much like locally,
Yeah, if you give away the model, what's preventing somebody from running away with it? I mean, this is, software industry went through this decades ago. Like Microsoft was doing, I mean, IBM was doing these big mainframes, and Microsoft was doing betting on personal computers. And they have to give software away, otherwise people can't run it. They have to run locally. And Microsoft Word was a classic example. And they came up with this idea that, oh, I'm going to give you binary. I'm not going to give you the source code. And even there, I'll try to do some licensing models. So they went through this process decades ago, and it works to some extent. I mean, we all know piracy is there. And this is the era of AI, which is a lot more than word processors. Word processors are static. They're just there, and you interact with it. Whereas this is a living object AI, and you interact with it, and it gets better with it. And of course, knows everything about you. It's your alter ego, literally. And so this is this ideas have been around, and this technology has faced this, and this is the era for new time.
Cool. I think Casey was like a look to, because we know Pramod would extend much longer on this.
Yeah, exactly. Watch out for me,
Casey,
okay?
a question to you. Like, how do you see this balance between data utility and user privacy, right, in use cases or like teams that you work with?
Well, I just feel there's a different argument to be made of that. I know we talk a lot about privacy and ownership, and that's all true as well. But I also think just like zooming out from first principles, the way consumers make decisions about what products to be used are usually it's like faster, cheaper, or better in some way. And I think that a lot of the technologies that we're talking about, and maybe even specifically like the edge stuff that Anna alluded to, just edge compute and on-device compute, that is just gonna become faster, better, cheaper. It's just like it is gonna be a lot better to do inference that way. It's gonna be, you're gonna have to like pay very, very little like hosting costs, obviously. And there's so many advancements happening on chips right now, especially on inference-specific chips, and just in general, there's a lot of advancements with GPUs and beyond GPUs that I feel like there's a case to be made of, even if you don't care about privacy, it's just going to become the preferred methodology in the future.
Yeah, very good, very good. DC, do you want to comment on this?
On like running.
Like more, I think Casey just zoomed out a little bit, right? That there will be technologies implemented where the user doesn't need to decide anymore about the privacy use. The initial question was like, how do you, in your project or in use cases, to, provide the balance between like data utility and user privacy?
I mean, you're always going to be on a trade-off of like how useful something is and where you're running it. The more useful it is, the more usually compute intensive it is, therefore you're going to have to either delegate that compute to something else or scale up the state of the art so far so that you're able to actually do that on your own devices. To me, like, I think the thing that gives you the best of both worlds is usually cryptography. That's at least how in the blockchain space has been happening recently. You can do some form of delegated compute where the person doing the compute or the computer that's doing the compute doesn't learn the data that it's computing over. But it's still able to run whatever you want it to run over that. So to me, things like MPC, where I split the data I have on my phone, my personal data, I split it into different shards. I send it to the server to compute over, but the server will not be able to reconstruct it without my thing, and I can just collaboratively compute with the server whatever the model they want, and they can commit to using some specific model that I want. These sort of techniques exist. However, they're not really production ready or efficient enough, and there's very few cryptographers that have talked to enough state-of-the-art AI engineers to the point where they're able to come up with something that is productionizable yet, because this would also require like variations of different hardware. Eventually, like once if we cared more about privacy, there would be hardware that would reflect the privacy, I think, because right now, for example, you can do AI models that run very performant even on phones because you have neural engines on the latest iPhones or whatever. But for cryptography, like you need to work with finite fields, which is different arithmetic and different algebra and different math than you use for AI models. And those chips are not in any consumer devices, unfortunately. So yeah, if we want to go to the privacy route, we should have like hardware that represents our privacy standards, and then these use cases will be a lot more possible without sacrificing either the usability or the privacy, which I think is what we want in the end, right? It's just better than what we have today at all fronts. We don't have to sacrifice anything for that.
It's always the trilemma, right? Pramod, would you like to comment?
Yeah, I mean, I think we've talked about sort of trusted hardware. Somewhere was mentioned. Definitely, Dominic just mentioned cryptographic methods for privacy, but there's another method, which is statistical methods. This is an area called differential privacy. I mean, somewhat technical, but some of you who are in sort of computer science may have known about it. And I led this research group for several years, several PhD students graduating, on thinking about how this is, the key point is that privacy is semantics free. I mean, what is private to me may not be private to someone else. And so in other words, privacy has semantics and personalization aspects to it. But perhaps there is a way to make it just syntactic and think of it as numbers. This is especially relevant for AI. You know, in comes very private data, and out comes a model which is just a bunch of weights, numbers. So perhaps there is a way in which one can consider just the syntactical aspect of privacy. And this would be a statistical way. That means from the weights, you cannot exactly pin down who it is. Maybe you can pin 1 out of 100, 1 out of 1,000. And maybe that's OK. These are not the cryptographic guarantees, which is astronomically good. These are more statistical. And I just wanted to point this out. And there have been some success stories. I can talk offline.
Yeah, great. I would like to wrap it up with like an overall question to be answered by all of you, and starting with Anna. Like, what are you personally most excited about when we talk about like the use case of really having users owning AI agents or models and so on? Why do you think this is so important, and what can it do for the user or developer?
Yeah, so I think that what AI has done is really shifted the question of privacy to kind of like something that's maybe ideological or some kind of cultural preference towards more economic, right? So it goes from like, oh, I don't want anyone to see my messages or my data, towards like, hey, there's an AI version of Anna who can potentially like earn wages on my behalf, and I want to protect those economics and kind of like have true ownership of my kind of personal AI model that I create, and also the broader models that I might contribute my data or expertise towards. And so what I'm excited about from kind of a decentralized AI and user-owned AI perspective is just making sure that the benefits of AI are really like widely spread towards everyone who has contributed their data. So that's more of the social benefit. And then I'm very much kind of in the AI accelerationist camp, so long as you can do it in a decentralized way. So the other piece is just pushing model performance, right? And actually like getting over that data wall of like, how are we going to train better models, and how are we going to get closer towards AI that can enable amazing things like scientific discovery and like, I don't know, a better understanding of ourselves. And so, yeah, both kind of the individual perspective and also the broader, just like what can you do with super powerful intelligence.
Amazing. Pramod, please.
I think, I mean, as an educator, I meet young people all the time, and there's an immense drive to build and contribute to AI. And if you include high school students, college students, like a majority, I teach crypto classes, and very few students, when they come in, have wallets. But nearly everyone has done Python programming, and probably definitely have a Git account already. And so there's a huge urge. There's like several hundred million, several tens of millions, if not 100 million aspiring AI developers. Very accessible, shake and bake technology. A lot of tech is in crypto, it can be deep tech. This is shake and bake. I mean, it's doable. And on the other hand, all of humanity wants AI. And there's such a narrow path to meet the supply and demand. And I'm really interested as an educator, as a scientist, to build technology to bridge this.
Amazing. DC Builder.
I really echo the same point that Pramuth said. I'm in the same place. From the applications perspective, I'm not necessarily the best person to ask, but I'm really excited about the infrastructure getting better. Right? Like, I'm someone who cares more about the engineering efforts being there, like people getting excited about these things and sort of allowing these things to happen. Be that like better hardware for the privacy stack, right? So better cryptography enabled hardware, and just trying to learn more. I think like the thing that we're missing is like bridges between both spaces, where the cryptographers talk to AI engineers, and so in that name, I'm also going to SF for 3 weeks in August, so I can learn more about that. But this is sort of like something I'm excited about.
I think all these points are great. I think that I feel if you zoom out again and you think about kind of the pace at which technology is becoming integrated with Homo sapiens in general, or humans, it's just crazy. It's like the phone has been around, or the iPhone has been around for what, like 20 years? And now if you look at any public space, there's basically nobody without it. And it's just so obvious that this is going to be accelerating, and that we need to come up with a new ownership model, or it just won't make sense. Like, this is just the next iteration of how we're going to be living, and it's so clear that something needs to radically change. And not even from an ethical standpoint, just from a systems and an economic standpoint, there just has to be advancements.
Amazing. Thank you so much, everyone. As a quick summary, I think we all agreed on, like, on the privacy side for AI crypto use case, we are very excited to combine a lot of software or hardware-based technologies, right, to enhance privacy for users and developers. And on the ownership side, I think Anna pointed it out very well. Let's be more excited for, like, the economic models that we can actually enable in these use cases. Thank you so much. I hope you all got something out of this panel, and yeah, see you around.
Okay, everybody, we are thrilled to have a very special guest join us right now through the power of the internet. This individual needs no introduction. Balaji Srinivasan is joining us remotely to give a keynote on the intersection of crypto and AI. He is an investor, entrepreneur, and man of many talents. So please welcome Balaji to the summit. And just excuse this while it takes us one moment to get the AV set up.
Okay, can you see the slides? I shared the presentation there. All good? Well, I shared the slides there. All right, maybe I can do view exit full screen. How about now? Do you see the slides now? Yes? All right, time. How about now? Do you see the slides now? Okay, great. Can I get started? All right. Okay, folks, so let's talk about AI and crypto beyond the cliches. AI makes everything easy to fake, and crypto makes it hard again. So AI and crypto are often paired in a vague, hand-wavy kind of way. I want to give a little bit of background, then talk about concrete relations between them, just give you 10 points, take home very nice, crisp talk. So just background on myself. So you may know me as CTO of Coinbase and GP at Andreessen Horowitz, but before that I did robotics, genomics, and machine learning. I taught stats and neural networks at Stanford years ago. So I do have some background here. It's not just totally out of nowhere. And with that background, I want to just contrast these $2 trillion technologies, crypto and AI. And the thing is that AI came out of machine learning and academia and Google and so on and so forth. And so it came sort of top down with a large brand behind it, whereas crypto came very bottom up from message boards and Satoshi posting and didn't have name brands behind it. And so it's a very organic, internet phenomenon. So very, very different emergence patterns for these two things, but they're also very complementary. So first, AI is probabilistic and crypto is deterministic. So modern AI is largely statistical while crypto is procedural. And if you compare diffusion models and LLMs to cryptography, you can see the difference. Okay. Number two, AI is digital abundance, whereas crypto is digital scarcity. So you can create anything you want with generative AI. It can substitute for human writers, researchers, artists, lawyers, doctors, makes many of these services abundant. Crypto, by contrast, basically digitizes currency, stocks, loans, assets. It's about representing scarcity in a natively digital fashion. So if AI is digital abundance, it makes all these digital things abundant. Crypto models digital scarcity, and so they're complementary in that way. Next, AI makes things easy to fake. Crypto makes it hard again. So, a year or two ago, there's like this fake Trump arrest photo, how to spot an AI generated image. And they were saying something like, look at the hands. But eventually AI generated images are going to get better at hands and better at various body, conformations. And so instead of hands, we need some kind of cryptographic verification. Because it may not be something that you can actually see with your naked eye in the photo, it may be something that you'll need something like how to verify a message signature on Ethereum. You're going to be signing images or messages in general with your wallet. And so that's actually related to number 4, which is AI generates and crypto authenticates. So you can likely modify the IPFS, ENS stack to determine whether a given piece of content was provably publicly authored by a given ENS name. So, a name resolver for the distributed web, you could have something where maybe you right click on this, and rather than right click save as, you right click and, see signature. Okay. So there's ways of doing that with magnet links and, content hash. There's lots of different ways of implementing that. But fundamentally, the concept would be AI generates and crypto authenticates. Next, AI bust captchas and crypto rebuilds them. So, here you have this robot saying, I'm not a robot. And of course, they're just clicking this. And of course, now with AI, it's actually relatively easy to break through most captchas. So we may need to retreat to cryptographic scarcity. And instead of I'm not a robot, you have sign in with Ethereum. You pay your sign in with a high reputation crypto address or something like that. Next, AI proselytizes and crypto verifies it. So AI can generate all kinds of content, but crypto can then check it. So an example of this is if you ask Perplexity about the FTX hack, then it'll give you a bunch of links, and those links will be links to Etherscan or links to blockchains. And so you can actually look at cryptographically verifiable on-chain data for the financial facts that underpin this story, the numbers that underpin these letters. Now, the thing is, it seems like a limited set of stories for which that's possible, but that's because only financial data is really on chain now. If you start thinking about Farcaster or Lens or other kinds of protocols, more and more kinds of data are going on chain with social crypto protocols. So a much larger class of events will be on chain, and therefore you can have a much larger class of events where crypto can verify it. And so those are also going to be the open data sets that are going to be more accessible for AI. So AI will proselytize, so crypto will verify, right? Okay. Next, AI breaks a public web, but crypto builds Web3 of trust. So AI is filling up the internet with all these garbage, spam sites, all this stuff, which looks quasi-human or what have you, and it just looks plausible and so on. Crypto, however, adds a new primitive, which is every single piece of content can be signed because we've solved the public key infrastructure problem. The whole problem of public key infrastructure was how do you distribute lots of wallets where people can keep private keys, A, secure, and B, available at all times. And if you had that, you could do a lot. But it turns out that it's easy to keep something secure but unavailable. You can just put it in a lockbox and bury it in the desert. And it's easy to have something available but unsecure. You just put it on a public website. To have something both secure and available at all times is actually a very high cost thing. It's like holding your wallet. In fact, exactly like holding your wallet. So you need an incentive to do that, and crypto provided the literal incentive to do that. So crypto has actually solved the public key infrastructure problem in terms of giving an incentive for everybody to have their private key available and secure at all times. And so because of that, all kinds of content is getting generated with what I call the Web3 of trust. Again, Farcaster is the initial scaled example of this. With Web3 of trust, we can start restoring a new kind of signal on backlinks, and you go from a broken public web, from a broken Web 1.0 or Web 2.0, to a cryptographically signed and verifiable Web 3.0, where you can get back the author of a page and then determine are they human or not based on the cryptographic information there, like a proof of human or multiple proofs of human, okay? And the thing about this is there's various signature schemes, for example, with Farcaster, but really the Web3 of Trust version 1 looks like Farcaster with every message signed. Next, AI training is centralized, crypto can decentralize it. So if you look at all the largest crowdfundings, okay, all the ones in yellow are crypto crowdfunds. Now, you may not agree with what was crowdfunded here. Maybe these are projects that failed or what have you, but leave that aside whether the project failed or not. Simply the fact that you could do capital formation at this scale across borders at this speed is very new. And so the level of money that you need to train AI models is quite substantial, but crypto crowdfunding could actually get you there, right? So this is basically saying at least you can raise the funds to train potentially in a decentralized way. Whether the training itself is done that way is difficult because right now it's hard to train outside data centers. Perhaps someone will come up with a breakthrough like folding at home, but right now at least the funding for training can potentially be moved out of corporations and to DAOs, or at least partially to DAOs. And you could have a model like the Linux Foundation where you crypto crowdfund a model and then everybody has access to it. The next, AI evaluation is centralized and crypto can decentralize it. So AI model evaluation is moving to something that can be done on individual beefy machines on a Mac Studio or something. And with crypto, you can imagine decentralized evaluation of different versions of a model, very much like hosting a node. And you can imagine different versions of that model that just get pushed out. This is really what's happening already with Llama 1, 2, 3, et cetera. But different, or Stable Diffusion 1, 2, and 3. But it's just like different builds of of blockchain software. You just have a different model, and you host that, and then you serve up responses, perhaps in return for tokens or for people who are holding NFTs or something along those lines. Then AI creates new authorities and crypto decentralizes them. So now an implicit assumption of a lot of the writing on AGI and so on and so forth is that there's a single, what I call monotheistic model of AI, like a super intelligence. But what if it's a polytheistic model of AGI where you have actually many of these quote AI gods or AI superintelligences? And then if you had that, then every sufficiently large community would crowdfund an AI that serves as a guiding force for their community. They would have messaging, they would have a social network, they'd have a cryptocurrency, they have all those things together in kind of one stack. That'd be like their network or their digital stack. And you could do that for many different values of X. You could say, what would George Washington do? What would Lee Kuan Yew do? And that would be the AI that would be at the center of your culture. So AI creates new authorities and crypto could decentralize them. So those are just 10 observations of how crypto and AI can work together beyond the cliches. If you want more, you can DM me on Balaji at Balaji on Twitter and Farcaster, or I should say X/Twitter and Farcaster. Okay, thank you very much.
Okay, we have our next panel starting shortly. This panel is titled Leveraging Incentives to Build with Your Community. For this panel, we're joined by Ben Fielding. He is the co-founder of Jensen. Carton Wong, who is the co-founder of Aura. Alexander Hicks, who is a researcher at the Ethereum Foundation. Greg Osuri, who is the founder of Akash Network. And the panel will be moderated by Stepan Gershuni, who's an investor at Cyberfund. Welcome.
So,
yeah, hello everyone. So we're going to have a panel about incentives, the use of incentives in decentralized AI. I'm going to talk about money, about how to incentivize people, machines, and artificial intelligence. So yeah, I suggest we start with the round of introductions, and yeah, please introduce yourself briefly.
My name is Greg. It's late in US, so you know my circadian rhythm hasn't quite caught up with the Eastern with the time zone. Anyway, my name is Greg. I'm the founder for Akash Network, CEO for Overclock Labs. Akash is the world's first supercloud, and with a focus on accelerated computing. GPUs is the bread and butter for Akash now, considering the demand for GPUs is just increasing without the supply chain improving. And Akash is now the only place to get on-demand high-density GPUs anywhere on the cloud, and that doesn't seem to be changing anytime soon.
Hey, I'm Ben, co-founder of Jensen. Jensen is a very low-level machine learning compute protocol. So we sit just above GPUs, TPUs, CPUs, any device that can do machine learning training, and we provide access to those devices via our infrastructure, essentially. So kind of differently to Akash, we commoditize the compute itself and change the sort of interaction from ML engineers and researchers from finding access to a specific GPU and booking time on it to just running ML ops on something. So you're submitting a machine learning training task. You want to train an AI model. You don't care about the device. You just want some kind of infrastructure where you can submit that task and somebody somewhere in the world will train it. Maybe it trains on one NVIDIA H100. Maybe it trains on 1,000 MacBooks. You don't need to know as a user. You just need to know that there's some kind of rails to do that on. And so that's what Jensen is. A tiny bit like TCP/IP, but for a new kind of machine learning future.
hi folks, I'm Carton, the co-founder for Aura Protocol. We are building the decentralized AI on Ethereum. So we have two major products. The first one is called OAO, On-Chain AI Oracle. We use optimistic machine learning to enable decentralized inference for smart contract on Ethereum and its L2. And so that will enable a lot of use cases like AI GC NFT and AI DeFi and some AI on-chain gaming. And another major product we have is called Initial Model Offering. We tokenize AI model on blockchain and then do the revenue share for the AI model. After they do IMO, we will make it as like an AI Oracle. When AI Oracle makes fee, the revenue will share with the model token holder. Yeah.
Hello, everyone. So I'm Alex. I joined the DSM Foundation about a month ago. And essentially, I work on formal verification and AI and the intersection of both. I guess we're not actually, well, we have a product which is Ethereum, but we're not really building AI on the layer one at this point. But we're paying attention and keeping an eye out for anything that's relevant to us.
Yeah, thank you. So, Greg, maybe we'll start with you. You've been doing Akash for quite a long time, one of the biggest decentralized compute networks today. And I just want to ask you to share some of the learnings regarding incentive, the use of incentives. So what does work, what doesn't work, what was maybe some of the largest failures or problems that you had to overcome while building Akash? Can you share something?
Yeah, so Akash hasn't enabled incentives on-chain yet, and the reason for that is you do not want to have incentives without verification. If you do so, you'll end up into situations that you really don't want to be in, right? And we saw recently with another network that enabled incentives without verification, they got Sybil attacks to death, right? So Sybil attacks are very, very real. Every time there is money on the line, you want verification. And it's very hard to verify general purpose compute, right? Where you don't necessarily, from a platform standpoint, have access to the source code to verify the runtime or whatnot. So we are working right now with hardware verifications using trusted execution environments, which I was vehemently against it, but I kind of gave up my fight and I started accepting TEEs as the way to go. But TEEs are not not generic across different boxes, so you get into this, edge cases, and you get into situations where you really can't work out. So future of Akash verification is TE now, and there's a proposal out there that we'll be enabling very time soon. And second lesson is you don't need on-chain verifications to start off with. You can do off-chain. You don't need on-chain incentives. You can always do off-chain incentives, right? And I think that's where you get the flexibility of governance. So we do have a pilot program now with a very well-defined membership requirements and distribution requirements and whatnot, and that's running really well. One of the best things about this pilot program is, it's a controlled environment. So before you can go on chain and go the scalable and all the craziness, you get to study the patterns and the behaviors of the incentive receivers, right? And I think that gave us so much valuable feedback in terms of how we should design the incentive program instead of sitting in a dark room and deciding what the incentive program should look like, right? And third is, when you look at incentives, in crypto we have this notion of homogeneity. That means you don't really think about how to optimize your incentive design, but rather go with the original incentive program that Bitcoin introduced. That we just need to give block rewards for every block instead of really thinking through what this block reward should look like. And when you incentivize, in the token that's native to your platform, that token tends to be a volatile token, and then incentive distribution happens to be irregular and doesn't really make sense because you're most probably likely incentivizing real-world assets like a GPU or a CPU, which are priced in US dollars and not priced in your token, right? So really think through what you're doing in terms of how are you allocating incentive budget to these behaviors that you're incentivizing, and just don't go broad and saying that you're going to get X amount of tokens without realizing what the value of these tokens are. It is it's such a privilege to have access to liquidity in crypto, but it's also responsible on the protocol mechanism designers to understand what that means in terms of your expenditure for incentives, right? And fourth is go as narrow as possible instead of going broad. We learned a lot of lessons there. If you have broad incentives that doesn't really fit a particular behavior that you want to see, the likeliness of that behavior coming to life is very low. So being extremely narrow, being extremely prescriptive is what we learned is a significantly better way. For example, if you want to incentivize a certain chipset for A100s, for example, the way it works in Akash is we have, every time you reach 50% utilization for a certain chipset, the rewards or the incentives to double the capacity are released. So that way you're ingrained completely in utilization and not just going for large numbers, because it doesn't make sense to have large numbers without utilization, right? So for example, if you have 100 A100s and 50 of them gets used on a 24-hour period, the incentives for 200 A100s gets released so that, people with capacity can actually, list their capacity and keep it on the network. So that way you have a significantly better and more disciplined distribution curve instead of just a broad, hey, incentivize everything and get thousands of GPUs that no one really uses. So lots of lessons there, and we took the lessons and now we're putting that on chain. And if you talk to me in a year's time, I'll tell you what lessons we learned of on-chain incentives for resources that are priced in real-world dollars.
Thank you. very insightful. Ben, question to you. So I want to ask about crypto economics, and you touched a little bit on cryptography part, but there is this criticism to decentralized AI that it is not as efficient as centralized data center pre-training or inference. And so why do you think that decentralized AI will beat centralized compute economically long term? And what are the drivers? And what of that do you plan to implement at Jensen?
Sure. One quick point on the previous question, though. I think there's, if I could just jump on what Greg said with the point that incentives aren't the product, I think that gets forgotten in the crypto space so much. Like we spend, and lots of projects spend lots of time constructing these incentive mechanisms, and it quickly becomes the fact that that's what they're beholden to. They've built these incentive mechanisms, they've got users for those incentive mechanisms that are only there for those incentive mechanisms, and then they continue to build based on the feedback of those incentive mechanisms, and they actually just build a product which is only an incentive mechanism. It doesn't do whatever it was originally intended to do. The point of an incentive is typically bootstrapping. It's a kind of tool that you can use to create a market where one doesn't exist full stop, but it's a very kind of tiny thing. And as soon as you do it, you create a proxy of the real value transaction that you want to make happen. That proxy is not going to be the same. So if you keep iterating on it, you go in the wrong direction, basically. So it's something that you see repeated time and time and time again, and is why Greg was saying the verification is so important, right? Because if you don't have that, people are just going to come in, they're going to game that incentive directly, because why wouldn't they? They're financially rational actors, and then you've built a thing that just is gamed by those people. So I wanted to say that very quickly, incentives aren't the product. Jumping onto the question you asked me, though, why would decentralized AI be viable, basically, against the kind of efficiency of centralized AI? Two kind of big reasons, in our opinion. So one is scale, and the other is access, competition, price, whatever you kind of want to call it. But generally, the scale piece is, right now, as we're building models, the models that we all see are things like GPT, Llama, these huge models built by the hyperscalers. Those are effective. They show us what's possible with AI, and they're built with brute force scaling, which is just throwing GPUs at them in the most centralized, easiest to perform way. You can see that with most technology going back in history. We do the kind of like easiest way of making it effective to start, and then after that, we look at productizing it and making it efficient, generally scaling it beyond that kind of limit that we've achieved there. We think AI is either at or rapidly approaching that limit from a centralized perspective. And you can see this reflected in the hyperscalers with the research they do. So they're moving from how do we just make a bigger model and add another 1,000 GPUs in the same data center to how do we build a model over 2 data centers, because we have multiple, and we can actually access more GPUs if we do it that way. And they research these communication mechanisms which allow them to train models over multiple data centers. Jensen's view is that you just keep extrapolating that out. You scale it up and up and up to the point where we take off the scaling limits. We set the kind of limit at humanity's GPU supply full stop, and it's CPU supply, it's TPU supply. We do that through these communication mechanisms, and they are effective, they just need more research. So that's one of the pillars that Jensen works on, is research of how do we improve the communication efficiency of models so that we can model over theoretically every device in the world instead of one data center and then maybe one more data center added in. So that's the scaling piece. The second piece is the access piece, which is right now it's just very hard to get GPUs, TPUs, CPUs, etc. They're usually concentrated within a small number of companies, either the hyperscalers or the oligopolistic cloud suppliers. There are many more devices out there in the world that could be used, but people just can't access them. There's a big divide between the person who just wants to train a model and the person that has a device that could train that model but has no idea how they could become a cloud provider. So if we can build an infrastructure which just connects those two, it takes out all of the weird administrative costs of being a cloud provider, like KYCing people, like building an infrastructure to take a model over to that device, like a payments infrastructure, etc. If all of that is sorted, then any one of us could be cloud providers at any point in time. All of our phones in this room right now could be training small pieces of model. If you combine that with the first scaling piece, then you get a completely new way of doing machine learning, and that's the thing we're excited about, rather than just saying, can we make GPT slightly bigger?
Yeah, thank you. Carson, and you mentioned that you're building this product around initial model offering, so people are able to tokenize their machine learning models and essentially get paid for doing that. And my question is about how is it working for you in terms of experience, like how is it working right now, and where do you see the most applications? Because traditionally in AI, like machine learning companies, they build these models, then sell API, and that's the business model. How do you see distributed ownership over the models?
Yeah, thanks, Greg. So decentralized AI is not a future thing, it's already here. So initial model offering solved a really important way, a really important problem for our civilization. So have you think about why we have not seen any alien, right? Like, do you know why we haven't seen any alien yet? What do you think?
How do you know?
They know.
Didn't notice yet.
Okay, so the thesis here is that one of the most convincing thesis is like there's a grand filter for our universe for different civilization. So once a civilization develop a way to have an industry, have information technology, it's really dangerous for them to kill each other, or like they don't have the chance to go to the space or something, right? That's the grand filter. Like, because most alien, most civilization, they're probably just like our stage. They cannot reach out to each other. And so the grand filter is really hard to escape. We need to have a really strong and really efficient system of protocol for our civilization to escape the grand filter before like our civilization and ourselves. So one of the biggest problems I observed today is that open source AI do not have a way to keep their flywheel spinning. It means like once you spend few $1 million to build an open source AI model, you're not gonna make anything back in your hand. So which means you don't have extra resources to build the model better. So it's really bad. So like everybody is trying to hide their own model, hide the way they build it, how the knowledge they have, right? So it means that everybody are separated. So it decreased the velocity for us to discover the new knowledge, to develop the new technology, develop the new AI system to help our civilization to escape from the grand filter. And so for initial model offering, like we tokenize the AI model on blockchain, so that everybody, like all the open source AI creator, once they publish their AI model to the world, like they don't need to worry about somebody just copy the model and like run the model without paying them. No need to worry, because like you already have the token, you already have the credibility, you already have the social consensus for the AI model that reflects on the token. So the first IMO we did is called Open Language Model. It goes really well. Like 1 week it goes 60x in the price, and also there's multiple teams in the world. After they buy the token, they work on the model. So like a few days ago, the chat ORM model just got published in Hugging Face. Because the originally open language model is just like a base model. You cannot really use it for anything. It's a base model. It haven't been fine-tuned by anything. So now, if you go to chatorm.com, you can see that they already have the chat ORM model that fine-tuned it. It's not by our team. It's just like, I don't even know who they are really. And then they are just like some anon in the world. They just like buy the token, and they want to empower the token price, so what they do? They just like build a product and make the model better. So I see the flywheel here begin to spin. It's like an open source AI flywheel just begin to spin. It might be slow, might be the model still worse than Llama 3, but it's okay. It's okay. The flywheel will spinning, and then we will increase our velocity to develop our technology to escape the grand filter. So that's my thesis like for the IMO. Yeah.
Thank you. Alexander, so as I understand, you're doing research at Ethereum Foundation, right? I wonder, like a lot of things in Ethereum are ultimately about mechanism design and incentives, issuance, proof of stake, MEV, all these important things. And when we are talking about AI, decentralized AI, it could be compute or models or data or agents or multi-agent systems. What are these learnings and what of the things that already exist in what like Ethereum already invented or actually implemented can be applicable and useful? And also, can you maybe share a little bit more about your overall research thesis in regard to decentralized AI?
Yeah, I'll start with the latter part since that's a bit shorter. In terms of my research thesis there, so I mean, my main project at the moment is mostly focused on improving the security of ZK VMs. And so we're looking at if we can get some, good kind of AI tooling and some help from AIs to basically work on that, because it's long and tedious to try and formally verify everything. And that's maybe less kind of decentralized, AI. It's more just kind of looking at what's out there and trying to use it. And there's a big portion of that is obviously where we can get fine-tuning, our own models and things like that. So there's a share of at least open source AI. To come back to the first part about incentives and what we can learn, I think something that's quite interesting around incentives is, and maybe kind of Ben alluded to this, a lot of people put a lot of effort into trying to design the perfect incentives, and then despite all these, incentives and mechanism design, the token is worthless. But something that's also quite interesting is that incentives can work in ways that are very different to what you would like. A lot of the times you can model a game, define some utility function, find the equilibrium, and it all looks good on paper. And then in the real world, actually, the utility function you defined isn't actually what people have in mind. And you actually have incentives that come from outside your system. So one of the first papers I worked on when I was doing my PhD actually was unrelated to the AI, but had an interesting point around incentives, which is that you could write a smart contract in Ethereum, and a Bitcoin miner could mine an empty block on Bitcoin, store that chain, and submit a proof to the Ethereum smart contract that they'd done an empty block and get paid in Ethereum. And so whatever incentives you define for Bitcoin, you could subvert them from Ethereum. And I think that's quite true for a lot of incentives, because whatever you're trying to model is in a vacuum, and once you deploy it on chain, whether that's Ethereum or something else, it's no longer in a vacuum, and you have a lot of people interacting with it. You've seen this with airdrops as well, where airdrops sound like a good idea. Now people are airdrop farming, and it's a bit nonsensical. So to some extent, actually, I feel like with the way that AI is going at the moment, and a lot of people being very excited to contribute to it, I don't think there needs to be that big of a focus on reward mechanisms, because you already have people contributing basically altruistically just for the fun of it, or because they get a job out of it. You probably don't need actually to pay them that much. And if you start actually trying to give payouts for data or for models or things like that, maybe actually, people trying to game the system and submit really terrible data and poison your model. So it's quite hard, I think, to really think about what incentives you want to put in place and how to put them in place without encouraging bad behavior that would detract from the already massive amount of good behavior that we have. You can go on Hugging Face any day, and there's people doing tons of good work. And maybe they're getting paid from their job, maybe they're doing it as a hobby, but it's already happening without, I think, the need for additional incentives at the moment. And I think the same is true for compute as well. If you look at something like Bitcoin and proof of work, probably a lot of people would try and run proof of work back in the day when it was cheap, just out of interest for Bitcoin. But it wouldn't be secure against a state-level adversary or mega corporations that could come over. So you have to introduce a reward mechanism. But then once you do that, you have people, running these kind of massive mining rigs and building big companies, and actually your reward mechanism slowly turns into a massive cost of entry for anyone who actually wants to contribute to Bitcoin. And so again, because we already have a lot of people contributing, I think maybe the best incentives we can have is reducing the barrier of entry and making sure that people who actually do want to contribute can do so. And maybe, for data, that's giving better guarantees or better transparency around how your data is used. That your data might be used to train a model, but won't, otherwise leak on the internet. Maybe making it easy to contribute models. Maybe having, just kind of initial model offerings is a good way of doing that, so that people can kind of do the work that they want, and then they get paid after. And hopefully, training a model is hard enough that you don't get a bunch of trolls training, the worst models on earth and trying to sell some kind of meme coin token initial offering or something out of models. I don't think we need a kind of dog with hats AI model at this point. So I think that's what I have in mind, I think, around incentives. Is mostly trying to maybe not so much try and find reward mechanisms for people, but actually try and figure out how to make the best use of the people who already want to contribute and are contributing, and maybe rewarding them down the line, but a lot of them are already being rewarded because they're, people are finding jobs, working on cool projects, and that's why they're doing it. I don't think you need to maybe define, kind of payouts and things like that if people are already happy with what they're doing.
Yeah, so we discussed the use of incentives to motivate certain behavior, to block or stop from malicious behavior. I also really like the point about like not over-index on incentives. If you're doing only incentives, that becomes your main product, as you guys said. And now I have a question just to the panel. I want to talk a little bit about the future and specifically about composability. I think one of the main benefits that on-chain AI brings is it basically reduces the friction of connecting multiple systems. Like sending money between smart contracts is much cheaper and faster and easier than doing it between banks. So if we apply the same analogy to AI, like maybe an AI agent that makes money and then pays for its own compute, and then that money goes into training and creating better agents. So if anyone has any ideas or you just want to brainstorm or share something about how can on-chain economy enable composability and therefore faster and better and more powerful AI systems in the future.
Yeah, happy to jump in on it. It's really strong believers in composability. Like we think that the future is for AI and decentralized AI, but I see them as kind of the same thing, given that I believe that AI will inevitably be decentralized. I think it has to be done in that modular way that you described, just because there's too many resources underneath that need to be combined in order to make any kind of useful AI system. I think at the end of the day, you need to find a very, very clear use case that actually has value to somebody in the world, and then use the kind of core building blocks that we have to build models to solve that problem. And I think a lot of the talk that we see right now around like AI agents and things, it is a predictor of what the future is going to be, I think. I think we are going to have agents. They're going to be acting on our behalf. They're going to be kind of sent out into the world as sort of like shadows of us, and they'll be interacting with each other, etc. But I don't think we're ready really to build that right now. And so a lot of the talk about building it right now, it's interesting proofs of concept. It's an interesting view into what it can be in the future. But realistically, I think we have to just solve some actual real world problems with the kind of hodgepodge of infrastructure that is built right now and is currently being built. And gradually, in the usual way of like progressive decentralization, feed in the kind of decentralized and better resources that sit underneath that. But I think the space at the moment is getting a little bit captured by like what can be in the future and lots of kind of POC building. But I would like to see it go back to let's solve some actual real world problems.
I think like the decentralized AI have like a native use case on blockchain. Like, so when I start Aura, like, because we use the OPML to have the decentralized inference on blockchain for smart contract, right? So I have a thesis is that like AI is going to disrupt, innovate the whole space. Every sector in crypto are going to change by AI, change by decentralized AI. Because when you want to use AI on blockchain, it's like really dangerous to use a centralized one. Because like, when you, for example, if you use AI model become your landing decision maker protocol for your AI DeFi, then it means like the AI compound, for example, like if you have a centralized server control everything, control all the inference, then it's really hard for a lender to believe that you are not cheating on the model, right? And also it's dangerous, like if the model server got hacked, the whole DeFi protocol got hacked. So that's why we need Chainlink, like for traditional price fee oracle, right? Like you cannot just have a centralized server to just provide the price fee to like a smart contract on DeFi. And same for AI DeFi, I think like you need like a decentralized inference that's verifiable so that you'll be able to have like an AI compound that can actually, what the value for AI compound, right, is like it increase the capital efficiency on blockchain. Because like if you open compound right now, there's only 2 assets can be used on compound. One is like a ETH, another is a USDC. Then like, but you have like thousands of different assets on blockchain every day. Like how I can land this, like how I can categorize this new asset, right? Like it's so inefficient if you use like traditional mechanism on blockchain, the traditional compound mechanism. You have the DAO voting for a new asset. They're gonna take forever to run it. The second thing is like even if it's probably not accurate. So what if we use an AI model that can like identify what's the rate for this new asset, how much money they can borrow, and all kind of thing. If this kind of thing, it can be, it's like open-end problem, but it can be optimized by AI model on blockchain that's decentralized and verifiable. And so that's like, I think the real use case, right? Like when you have a decentralized AI on blockchain, you'll be able to have like this AI-based DeFi, AI-based NFT system. Like probably not just like AI compound, also we have like AI market maker that is not just X times Y equal to K, you have like really complex market maker, like AI model that behind the swapping, so that it will be like safe and increase the capital efficiency on blockchain.
Well, the challenge with bringing AI on chain is AI is non-deterministic, right? Like what, I guess I want to hear some of your thoughts. And how
you mean how to make like AI make no mistake?
Like how do you mix determinism? How do you maintain determinism when you bring AI on chain or inference?
So it's just like a technology that we use called OPML, optimistic machine learning. So pretty much we convert the AI inference like trace into a Merkle tree. So like the proposer proposed this AI inference with the Merkle tree, and the challenger will be able to like, if I see you're doing the inference maliciously, then I will be able to like challenge you. And then like how I challenge you, right? I run a binary search between the proposer and my own challenger's Merkle tree. I run a binary search. And once I locate the difference, right? If, for example, if you are proposer, I'm challenger, you're telling me that 1 + 2 = 4. And I was like telling you that 1 + 2 = 3. Then, okay, it's fine. We don't know who is right, right? Then we put it in a smart contract and have a smart contract to compute this certain bytecode. And then the smart contract can identify. Because like for the challenger, they just need to prove the proposer only one piece of the bytecode are incorrect. So we'll be able to tell the whole rest of the inference are incorrect. So that's the mechanism.
That requires determinism, though, to Greg's point. You can't do, because that's essentially auditing the process itself. You need the process to have been done entirely deterministically, and if it's redone on a different piece of hardware, you need reproducibility as well, which is
That's right.
Exact bitwise results identical to the original results. That's quite hard to do.
Yeah, that's hard, but it's possible, and we already done it. And the new version for OPML will be launched on December this year. That like we also conclude a paper result from Dan Bonnet and his student, like the optimistic AI training paper. It pretty much used the roundout for every layer when you do the inference, because the majority of the undeterministic factor from AI model inference is come from two parts. It's like from parallelization, like and the accuracy for the flow point. And so like it's for every time you do an inference go through the whole AI model, we will round up like every layer inference, so that we'll be able to make it like deterministic, so that people can challenge that.
That does work for CPU, but GPU is a lot harder.
Oh no, that's for GPU. So the OPML version you have that we open source a year ago, that is for CPU only. And the one we gonna open source on this December, I guess, that will be the GPU. Like the GPU have the antideterministic problem, but the CPU is like really easy to solve. But for GPU it's hard. So like that's the paper about.
Yeah. Sorry guys, I see that we are out of time, so there will be next speaker here. But thank you so much for the panel, and good luck with your projects, everything that you all projects that you work on. So I hope that we'll have like incentives in decentralized AI that actually make it much more efficient and widespread and powerful, but not over-index on maybe some of the grid aspect of that. And yeah, thank you.
Thank you.
All right, we're heading into our last panel, which is the role of verification in AI. For this panel, we have Jason Morton. He is the founder of Ezekiel. We have Stephen Hilton. He is the head of solutions and go-to-market at Space and Time. We have Jorge Antonio. He is a co-founder of Atomic Network. And this panel will be moderated by Tim Corey, and he is a partner at Lightspeed Faction. Welcome, everybody.
Thank you.
All right. Good evening, everyone. Well, yeah, the topic of this panel is the role of verification in open AGI. We'll get into what that means, but first of all, it would be great if everyone could please introduce themselves. Maybe, Jason, could we start with you and then work?
Sure, I'm Jason Morton. I was, until very recently, a professor of mathematics. Worked on the original DARPA deep learning program in 2011, and also various crypto things since then. And a couple of years ago, I've got to combine those interests in Ezekiel, which is a system for verifiable AI using zero-knowledge proofs.
I'm Steve Hilton. I'm the head of solutions at Space and Time. I actually worked with the two founders. We all came from a company called Teradata. It's a big data vendor out in space. Got tired of playing around with Web 2 and decided to bring that paradigm to Web 3.
Yeah, and I'm Jorge Antonio, CTO and co-founder of Atomic Network, a decentralized network for verifiable AI inference. I have a PhD in mathematics. I worked as a machine learning engineer in the past, and I've been involved in the Web3 space since 2020, where I've worked as a engineer and researcher in topics such as consensus, applied cryptography, and ZK. Yeah.
Cool, thank you guys. Well, we're going to try and ELI5 this, so I want to break this down into question words. So I think the first place to start is, what is verification? What does that mean to each of you? Feel free, whoever wants to jump in to do so.
I guess, I don't know, we all want to go at once, or no? I mean, verification, I'll answer it from the non-mathematical perspective here. I'll let you guys, you seem like you got the math covered. Verification is really about trust, right? It's verifying that the work done is as appropriate. Not to say that it's done right, it's just done as expected. At Space and Time, we have a piece of cryptography, a ZK snark called Proof of SQL. That's the marketing name, Proof of SQL. It's a way that we can produce a proof that a query run on our platform, the query itself and the data that it ran on has not been tampered with, and then we produce that proof and hand it off to a verifier. It's that verifier that their job is to check that what we did is in alignment with the expectation of our user, right? We have our own verifier network, but usually you want the prover and the verifier obviously to be different. So I'll just, like, from a very high level perspective, it's really about trust, and not just trust, but being able to say, everything was as expected from the user.
Yeah, I totally agree with that, and I can give you the perspective on how we see a verifiability verification at Atomic, and it's really about, like, whenever you are requesting, say, AI compute from some machine that you have no control through some API or through some decentralized network, how can you have a guarantee that the model that we requested to run the inference actually did the computation, right? So, for example, I don't think we can, for example, know that if I ask a question to GPT-4 and I'm paying for the API fees they provide for GPT-4, we don't have, I mean, we expect that the answer is actually produced by running GPT-4 on my input prompt, but it could be that OpenAI, in order to optimize their costs, their fees, they can actually route it through some less capable model that can give some reasonable answer. But in some cases, it might not be as good as I would expect by running just GPT-4. And this phenomenon is more important when we enter in the world of decentralized networks, because now nodes, they are not necessarily entitled to some company reputation, some national regulations and whatnot, right? So these nodes, they can do basically whatever they want to kind of optimize their costs, and they can be claiming that they run a very powerful model, like 70 billion model parameter, but at the end of the day, they are running just a 7 billion model parameter, and they are not producing such a like a consistent and good answer.
Okay, awesome, thank you. What about
Yeah, sure. It's more or less the same story. I like to think about digital signatures. I think of zero-knowledge proofs as generalizations of digital signatures. There's a setup phase, like creating a public-private key pair. Similarly, we create a proving key and a verifying key, and then anyone can prove, I used this model or a model that has this commitment on an input that has this commitment, got an output that has this commitment, and the verifier can believe it with the same kind of certainty they would believe that someone signed a transaction using ECDSA. Of course, there's a social element to that, which is kind of what is the right verifier, right? So we make verifiers you can deploy on Ethereum. It gives you a nice kind of way of thinking about what is the right contract. But that notion of what is the right contract or what is the right verifier is really a social consensus problem. And so that's something that the math sort of can't directly solve for you, and your system has to think about.
Well, that's the thing I want to ask about, actually, because I can run a query through GPT-4, and GPT-4 can be confidently wrong. But I could have a proof, a ZK proof. So what does a ZK proof really mean in that context?
Yeah, I mean, it means that the model that you promised is the model that ran. It doesn't mean the model is right, but it's it's proof of execution. And
I'll absolutely. We're working with a couple large enterprises. If you're curious, I don't know if I want to say it up here, but I'm happy to share offline. To do verifiable LLMs, which is really like, there's the compute side of it, but that use case is more about feeding the correct verified data into the LLM for training, right? So as a use case, imagine like we're in Europe here, imagine you have a large organization, you have a corpus of legal documents that you want to put into an AI and ask it, is this GDPR compliant? Or what is my GDPR exposure, right? To do that, you don't want your LLM trained on Reddit, right? Like it's going to hallucinate. And so in that particular use case, you want to have a data set which is only GDPR and that you can verify as only GDPR, right? Because then you can't, it's not going to prove that the answer is absolutely correct. That would be on the processing side, right? But on at least you can say, we can verify that it's not going to hallucinate anything from Reddit because somebody went off on a rant, and now that's what you're basing your legal AI on.
Yeah, and I think that's actually a very good point, because it's important that we make a distinction between what we call verifiability and model integrity, right, in this case. So model integrity is actually have some sort of assurance that given a prompt, the model, if it's run correctly, will provide you with an answer that actually makes sense for your use case, for your situation, right? And this is definitely a great example, but in general, this is a very difficult problem. It has usually typically for these large language models, you don't have control, or you cannot like kind of attest all the training data that was fed into the model. So for example, Llama 3 has been trained on 15 trillion tokens on the internet, right? And I think this is like, there are some rough estimates that this is around like half of the content on the web in a way. So it's kind of like unfeasible to attest for all the data in which case. And so I think this is a very difficult question for this general purpose large language models, but when you kind of you kind of reduce the context in which you want your LLM to operate, in for example, the case you specify, then actually it makes a lot of sense, because now you can have control of the data that you fed into the LLM. Yeah.
Cool, makes a lot of sense. So I guess we've got, to summarize, verification of data, verification of execution, and then this concept of model integrity, which is slightly different but related. Okay. Next question I want to get into is, why is verification important? is it always important? Is it more important for some things than for others?
Yeah, maybe I could start with that. So this is an incredibly difficult question. I think I like to go back to, if you look at these accounting ads from 100 years ago, when you're trying to convince people to go from paper to adding machine or adding machine to computer, it's very similar, right? They're like, oh, we have this accounting department. It's fine. I trust them. They're really good. And then you're trying to convince them that they should switch to a computer, and the language they used to make that sale was very similar. They talked about proof a lot, right? Like, you need not something which is just fast or accurate, but you have to have proof that it was true. And they felt that the computers at those times, just by using a computer, provided that proof. Of course, we can provide now a much higher level of proof. I like to think about it as something like a cryptographic audit that has 100% coverage and perfect confidentiality. Something that no accounting firm could ever provide. And that's a pretty powerful concept. However, it's expensive. Today, it won't be expensive in 5 years because the rate is increasing very quickly. The speed of these things is increasing 1 to 3% a day. But that proof works best in adversarial environments. So you're worried about fraud. Blockchain obviously is super adversarial because you're letting someone untrusted run a computer or run a computation for you, and they're going to try to steal your money. I think in cybersecurity, it's also an adversarial environment. I think in situations where you have a contract with the provider and you have human oversight, it's less appealing.
Just quickly on that, and then I'll give others a chance to jump in. You talked about cost. What is that cost differential today? And presumably there always will be a cost differential, but it gets smaller over time.
I don't think there'll always be a significant cost differential. If you look at GPUs, you get double every sort of 2.5 years. And we're looking at, like I said, around 3% a day improvements in ZK. That's going to catch GPUs pretty fast. I think long run, we're looking at maybe 30% over. It's going to be like ECC RAM. Just runs in the background. It's a little slower than unchecked RAM, but mostly you don't need to worry about it.
Okay, so it's not thousands of times more expensive.
On the long run.
And I was going to say, I mean, that's a great point. It's really securing the value, right? The guaranteeing the value. And so really, if your cost of securing it's more than the value, then it doesn't make any sense. And so it's going to be a sliding scale, right? And like you said, it's going to get cheaper over time. Which means that it will be more pervasive over time, the use of verification. And then there's going to be a whole class of use cases. It just doesn't make a lot of sense. If you're making a video game, right, you may even be moving in-game currency, which may even be tokenized on-chain, but does it really matter that much? I mean, eventually, maybe it becomes so ubiquitous that, hey, why not? But I think that's a long time out.
Yeah, so I actually have to disagree here. I think we need verifiability whenever we don't want to trust on some centralized API. So for example, we have seen a lot of discussions around decentralized physical infrastructure, DeepIn, that we want to use for a bunch of use cases, including AI. And so if we want to rely, instead of wanting to make a call to OpenAI API, I actually want to use some decentralized network because it might provide cheaper costs and whatnot. I'll argue that in that case, you always need some sort of some verifiability guarantee. That said, there are plenty of applications in which we can use decentralized AI and verifiable AI, and I will argue as well that certain applications require very high trust guarantees, very high verifiability. Others, they require mild assumptions. So for example, if a DeFi protocol wants to have access to some AI functionality, to take into account fund management, whatever answer the smart contract gets, it should have a very high trust guarantee, right? And that will require high verifiability. You need to run this through either a ZK proof or a trusted execution environment that's a station or like some consensus protocol like what we do at Adoma. And in all these cases, you might have to pay a higher amount to have access to this verifiability, to these trust guarantees, right? On the other hand, so for example, if I'm playing on a game and whatnot, or just interacting with some chat application, I don't need those very high verifiability guarantees. But I would argue that you still need to have some sort of like guarantee that you are paying for what you get, right? So it might be the case that like the AI provider is not using the model that you requested to, and even though you might be happy with the answer, you could have been paying less to get like the type of output you are getting, right? And so I would say verifiability in that sense is also required in a way to kind of entrust that all like the nodes in the network, they actually are running the type of AI compute that you requested to. Otherwise, you could just basically, you are paying an extra amount that you will not have to. And so also just to finalize here, on the cost side, for example, on Atoma, we have developed like this consensus, sampling consensus, in which in a lot of cases where you don't need these high amounts of verifiability, we can just run inference with a single node in many cases, and from time to time with some given probability, we select some more nodes to attest for the result. It actually can prove that you have some Nash equilibrium, and the advantage of this is that you can run, say, 90%, 95% of the requests with a single node at native cost while still having verifiability.
Awesome, thanks, George. And I was just going to say, yeah, disagreement is good. In general, the spicier the take, the better. But yeah, that gets us into, I think, sort of the different approaches that are there. You've got zero-knowledge proofs, crypto economic sort of mechanisms, trusted execution environments, and maybe sort of newer techniques that we're less familiar with. How do you think about the trade-offs as it pertains to what each of you are building at your respective companies?
I'll just say, Spacetime, we've kind of thrown in for the zero knowledge, right? Like our network does have crypto economic as well, but that protects you up until the point where it's no longer cost effective to not cheat, right? As soon as it becomes cost effective to cheat, then. And so there's a lot of variability. You have to get that exactly right, whereas zero knowledge is just math, right? It either equates or it doesn't. And so that covers all of the use cases there. Trusted execution that more obfuscates than verifies, right? Like I think that in conjunction with ZK is a good approach, but it doesn't actually prove anything. It just obfuscates. You can't see what it's doing, which has a lot of good value in it of itself.
Yeah, so it really depends on the type of application you care about. So I agree that ZK is ideal for any application that requires high trust assumptions because you are only relying on the math and on the developer implementation that might have bugs, but I mean, that's part of the game. I would say that trusted execution environments, they also provide you attestations that can confirm that a given computation run correctly. It's just like you need to trust the vendor, right? But the advantage is that you can actually run the computation without having to do, without having the overhead costs of like ZK or do this like crypto economics strategy and whatnot. Yeah.
Two examples that I like to bring up that I think illustrate the situation is, first of all, rollups, right? We have ZK rollups, we have optimistic rollups. There is, in fact, Oasis, there is a completely enclave-based rollup. But if you ask most people in crypto if they would trust their money to someone running an enclave on their computer, almost everyone says no, unless they're invested in that, right? And I think that indicates that we just don't trust enclaves for things that are critical or truly adversarial environments. The other example I like to bring up is the drone, right? So imagine you have a drone. It's deciding whether it's to drop a bomb on a building. It can take a picture of the building, hash it, send it to the server. Server makes the decision, sends back the result. If that's accompanied by a proof, then the drone can check if the model that ran was authorized or not. if you apply the sort of crypto-economic or optimistic approach to that situation, you're forced with a dilemma of trying to roll back the fact that the building is destroyed, which is just not possible, right? Or certainly not without, if any lives were lost. So I think these things all have a role to play. I think they have different trust assumptions, different security assumptions. Obviously, I like ZK because I think that's kind of the farthest over in terms of how much trust you get. But you do pay for that. Yeah.
Yeah, I think that's actually a super interesting example, the example of the drone. And I think that's not, it's actually a very good example. So I'm super excited about like real world asset tokenization. And I think this is possible through using smart devices. So for example, you can have like some smart glasses or some smartphone whatsoever that can actually use some AI model to check, okay, I own this, I don't know, like this item in the real world, right? And it can use ZK to actually prove that this computer vision model, object recognition actually run correctly. And then this can be minted directly onto the blockchain. And I think this could be a very interesting vehicle to kind of bridge the real world asset tokenization with blockchains in general. So I think that's definitely an example where ZK really shines there, yeah.
Makes a ton of sense. So there's a spectrum of solutions. Some combination probably makes sense over time as certain approaches become cheaper. Probably makes sense to use more of that. Cool. Well, another area I want to get into is the applicability of verification in Web 2 as it pertains to AI. I guess there's two questions here. I guess the first is, why should Web 2 AI companies care about this? And the second, which we can get into afterwards, is, does this help with some of the regulation that we're sort of starting to see in the space? So any thoughts on, I mean, really, either of those two questions would be great, please.
I mean, on the regulation front, we're in a difficult place because I think we see that ZK can solve a lot of regulatory problems in a privacy-preserving way, but their legislative side is not there yet, right? So we have to do the hard work of convincing governments and legislatures that that actually makes sense and that's good enough, and they should trust that, where the laws are all tailored to, you must find out who this person is, not you must prove that that person doesn't have, sanctioned or characteristics. So.
Yeah, I'll mention that we do have, I think ZK proofs are largely the realm of Web3 today, but not entirely. So for example, we have audit firms, right? And so Spacetime has this idea of a tamper-proof table that you can run ZK proofs on. Tamper-proof, we call it immutable. It really means it's append only because we have to collect the commitments as we ingest data, which is a great use case for Web3, but people sometimes are like, well, we have actually quite a few enterprise customers. Why is that? Well, because, like I said, an audit firm has this great tool now where as they're performing their audit, they have a place of record that they cannot change. So if they get to the end of the audit and they don't like the results, like, well, sorry, that's what they are. You cannot undo that. It's an example of something that doesn't belong on chain, because no enterprise company today is going to say, yeah, take all my financial books and put it on chain, right? But that ZK proof actually helps the audit firm, because they can go back, instead of doing a secondary audit on their audit that they have to go prove their work to their customer, they just hand them that proof and say, look, we built this as we went, and you can mathematically prove that we've not tampered with it.
I guess, sorry, really quickly, in that example, do you need the blockchain, or can you just, say you're running whatever, you're deciding who gets a loan, right? And you've got a bunch of financial data about, an applicant, and there's an AI model that decides it's a binary outcome, yes or no, maybe another outcome, how much. Do you need to store any of that on the blockchain, or can you just run the ZK proof alongside that computation?
I'll say that we do store some of the information on blockchain. It's not the data itself, it's the commitments I mentioned. So as we're ingesting that data, we're generating these commitments. And so there's no way, obviously, to take that back to the data, so it's secure, but it's a way that we can publicly show our work and say like, we as the vendor, as we're ingesting this, we're putting that out. You can always go and tie everything back, right? So yeah, we still use blockchain. I think that's a great, I mean, that's a use case for blockchain, even in a Web2 company, even though they may have no idea, or again, that's more our role as a Web3 company. But they can use that in their Web2 environment to always go back and check our work.
So it's about the audit trail is what you're saying?
I'm sorry?
It's about the audit trail? Is that right?
Yes, yeah. It's about an audit trail.
Okay, understood.
Yeah, so I really think Web2 companies will have more interest in decentralized AI overall, because I think given the current constraints on GPU markets, GPU access, compute access in general for AI pipelines, with all the overburden costs that transpires to developers and companies, I think Web3 is well positioned to kind of put forth incentives to align compute networks to kind of handle a bunch of these services at lower costs. And if that's the case, then any Web2 service will need to actually trust that whatever is running on a given decentralized network is running as they plan to, right? So it will be catastrophic for a Web2 company to actually provide some service relying on some decentralized party in the back end, and this decentralized party is behaving maliciously, right? This will basically have huge implications for the reputation of this Web2 company. So I think it will, from a perspective of optimizing costs, that Web2 services will be more interested in decentralized networks for compute, namely in AI, and therefore verification will be important in that case. Blockchains will still also have definitely a role to play, and just leveraging on your example, for example, at Atoma, we are also using blockchains not to provide to process requests, AI requests, but you use it to store commitments to the input data, right? So we don't store all the input data that has the prompt. It might have the output additional data that's too big, but we can actually commit that to the blockchains, and the blockchains in the future, I can foresee that there will be kind of this universal registry where you can have commitments for all sorts of requests that can come from Web2 or Web3 protocols. Yeah.
Awesome. Well, we are approaching the end of the panel, but I did want to ask each of you, for people in the audience who are interested to learn more, what are the best resources that you guys use to stay up to date with this space? And maybe you can also tell folks where to find your companies on social platforms or elsewhere.
Yeah, so I'll start on this one. So regarding Atoma, you can find more at Atoma_network on Twitter. We also have a website, atoma.network. On the GitHub, we are going to release our white paper tomorrow, so there will be a lot of content over there, and a lot of content around crypto and AI. I learned, in my path, I learned a lot from reading papers, and I leveraged basically my academic background. But I think there is great readings or on the web around AI, the capacities on this LLM news, everything that is going on the internet. There is an amazing Twitter account called epoch.ai that has a lot of data regarding compute requirements, growth of AI models, etc. So I really recommend to look into that Twitter account, epoch.ai. And then I think over in the coming months, and so once the space gains more attention and more traction, we'll see more blog posts and more accessible material. But I think the best way is to look out for great projects like Space and Time and is equal in the space. Yeah.
For Space and Time, I would say reach out to us, spaceandtime.io. That's our webpage, has all links to all the socials. Usually the socials are Space and Time DB. My name is Stephen Hilton. You can reach out to me directly. We have open sourced our verifier. We've open sourced our GPU acceleration framework for proofs. I would say if you really want to get involved, go read the documentation, dig into these open source projects, ours and others. If you've never run a node, because sometimes running a node for for a blockchain is a substantial amount of work, can be. Go run a verifier. Verifiers are usually pretty easy to run, and they're pretty lightweight. Like, not the prover, but the verifier. And so the more decentralized those verification networks are, the better life is for everybody. So that would be what I'd say.
Awesome. Hey, and we're at ezkl.xyz at GitHub, zconduit/Ezekiel. Best place to start there is with the notebooks. So we have Jupyter notebooks, Python notebooks. You can do everything there using Google Colab in your browser. Don't even have to install anything. That's the way most people get started with it. For more general ZK, I recommend getting a PhD, which is a lot of fun. And if you don't have time for that, there's some articles that you can get up to speed in a few days.
Awesome. Well, that's all we have time for. Please give a round of applause to our 3 panelists. Thank you very much.
Thank you.
Thank you.
All right, that is going to conclude our Open AGI Summit. If you want to hang around, there's food, cocktails, drinks in the networking room here. The speakers have been congregating a little bit outside there if you want to check in with them. Thank you very much for attending today's summit, and we hope to see you back at our next one very soon, to be announced in the coming weeks. Thanks, everybody.